The following is a conversation with Charles Hoskinson, founder of Cardano, co-founder of Ethereum, and a mathematician who's one of the most well-read and knowledgeable people on the technical side of cryptocurrency that I've ever spoken to. Quick mention of our sponsors: Gala Games, Allform, Indeed, ExpressVPN, and Sleep. Check them out in the description to support this podcast. As a side note, let me say that Charles is not just a mathematician or cryptocurrency innovator, but also a Colorado-based farmer of bison and mushrooms, a gamer, a fisherman, and a world traveler. When I asked him if he has a nice professional picture of himself, he sent me a picture of him in Mongolia with a hawk on his shoulder, meeting the Mongolian president. That to me pretty much says it all, speaking to the humor and the intelligence of a man who's bold, innovative, and does not shy away from a bit of fun and a bit of controversy, which makes him a fascinating human being to explore ideas with. I do want to say, in terms of ideas, that at least to me, cryptocurrency is much bigger than just a way for a few Americans to make a quick buck through meme-driven speculation. It is technology that enables freedom from oppression, from suffering in the world, because money is power. Mongolia, for example, was a reminder of that for me. Next day, after talking with Charles, I spoke with Wyoming Park, who's a North Korean defector and who spent time in Mongolia, as many defectors do, in her and their escape from North Korea. Her story, the story of North Korea, the story of atrocities throughout the 20th century committed by Hitler, Stalin, and others, is a reminder that the world is full of darkness, but it is also full of beauty and love, and it is a world worth fighting for in every way we know how. This is the Lex Fridman podcast, and here is my conversation with Charles Hoskinson. Let's start with a fun question. If we're living in a simulation, what programming language do you think it's written in? And maybe from a software engineering perspective, what do you think are some of the design principles that it operates under?
You know, there are a lot of really lovely papers, like one came out of MSR, The Autodidactic Universe. Did you have a chance to see that? Oh, you got to read it. It's like April of 2021. It's just brand new. But basically the idea is that the universe is like some sort of giant self-learning system that can self-evolve, almost like Gnomic. And then you got Wolfram running around saying, hey, we can come up with these like very simple rules and we can reconstruct all of reality at some arbitrary point. So I have absolutely no idea what's right. You know, I look at it kind of like a formal system, and I say, well, if you're stuck within the system, it's hard to actually understand that you're inside the system. You know, it's kind of like an object language to a meta language. And, you know, there's this thing that is outside of it, but because you're constrained and limited by the simulation, you can't really understand the nature of the thing that's outside of it. It's almost like Minecraft. You can build these redstone computers within Minecraft and simulate and emulate things within it, but you really can't go outside of that environment.
The people outside of it can formally prove that it's correct or whatever, but the creatures inside of the system can't hope to perfectly understand it and prove something about it.
Well, also the question is, it's a computation question. You know, does P equal NP? Because you'd have to be able to emulate all of these.
How long will it take?
Yeah, exactly. And so I have no clue what type of language it would have to look like, but it would probably not be anything we're used to at the moment. It'd have to be something else, and we'd have to have some more fundamental resolution of the relationship of these formal systems and how they get extended. So that's like a 22nd century question instead of a 21st century.
Do you find the Stephen Wolfram idea compelling? It's a very different way of programming, which is you set some rules, you set some initial conditions, and let it run and see what happens.
Yeah, and it's not a new concept. I mean, like the Santa Fe Institute's been doing that for a long time, and you can use it for economic modeling, and you can show that in certain cases, there's this concept of simple rules evolving into a complex system is somewhat more predictive than trying to build a complex top-down model for things. And I guess there's some analogies to these things in AI where, you know, you start with some simple things and then somehow it just figures stuff out in its environment over time, and much better than if you actually tried to model it with Prolog or, you know, something like that. So that is exciting because you get to just do a few things, let the thing run, and then see what happens. And that's a lot of fun. In fact, it got so exciting, Wolfram came to us and he said, hey, let's do an NFT marketplace. And I said, what do you want to do? And he said, I got all these universes to sell. And I said, okay, well, that's going to be fun. So we're going to set up an auction system or something like that with him. And I think maybe end of this month or next month, we'll figure out how to do NFTs on Cardano with Wolfram universes. So as soon as we can sell one, I'll give you one, and then we can all just claim that we're living in some sort of Wolfram simulation.
I don't know how much money I have, but I'm going to give everything I have to get Rule 30, which is one of his universes that he's created. One of the first ones where he discovered some interesting complexities.
I think Rule 30 is Turing complete, or is that 45? I can't remember which one.
You know your stuff.
Yeah.
Actually, I'm not sure if they proved anything about Rule 30 in terms of whether it's Turing complete or not.
Okay.
But there's fun competitions on it, which is trying to predict something about Rule 30, about the way it evolves. And so far, nobody's been able to do it. Just like looking at the middle column, try to predict as the system evolves, say anything like conclusive about the future of the system as it evolves. It's fascinating. It's both beautiful that simple rules can create that kind of complexity, and it's also sad that we can't like make perfect sense of it, like perfectly predict the future. Even though it's all simple and deterministic, we can't say something conclusive about like when the thing will end. When will this little cellular automata like evolve in a certain way, and then nuclear weapons will be invented and they blow each other up, and then it'll just be this empty 1D cellular automata.
Well, doesn't that make it fun, though?
Yeah, it's fun, but when you're trying to create, and we'll talk about something that operates the economy and the way humans transact and cooperate and fall in love and work together, then you'd like to be a little bit more formal and try to say something conclusive. If this entire universe is just cellular automata, then being conclusive is kind of hopeless, generally speaking. And the hope is, I guess, that there will be pockets of within the cellular automata where you could be predictive, where you can formally show that something is true, and then you can rely on that. You'll be resilient and all those kinds of things, even though the rest of the thing is a giant mess that's unpredictable.
Didn't they call that Laplace's demon?
Yes.
Yeah.
Well, I wonder what the demon is up to these days. Okay. Thank you for entertaining me with that. But sticking on philosophy, you've also mentioned, among others, that Bertrand Russell and Saul Kripke are two of your favorite philosophers. Maybe you can comment on what ideas of theirs you find insightful, and also what to you is the difference, because you're both an engineer and a thinker. So what to you is the difference between philosophy and computer science?
Yeah, so there's both a deeply human element to both Russell and Saul, and then there's this, of course, amazing work that they did in the late 19th and 20th century. And you can't really talk about Russell or Saul without also mentioning Wittgenstein and Tarski. Because when you actually look at these guys and you put them together, what they were attempting to do was increase the level of precision we had in analyzing both formal languages and also language in general. Yeah. And so Wittgenstein makes no sense at all to me. So there's amazing people out there that somehow can parse that, but
he doesn't make sense to himself either.
I think you're right about that. However, Kripke has Kripkenstein. He has his whole building on that, right? And he built a whole hierarchy. And at least there I have modal logic, and I have the little boxes, and I have the diamonds, and I can do a computation, and I can kind of reason about things that people are saying. But it really was all just about precision and the nature of truth, precision, the nature of necessity and possibility. And the magic of these statements is that you can then start getting a better understanding of basically how far a formal language can take you. And so that's the work of it. David Hilbert also did the same thing. And Russell, he got his career started working with Alfred North Whitehead. He was a logician, and there was this whole desire in late 19th century mathematics to formalize mathematics in a completely new and better way. And they started with geometry, and Hilbert's geometry was like a complete system, although recently we've discovered there's a few holes in that. But for the most part, it's complete, and the axioms are independent and they're consistent. And they said, oh, well, now we can do this for all of mathematics. And Russell and Whitehead wrote this huge set of books, like two big books, Principia Mathematica, 1,000 pages. And the conclusion is 1 + 1 = 2. So they linked set theory and arithmetic and logic all in these beautiful ways. Then, little by little, as we entered the 20th century, logicians started chipping away at this idea that you could actually construct a complete system of mathematics. First with Gödel, and then later with the work of Turing and Church and others. They said, oh, you're not complete, you're not decidable. And so suddenly Russell was left in this really bad position where his early life's work was basically forgotten. So he had to kind of reinvent himself. And so he went into ethics and he went into different fields of philosophy. He became this titan in analytic philosophy. And he was also a great pacifist. And he was just a phenomenal writer. If you read Why I'm Not a Christian or any of his other attacks on metaphysics, he said, look, I can only deal with the world I'm in the senses that I have. And if I can deduce it, I believe it. If it's outside of that, I really can't make meaningful statements about it. And he said it in a lovely English prose that you would expect of a man of his stature. Now, Saul Kripke, it was like the complete opposite. This guy's really down-to-earth dude, not aristocratic at all. And, he was one of those guys that just could have done anything because he's so brilliant. I guess he's still alive.
I think he's 80-something.
Yeah, exactly. Yeah, he's getting up there, man. But I mean, literally, when he was in high school, he wrote these papers in logic, and Harvard contacted him and said, hey, could you teach graduate courses at Harvard? And he said, no, I really would like to finish high school first before I go and teach grad school at Harvard. And so this is just one of those guys that you can see through his work that he can think deeply about anything. He's like the Galois of philosophy. And he chose to try to clean up a lot of the messes that Tarski and others couldn't resolve. He said, let's really get serious about the nature of truth. Let's really try to resolve paradoxes. Let's really try to build things in such a way that the work that we leave behind can actually be built upon and it's not thrown away every 50 years or 100 years. And it was the same for Tarski. He comes in, he says, we mathematicians love this concept of truth, but yet we've never really created a nice rigorous definition that doesn't have paradoxes embedded inside of it. So he had to invent meta languages and object languages, all these notions and so forth. So I really like those four if you think about them. And there's a lot of great lessons. And where it's relevant today is, you have human beings and you have computers and they're trying to understand each other. And computers live in the formal world and human beings live in the natural language world. And those bridges between those two are still not completely clear. And so a lot of the work that these guys were doing in the 20th century, 19th century had nothing at all to do with that, but gives you hope that perhaps a bridge can exist between those two worlds. And maybe there are some nice tools for that bridge to be built upon. And maybe that in some way will allow computers to better understand us. I mean, they've even created languages, natural spoken languages that are completely ambiguity free, like Lojban and things like that.
What?
Yeah, right?
Wait,
Lojban, Lojban. It's based on a language called Loglan, and it's a spoken language that's equivalent to first-order predicate calculus.
Interesting. So no ambiguities. It's logically consistent.
Yeah, Lojban.
But can you still have fun in it? Like,
you can get.
Can you write poetry or what?
Yeah, there's people who actually write poetry in Lojban.
I'm going to switch to that. And start tweeting in it.
Yeah, there you go. So there's a lot there, and they're just fun to study and think about. And unfortunately, if you go down that rabbit hole, you'll spend way too much time, and there's diminishing returns. Now, the second question you asked was one on theoretical computer science to, I guess, engineering.
Philosophy. No. So first step, you said humans and computers.
Right.
So theoretical computer science is theory of the computer, and philosophy is the theory of the human. And then we can dissect different stuff about the computer. But in terms of these two worlds of the theory of the human, which is philosophy, and the theory of the computer, which is computer science, what do you think is the difference? Like, as we try to bridge that gap, as you mentioned, what is going to be the biggest challenge? Like, can we formalize love? Can we formalize music, art, poetry, all that kind of stuff? Or is that a human nonsense that we need to get rid of?
No, I don't think it's human nonsense at all. I mean, there's even attempts to create algorithmically generated music. And, the question is love just strictly a chemical phenomena? Or is there something like metaphysical about it or transcendent of some sort of formal system? I mean, computer science is just saying, hey, we have this notion of computing. We have this brain that we've constructed, this formal system that we've built. And given that we have it, what can we do with it? And so some people worry about the roots of the tree of knowledge, the great Yggdrasil of computer science. They worry about the roots and say, how far can we grow them? And let's keep adding these new models of computation. And other people worry about the trunk of the tree, and some people worry about the leaves of the tree. And the more advanced the field gets, the closer and closer it gets to the people who constructed it, us. We have better image processing. We have better ways of handling speech to text, and we have better ways of computers kind of understanding the intent of what a human being is saying. And then the question is, well, how will a computer understand love or poetry or music? Well, it'll understand it the same way we understand it. You have to get a computer to grow up to a point where it can learn the way we learn, or as close to it as possible. Then you just expose it to the things that we were exposed with. And then at some point, the computer will start creating things. So the question is, well, how do you quantify creativity? And I have no clue about that.
But you make it into an NFT and see how much it sells for. That's one way.
Yeah.
But basically, yeah, there's so much of it is subjective. And that's a fascinating whole area of that I'm fascinated with, is human-robot interaction, is how do we create compelling experiences that are subjectively compelling, whether it's art or just two humans talking or two humans interacting in some kind of way, to maximize the richness of the subjective experience. And I think that could be an optimization problem that could be solved. We're solving it all the time.
Right.
Human civilization is constantly trying to impress each other. When we're younger, trying to get laid.
Right.
Whatever, fall in love, impress your boss at work by all the awesome stuff you do. I mean, we're trying to optimize that problem that's purely, for the most part, is subjective.
Right. Did you ever watch Blade Runner 2049?
Yes.
Yeah. Did you remember the whole relationship between Joy and Kay? You know, and like, did she really love him, the hologram, or not? Was it like fake love or real love?
Fake it till you make it is my view on love. No comment from Charles. So let's go to the difference between theoretical computer science and software engineering. Or I don't know if you draw a distinction, but if we look into this computer world now, is there a difference between theory, things you can say formally, and the pragmatic implementation of that theory into actual systems that people use?
Yeah.
Which I guess we'll call software engineering.
So, you know, the engineer, they're obsessed with the domain of, well, what do you want to accomplish and who are you accomplishing it for? So they live in the world of people, if they're good engineers. And they say, okay, what's the experience? How are we going to use this? Why are we going to use this? What's the commercial application? What's the non-commercial application? And you collect all these business requirements. And once you've done all of that, the better job you do, the more self-evident it is of how do we apply the toys and tools of computer science and other such things to actually resolve that. And the point of theoretical computer science from the software engineering domain is it can tell you kind of where your guardrails are. It won't make perfect programs, and there's no such thing as that, but rather it can give you a good notion and sense that your program has some desirable properties. Like you can prove that it can terminate if you're dealing with total programs, or maybe you can prove you'll never have a buffer overflow, or you won't divide by zero somewhere or something like that. Some event won't occur that'll cause a catastrophic failure in your system. But there's always this combinatorial explosion between what you can test and think about and what you can actually code. So the stuff on the left-hand side lives in a different cardinality, a different universe. There's something significantly larger there. And the tools on the right-hand side, we have property-based testing and these SAT solvers. We have all this great stuff here in formal methods land and computer science theory land, but there's only a small subset of things that they actually give you good answers about. So the balance of the two things is basically saying, well, what do you care about and what are you okay throwing away? That's the art of engineering and building these types of things. So, cryptocurrencies, we deal with these complex distributed systems that have cryptography and game theory and Byzantine actors. So the balance there is saying, okay, what can't fail in that system? Mm-hmm. And that's the kind of stuff that you want to apply as heavy a tool set as you can, because when that stuff fails, you either have the loss of billions of dollars, privacy, or potentially even life, depending on how these systems get adopted. But then other things, what can fail? Is it okay if the block doesn't get made, every now and then? Is it okay if your latency goes up, or your network suddenly becomes asynchronous and, you disconnect from it and you have to restart the computer or something like that? That's probably okay. It's an inconvenience and burden to the user. And if you actually try to chase that tail, you'll end up spending 10 years chasing phantoms and ghosts. And meanwhile, the whole world moves on. So it's really figuring out those balance of the two. And what's really beautiful is that the formal methods tools have gotten so much better over the last 20 years in particular, mostly because of incredibly high investments from Microsoft and Google and big universities, because these guys are building these gargantuan systems. If you look at the Googleplex or what Amazon has or others, and they have so much value, so many users, so many things going on, and no person can keep that in their head. And so you're talking about systems may have 10 million lines of code, 15 million lines of code, millions of nodes connecting, faulty processes happening all the time, hackers breaking in on a regular basis. So when you're trying to model all of that, trying to ask yourself, what formal guarantees and properties can I get to simplify this system as much as possible? So instead of the applications of formal methods slowing you down, in many cases, it actually massively reduces your debugging time and your ability to find where errors occur. In some cases, you can't find where errors occur inside these massive concurrent systems. And you say, well, where are cryptocurrencies going? We're talking about just the same thing, but we're talking about a much more hostile operating environment, where instead of it running in a pristine data center in California somewhere, it's running on your cell phone. It's running on your mom's phone. It's running your dad's phone. It's running on, some computer in Mongolia that may have good internet on Tuesday, but not any other day. So when you live in that kind of environment, you really do need to think carefully about a whole new class of protocols. And then you need to think carefully about a whole new class of tools and techniques to test the reliability of those systems. And you need to separate the world and say, what is high assurance and cannot fail? Because if it fails, people lose money. And what is low assurance? And it's okay if that falls apart. The other thing I'll mention is there are perverse financial incentives in our industry. Because the reality is when something blows up, the people who built those things that blow up usually get paid up front. So what they're focusing on is time to market, speed to market, and getting tokens out and getting them liquid. And then people come in, they buy it, but if there's a nascent bug in some DeFi protocol, it'll probably be discovered 6 months later or something like that. It blows up, who suffers? The users.
The people that created that already got paid.
Exactly. That's why you pay the guy who makes the brake software for your train last. And you make sure he rides the train every day.
So that's you're basically describing the complexity of a distributed system that's fundamentally game theoretic, and like if we think about turtles all the way down, it's humans all the way down. I mean, you at the very bottom is still human nature. Is there something you can say formally about human nature to try? You said you can't. There's certain parts of the system that can't fail. Some people talk about nuclear war in that same kind of way, that there's this game theoretic construction of mutually assured destruction. That rhymes. See, I'm a poet. That system can't fail because we're going to blow everyone up. But you can't formally say for sure it's not going to fail.
Right.
So like you're basically trying to chase, like statistically reduce the probability that these particular critical aspects will fail. And then you test, I guess, by deploying in the real world at small scale,
right,
to see where things go wrong.
Yeah, it's a great question. And, the problem with game theory and mechanism design is that you can develop this concept of a rational actor. And I don't think in my life I've ever met a rational actor. There's a rational actor on Tuesday, but, any other day of the week, who the hell knows? And there's even, I think there was a book, Freakonomics, and there's a few of these things where it just shows again and again where people behave in ways that are against their best interest. So then you have these protocol designers and they say, well, we need an honest majority for this thing to work. And they say, oh, okay, well, we'll create this incentive model and rational actors will behave with that incentive model. And they say, well, the individual won't do that, but the firm, the government, the entity will. The problem with that is we have a lot of counterexamples where the system was actually behaving in weird ways. Like we almost completely eradicated the human population twice in the 20th century. Once during the Cuban Missile Crisis, and again in the 1980s, there was a Russian colonel and they installed a new satellite system and it said, hey, the Americans are launching missiles at us. You need to turn the key and, launch all the missiles in the silo. And he said, oh, that's not right. That doesn't seem right. And he was reprimanded for not launching the missiles. So in both cases, a single person stood against the systems of superpowers between us and nuclear annihilation. So in general, we're really bad at building these types of things. So what you look for instead is say, can the system be self-correcting? It's not about avoiding a problem. It's more about, can the problem be resolved? And that's how nature engineers things. It gives you an immune system. It gives you the ability to heal. If a rainforest has a fire or some catastrophic event, the ecosystem will find a way to patch things up. So it's a better question of how do you align the incentives over the long term of a system where all the actors within this system, when an event occurs that disrupts it, have an incentive to push it back into a healthy, productive, useful state, which is going back kind of to that complexity theory stuff that we began with, and a little bit about, how do you handle modern economics? Like, for example, we knew this coming into the COVID crisis that there would be catastrophic economic disruption throughout the entire world. In the developed world, it was print lots of money and hope to God it works. In the developing world, is try not to starve to death. Over 100 million people were pushed into acute starvation, so acute hunger. It's a terrible situation. But every economist knew we were going into that. So the question is, how do you restart the system? How do you realign the system and so forth, and make sure that it doesn't collapse at some point? So it's an imperfect, inexact science, and that's actually one of the things that makes our industry so much fun. Is that these are kind of like micro experiments for the macro. In years past, you never got a chance to experiment with monetary policy. I mean, it's like every 20 years, 30 years, they'd have some conference, usually in a cool island like Jamaica, and be like, okay, let's go talk about monetary policy and like amend the Bretton Woods Agreement. And these would be nation states, invitation only. And now you have over 8,000 cryptocurrencies floating around, all with their own monetary policy and their rules. And it's very Darwinian. A lot are dying, some are succeeding. Anomalies happen like Dogecoin. And you say, God, is this temporary? Is this permanent? Why doesn't this horrible thing die? And then other things you think would be absolutely successful and just take off and be in the top 10 don't really get as much traction. Like Algorand is a great example of that. I mean, Silvio, he's an incredibly bright guy. Every time I go to MIT, we have dinner, and his work is legendary, and it's just beautiful and elegant. And he literally has all the people. He went and hired Tal Robin, and she gutted IBM Research, and Craig Gentry, the guy who did homomorphic encryption under Dan Bonet's there. There's all these amazing people on that team, and they have money and the VCs. So you'd say, okay, that's a contender. Mm-hmm. But if you look at market adoption, Ethereum Classic sometimes is above it, mm-hmm. and other things are above it. So
then there's this weird Darwinian evolution produced Dogecoin organism that's just like stomping all around. Evolution doesn't make sense.
Exactly, but maybe we're the problem, not evolution. Because the market's the market, and you can scream and cry and pout and stamp your foot and say this makes no sense, but that's the way the world works. There's plenty of mountain climbers that didn't want gravity to apply to them, and it's the same situation here. There's plenty of people in these marketplaces that had the best of intentions, the best team, the best technology, and for whatever reason, they didn't get that adoption. So the question isn't the local, it should be the long term. And will the system over time converge to a state that actually is useful and meaningful to society and actually solve problems for it? And that's what we try to figure out is, how do we perturb these things in a way to kind of push them in that direction?
So before we go into this fascinating Darwinian evolution of cryptocurrencies, let me ask you sort of a basic programming question. There's a fascinating aspect to your work with Cardano that you use Haskell as to build the infrastructure. But even stepping back more, looking at this landscape, another place where Darwinian evolution operates, looking at this landscape of programming languages. You as an engineer, you as a philosopher, both, what programming languages do you think are interesting? And more practically, what programming languages, if you were to advise like students today, should they learn?
Yeah, so there's the pedagogy of learning how to program and to express the theory of computer science. Like you have to learn how to write algorithms, you have to learn what data structures are, you have to be able to do analysis of these things. And that probably I think the debate is over. Python is probably the best language, or JavaScript to get started with, because they're very useful. The libraries are amazing. There's just tons of online materials. Even MIT is now teaching their introduction to computer science in Python. And they used to do Lisp. I mean, these guys were hardcore.
I still love Lisp.
Oh man, it's great. These are your father's parentheses. They're elegant weapons from a time long ago. But that's a great starting point. And it's not about falling in love with a language. It's just falling in love with computing. It's about falling in love with having a dialogue with a computer and thinking about, well, how would I solve that? How would I interact with that? What does this need to look like? Functional programming is what we've chosen to use for Cardano, mostly because we're living in the academic world. We've written 105 papers. And the problem is you have to translate that work into code. And the gap between an imperative language like a C++ or C and these academic rigorous papers is extremely large. Mm-hmm. And so there's going to be a lot of semantical ambiguity between those two. And what I mean by that is that you might end up implementing a wrong thing. You might think that what you've built is the paper, but the computer's not going to tell you that because the paper is written in prose and maybe typed up in LaTeX or something, but there's no proof chain, evidence chain that you can show that there's no ambiguity. When you look at a functional language, you're a little closer to math. And so as a consequence, the translation of the papers that we spent so damn long writing and writing proofs about and so forth to code is much smaller. Now, the downside is these functional languages tend to be a bit more academic, and they tend to have not necessarily the best Windows support, and the libraries aren't so good. And also, they tend to be a little slower when compared as a whole on average to languages like C, for example. So it's really a question of, okay, what are you designing for version 1? Are you designing for performance, and are you designing for developer accessibility? Or are you designing for correctness, and are you designing for a high fidelity representation of the protocol? Okay, so Haskell was chosen as kind of the version 1 because we knew that the kinds of people who think about that are also the kinds of people that would have an easy time reading a paper like Ouroboros and working their way through all of this. And they would do a pretty good job writing a formal specification and then translating that into running code. Then once you have that, you have a blueprint that you can actually reason about, maintain. And if you really wanted to, you could then turn that into a Rust code base or into a Java code base. Going the other way around would be, kind of pointless and counterproductive. The other side of it is that Haskell code or functional code tends to be significantly more concise. And I actually have a real life example of that. So if you take a look at Mantis, we implemented a full Ethereum node in Scala. It's only about 14 or 15,000 lines of code. And you compare that with like C++ Bitcoin, I think that's 120, 150,000 lines of code. So it's almost 10 times smaller. And so less code, less to read. And you tend to read code significantly more than you would write code. So it's always an advantage for maintenance, understandability, documentation, and other sort of things when you have more concise code bases. And also it's a lot easier for you to apply stronger tools to a functional code base, like static analysis or property-based testing or these types of things than an imperative code base. But the thing is, it's almost like a religion. It's like or language. It's like saying what's French versus Russian versus English. Everybody has their adherents. They say, oh, well, they have the best poetry here. Or,
Russian, yeah, wins.
There you go. Always, or Russian. Everybody has their favorite tools and their favorite languages. But it just comes down to what problems are you trying to solve and what problem domain do you live in. If you're inventing new protocols based on science, you're going to take the time to write a paper, go through the peer review process, as you've done personally. You know how hard it can be to get into a conference and go through that and get your ass kicked. Then you also have to apply the exact same level of care to the engineering side in terms of the implementation of that, or else you will make a mistake, and that mistake will probably be an exploit in the system that destroys the security properties of the system. So we really had no choice but to go to some notion of functional. The question was, what's the Goldilocks language? Do you use a hybrid language like Scala and F# or Clojure, where you still have some connection to understandable things like .NET or the JVM? Or do you go to an overly academic language like Idris or Agda or, Isabel? And in there you can really dial up the correctness and write all kinds of crazy proofs. But by the way, it's like the 7 people who write your code, they go on vacation a lot. You'll never get anything done. So Haskell kind of felt like a nice middle ground between those two, where if we needed to pull into the left, we could. If you wanted to pull into the right, you could as well. That said, it's really amazing to see what the hybrid languages have done. If I was a new student in computer science and I said, learn any language to grow your career from, Scala 3 is probably the language to go with.
Interesting.
Yeah, it's great because it's like you want it to be like Java, it's Java, and it looks kind of like a Java program. You want it to be like Python and scripted, and you use a REPL, you can do that. You want to go hardcore dependent object types and do like weird proofs and stuff in the functional, you do all that. You have access to all of these things, and Martin Odersky is a brilliant guy. He's done some phenomenal work, basically, because he was one of the guys who created the JVM, and he's worked on compilers for over 20 years. He did a lot of really hardcore work on trying to build a concise, nice, modern language that does a little bit of everything. And it's got great applications in data science and in AI. And it's also heavily used in modern companies. Like Netflix uses Scala for all of their microservice architecture.
Interesting.
Yeah, so that's a great language. And it's easy to pick up, and it's easy to hire people into it. You just find these Eastern European guys who were Java programmers for 10 years, 15 years, and they got tired of making $20 an hour, so they picked up Scala so they can make $35 an hour. And they're really good at it,
Yeah.
And that's a great gateway drug because, you have like quick check and Haskell, you have Scala check and Scala. You can also do model checking. You can also go and use a TLA spec and make it work with Scala and so forth. So it gets you a little bit of everything. And, you can then move around that entire design space in a beautiful way.
So the recommendation is maybe if you want to go vanilla, you go Python and JavaScript.
When you're getting started.
It's the getting started.
Because that'll get you everything. You can do web scrapers and anything. It's
all of us
fun.
Experiment with drugs in undergrad. That's where Scala 3 comes in. It's a gateway drug to then potentially more hardcore functional languages like Haskell. Do you think C and C++ still has a role?
No, I think Rust has completely replaced the need for them. Go and Rust, those are the two twins of doom. I mean, Google created Go just to get rid of C. They hated C that much. And then Rust is just a phenomenal language as well.
Hate can be a great motivator.
Yeah.
Let me ask a question from Reddit on this topic. We're going depth first today.
Sure.
As a developer, why should I be incentivized to create Cardano-based applications? What is on the Cardano developer roadmap? Any other language? I guess this is the key question I want to ask.
Right.
Any other language support other than Haskell? The example this person gives is TypeScript, Go, Java, Python, etc. Also, have you considered a yearly conference focused around developers?
Yeah, we call it Plutus Fest. And we did the first one in 2018, 2019, I can't remember. And we were going to do one last year, but then COVID hit. So we'll bring it back, and we'll probably do it annually at the University of Wyoming for their hackathon there. In fact, it just so happens that coincides with the Gogan Summit. So we're doing that, I think, the third week of September. But yeah, it's great to do an annual conference. You can bring a lot of cool people together, and you can do hackathons and awards and so forth. But to the question in particular, Plutus is like any other language. Plutus Core, you can compile things into it. So it's entirely possible to write a Scala to Plutus Core compiler or a TypeScript compiler or something like that. But, I'm a big believer of separation of concerns, and we don't live in a single chain model anymore. So, you have a situation where you probably want to have different execution environments in different chains. So you have different virtual machines there. And that's why we work so closely with the University of Illinois, Urbana-Champaign, Grigori Roshu's team at Runtime Verification. What they did is they said, let's start with something very familiar, LLVM, which has been around for a really long time. And they happen to have created it there with Apple. And let's take that and translate that into the blockchain space. Okay, then once you have it, then it's very easy to modify compilers of standard languages like the C's and C++ and other such things that do compile to LLVM already and have them run there. So that's a different execution model than what we tried to build for Plutus, which focuses on correctness. Okay, so then all you have to really do is say, can both of these models coexist within the same ecosystem? Because then you kind of, and I did a video, it was called like the island, the ocean, the pond. And the basic idea was say, you have an island where everything's perfect. Calypso lives there. Life is great. People feed you grapes every day, but maybe you can't do everything on the island, and the ocean's big. It has everything, but the ocean's got sea monsters and sharks and Bodie McBoatface and, all kinds of crazy stuff, right? So that's what Yella is about. It's basically this bring LLVM into our world. And at some point in the next 3 to 5 year time horizon, we can bring modern programming languages in, but they're going to come in with all their flaws and their warts and their problems. And then the pond was the idea of the Ethereum virtual machine. There's some network effect around it, and there's some great tooling that's materialized and evolved. And it's not clear if that's the standard yet, or if like MySpace or BlackBerry or all of these other things, it'll fade away. Well, if it becomes the standard, okay, don't fight nature. Just support it. And the same thing that gives you the ability to bolt on the LLVM will also give you the ability to bolt on the EVM. And they can run with their own models, and they're encapsulated, bulkheaded, separated systems, but you can move ADA, applications, information between those two systems. Mm-hmm. And so your main chain will always stay somewhat conservative and have the minimum viable amount of expressiveness required on it to do all kinds of interesting things, and also for interoperability, be able to talk to all kinds of interesting things. But it's not trying to be everything to everyone. There's never going to be an ice cream store in the island. You'll have the grapes and the beautiful women, but no ice cream.
Now you're just like distracting me with the ice cream. So because we'll throw around a bunch of terms for the record, what is Plutus?
So Plutus is a programming language. It's kind of a DSL that we built on top of Haskell. And basically, we wrote it after spending about 3 years thinking about all smart contracts. We were trying to figure out, like, what is the ideal language to express a smart contract? And then we started thinking, well, what is a smart contract? Is it the whole application, or is it just like a submodule within an application? And usually it's the latter more than the former. You can build a self-contained program like a script, but usually what's happening is you'll have it like a video game, let's say World of Warcraft or something like that. You say, hey, maybe I want to actually create gold in World of Warcraft that's actually a currency, Okay, so I'm going to issue a token. Well, and then maybe I want to create some mechanics behind how people are going to trade that amongst each other. So that would be like a smart contract layer and issue an asset. So you have this centralized server running and proprietary software controlled by a single company. But then you've opened your application up to a broader world. And what you've done now is added a blockchain layer, and the blockchain handles the accounting of that asset and the spending policy of that stuff. So that is a much smaller program than what Blizzard is doing with World of Warcraft. So the point of Plutus was, let's create a language where you can write these small to mid-sized programs and have a high degree of confidence that they behave with correctness, and also they give you deterministic results on the consumption of resources. You can run things locally, and you actually understand what it costs to run, and that doesn't change when you deploy it on the system. If you dial up the expressiveness of the system, and like Ethereum does in these big mutable account systems, the problem is you have to have global state, so whatever you test locally doesn't actually necessarily translate to what you've deployed. Okay, so we spent a long time asking, like, where's the Goldilocks zone? Bitcoin script was too restrictive, and every single time Satoshi tried to dial it up, it led to mega problems. Like, there was a beautiful thing called the value overflow incident in 2010, which led to the creation of billions of Bitcoin. They had to quickly clean that up and sweep it under the rug and pretend like it didn't exist. But that was mostly because of an issue with how the scripting language was implemented. And when you look at Ethereum, it's like this Pyrrhic game of stomping down these skirmishers, where every update there's something they have to change or tune, and then it's not clear how you shard such a model. So we said, let's build something that's in the middle of this, and that's what Plutus basically is. And it's really designed to play very nicely with off-chain infrastructure as much as on-chain infrastructure. So you can look at all those different examples, whether it's Wolfram wants to auction off their universes, or Blizzard wants to issue an in-game currency, or you're Uber and you want to start putting peer-to-peer dynamics inside your system. You're going to gracefully connect to that on-chain code, and it's very clear how those two things connect together. Just so happens Haskell's really good for this. They have template Haskell, and it makes it very easy to embed domain-specific languages, and it makes it very easy to wire your Haskell code onto off-chain infrastructure. So in the future, you'll be able to have your off-chain run in Node or the Java virtual machine or a .NET application, and there'll just be this beautiful interface, and then it can talk to all your on-chain code, and that's written in that DSL, and you have a high degree of assurance that it's right.
Is there like a hello world program in Plutus that reveals the beauty of this balance that you're referring to? Sort of simple but not too simple, the Einstein idea?
Yeah. So we did do our first Hello World program actually today, because we
I heard about this.
Yeah. But there you'd want to have the whole round trip. So you'd like to have an interaction, and I think a video game would probably show it the best. Like if we could re-implement CryptoKitties or something like that on it, and you have this off-chain infrastructure, and you have your GUI in your front end, it's running on your phone or a browser, and most of that lives off-chain. And then, but your CryptoKitties, they'd live on the blockchain. The whole round trip, end to end, with relatively low fees and low latency, and high availability of service. It never goes down. That would probably be the best thing to do, and we'll have something like that by August. It's pretty easy to build this stuff.
So, what kind of off-chain interactions are supported with Plutus? What are the limits you want to put on the thing so it doesn't get chaotic?
Well, that's the beautiful thing. When you have a less expressive model on-chain, it means you can do anything you want off-chain.
So you started talking about smart contracts, but let's zoom back out and ask the big question here is, what is a blockchain and what is a cryptocurrency?
So a blockchain is just a ledger, and really it has three nice properties. You're time-stamped, you're immutable, and auditable, either in a global or a local sense. And so there's all kinds of things mankind has invented where it's really important that when you put some information down, it doesn't change and other people can see it, and that you know when it was put down. For example, a property ledger. So when you buy land or you have rights associated with land, like mineral rights or water rights or these things, you'd like to transitively see how does it go from Alice to Bob to Charlie to Jim and so forth, and what was the state of these things as they were transitioning. So how much did they pay? When did it occur, et cetera, the metadata that follows that. Okay, well, normally these types of ledgers are so important that they're managed either by governments or regulated entities. And the issues are that while they can be efficient, they're generally brittle to political manipulation, and they're brittle to geopolitical events. For example, when Syria fell apart, the very first thing ISIS did is they started saying, hey, the ownership of the land, it's going to fundamentally change. We've decided that, this guy over here now owns all these things. And then when peace comes, like, how do you unwind all of that, put it all back together? So the power of a blockchain is that it gives you a transnational way of sorting all these details out, putting all together in a place that that even if it's inconvenient to a very powerful actor, that it will still stay preserved. This is an asymmetry we haven't had as a society. Usually kings and empires, they have the ability to decide what's true. And then suddenly you have this asymmetrical thing that is above them, kind of like a synthetic laws of physics. And once something goes in there, that that's there. Okay, so that's the first part of it. The second part of it is that it's auditable, meaning that instead of saying only the high cleric or the president or, some very special club of people get to see what's going on, suddenly now all the people can actually see who owns what where. Like imagine a tax system where, the ProPublica just leaked the taxes of all these different billionaires and said, well, how much they make and how much they pay. Well, imagine a tax system where that's just done by default, or other social systems where this type of information is put in by default. So it's tremendously useful, this type of structure and all kinds of things, medical records, supply chains. Just a good thought experiment is I travel a lot. I've been to 52 countries in the last 5 years. Imagine if I got sick in Zimbabwe, I get hit by a car or something and I'm unconscious, and a Zimbabwean doctor calls my doctor in Colorado and says, hey, I need all of Charles's medical records. He's unconscious right now. But I needed to treat him because he's quite ill. They'd say, who is this person in Zimbabwe? Why, I don't know you. I can't give you his records. I need his consent. Oh, no, he's unconscious in the hospital. I can't do it. Well, a broker system that would allow the movement of medical records would be an example of what a blockchain could potentially do in the foreseeable future. Cryptocurrency is just an application that runs on top of a blockchain, because it just turns out that when you issue property, you also can issue tokens of value. And then you could have a monetary policy. It can be inflationary or deflationary. You can have demurrage, where it decays over time or whatever have you. And the very same mechanics that would ensure your property records are secure, your medical record access is secure, could also be applied for the ownership of the cryptocurrency. And again, you can either be completely transparent and everybody can see what everybody owns, and that's what Bitcoin does, or you can be as opaque as you seek to be. That's what Zcash basically attempts to do. It says, hey, let's keep these things as private as possible. But they have relatively the same mechanics in terms of those properties of auditability and timestamping and immutability. Things won't be reversed. That people aren't going to manipulate the timestamps, and you can audit at least enough to know that the ownership is right.
But the way, if you think about physics and the universe has figured out a way to update the ledger of physics in a way where like a lot of people can be updating it and it stays consistent. Is there something you can say about the task of updating the ledger when a bunch of people are trying to do it, or a bunch of entities are trying to do it?
Well, yeah, that's the whole point of a consensus algorithm. So whatever ledger you're running, there has to be some mechanism to decide who's in charge. And that's what proof of work does and proof of stake does and all these other systems. And you break them down to basically 3 steps. And so we'll use Eve for kind of step number 1. Hi, Eve. How you doing? And we're going to use Wally for step number 2. And I need the monkey. Give me the monkey. What's the monkey's name?
Daisy.
Daisy the monkey. Okay. I like Daisy. Daisy's a Very confused monkey.
It's pondering its own mortality. Just so
right. And so anyway, the first step is all about basically deciding who's in charge for that moment. So blockchain is just a sequence of events. The heart has to beat, the metronome has to click. So somebody has to be in charge. And so generally you have this notion of a resource. So there's some pool of resource out there, and it can be a token. And in that case, it's a plutocratic system. And that's what proof of stake does. Or it can be computation, but there can be other resources. But computation is what proof of work does. And so you make so many hashes, and then eventually somebody wins. And that person who wins is now the person who basically gets to decide the order of transactions and put them all together from their perspective in the system. Then once that person wins, they'll make the block. That's step 2. And after it's made, transmit it, and it gets validated and accepted. So actually, it's quite fortuitous you have the magnifying glass, because at this stage, people are trying to decide, is what I'm looking at correct or not? Now, there are other ways to potentially conceive of this, but this particular model gives you a kind of a way of thinking of all consensus algorithms in one setting. You can be Algorand, you can be a classic BFT protocol, you can be Paxos, you can be Raft, you can be proof of work, you can be proof of stake. It's always the same idea. You have to find someone or some group to be in charge. They'll reach a consensus on order. They have to then do some work, change the state of the system, update it, and then the network has to accept that that's valid. So even if this process works well, this side will say, oh, you created a Bitcoin out of thin air. You're not allowed to do that. So that's rejected. Okay, so there's checks and balances and guards all the way through. There's a meta question of fairness in all of this. Okay, so the proof of work people, they're kind of a cult, and they say that this is the only truth, and everything out here, any other resource is not legitimate or valid. And there's not a lot of evidence to that, but that's what they believe. The proof of stake people, the downside and weakness they have is it's a plutocratic model. The more ownership of the system you have, the more control you have over that system. And it suffers from the same thing the shareholder models suffer from, whereas you may maximize short-term gain over the long-term viability of the system. So a really cool question is, can you build systems that are multi-resource? So instead of just pulling from one resource to select who wins, this 25% of the time and maybe this 25%, you can do that. In fact, the cryptocurrency space did that a long time ago. There was a cryptocurrency called Purecoin in 2011, and it was a hybrid proof of work, proof of stake. So some of the blocks were made with the token ownership distribution, and some of the blocks were made with proof of work. But you could keep adding. You could put in like, hey, I want hard disk in my thing. You can put permacoin in or something like that. So create incentive for hard drives. And then you could say, oh, no, I want to do like a human system, like a proof of merit. Oh my God, now we're up to 4. And you just keep adding. And each of these pools will have different adherents and actors. And then you can actually balance out the whole thing.
So as opposed to having one cult, you have many cults.
Exactly.
And they argue.
And the cults argue with each other. And we call that a government.
By the way, not all cults are bad. Physics is a cult too.
And it's sometimes bad.
It's honest, at least. Nature is a cult.
Yes.
Nature is metal.
Yeah,
Check out the Instagram.
So that's really the crux of it. You have a ledger, and the ledger is just all about saying, hey, we need to put some stuff in here. And once it's put in here, you can't turn it back. And you know when it was put in, and everybody can see it, or some group can see it. And then you need to pick somebody to modify that. So all this chaos will happen. All these transactions are all around the world, and our perception of them are different. There's a beautiful paper from Lamport that kind of talks about this from the 70s. It's like one of the most classic papers ever in computer science. I think it's been cited like 50,000 times or something like that. It's a crazy paper. But basically, you have to figure out, okay, well, somebody has to be in charge. Some group has to be in charge. And you can do it with a meritocratic, hashocratic computation thing. You can say, well, if you have coins, 25% of supply, 25% of the time on average, you'll be selected to have the right to do this or give it to somebody else. Or you could search for other resources. And they can even be human resources, like some notion of merit or social benefit. Maybe you get a token for that and you can weight it with these other systems. And that's where everything's going. We're getting to a point where we've really optimized all the properties here. We've proven all these nice things about it. And there's a lot of competition to basically build like the perfect proof of stake system, whether you're Polkadot or Algorand or any of these other guys. But now the next step is say, well, why do we just have one. We should have multiple resources. And the point is each of these has different trade-off profiles. And so they balance each other and you end up building a much more resilient system. So it's not winner take all with one particular demand.
Okay, so there's a million questions that spring up right there. But first, linger on this topic and say, what is proof of work? What is proof of stake? Just zooming in on each of those. And what are the differences?
Okay, so they all have the same three properties of pick someone in charge, do something, and validate it. The difference is that the picking mechanism for proof of work is you have to solve a puzzle. So it's basically like buying lottery tickets. And you can buy a certain amount every second with your computing devices. And some of them are ASIC resistant, so you run them on like a laptop or a GPU. And some of them are specialized hardware that you have to either manufacture or buy from someone who sells it to you. And that's just how many tickets per second you can get. And eventually you hit those magic numbers. And when you do, it means you have the right to make the block. And generally you bundle the block making with the proof of work system. Now you can do this looking for a single, or you can do this to actually shard it and look for multiple block makers at the same time. So there are sharded proof of work protocols, like Prism is an example of that. And actually, Ethereum got started this way with Spectre and Ghost and Phantom, the Avi Zahar's work and Yonatan Lipinski. But the basic idea is you pick some collection of people, they make some collection of things, and there's some way to sort it all out, serialize it, and prevent double spends. Great. Proof of stake is the same, but it's a synthetic resource. So instead of doing things, they say, well, if you had 25% of the hash power on average over a long period of time, you'd probably win 25% of the time. Well, why don't we just introduce some randomness in from some source, and then 25% of the time on average over a long period of time, you'll win. So it's a synthetic resource. But you still have to do the other two things. You still have to make the block and you still have to validate the block. The big difference is this step in the proof of work world is horrendously expensive. You use more energy than the nation of Switzerland. And the problem with that is that you have less resources for the other two. And the other problem with that is that if this is horrendously expensive, you have an economy of scale kick in. So what ends up happening is the system becomes less decentralized over time because you have these vertically integrated operations. I mean, not everybody can go build a mining facility on a volcano in El Salvador. Not everybody can go to Mongolia and set up a 5 gigawatt power plant and a huge data thing. Not everybody has access to the patented ASICs that people produce. Because what if I don't sell it to you and I have the patent on it? Or what if I control the supply chain for these things? So you'll end up having centralization around maybe 10 or 5 major operations, as we've seen historically with proof of work. And that means you end up having like a ruling class of a mining oligarchy in the system. Proof of stake, if you design the parameters correctly, you actually get more decentralized over time, because as the currency goes up in value, the distribution of the currency tends to get more egalitarian. For example, Bill Gates, when he started Microsoft, he had 64% of the shares. Now he has less than 5% of the shares. So this founder drift over time, as the value goes up, divestment occurs. You have more and more and more people coming in. That means there's more people who can participate in the consensus. You can even tune economic parameters. And this is what we did with Cardano and Ouroboros. We created this concept of K in the system, and it's just a parameter. And it's like a forcing factor that tends to accumulate a certain amount of stake pools. So you can set it to 200 and then 500 and 1,000 and so forth. But the basic idea is as the price of ADA goes up, you make K larger, and then you end up, in practical terms, having a larger and larger set of actors making blocks that are unique and distinct. And the other good thing is this is a virtual resource instead of a physical resource, which means it's portable by a click of a button. So let's say China says mining is bad, we're going to shut it all down. And it looks like they're moving in that direction. You have all these people in WeChat just like trying to sell miners or trying to figure out how the hell do I move miners, because they have these huge data centers they've constructed. You can't exactly go and grab a server and like take it with you. It's huge. It's a lot of work. And if the government seizes it, well, it's their property now. A virtual resource, you can click a button and redeploy it to a different jurisdiction. So to me, for a virtual asset, it makes a lot more sense to try to tie your security to something endogenous, something within the system, because it's just like the asset. It can move anywhere at a click of a button, and human beings have a much harder time attacking something like that.
Well, so people, maybe you could sort of play devil's advocate and say, what is the strength of proof of work system? Because some people would argue that proof of work because it's outside the system, it's tied to physical resources, it's more secure. It's less prone to attack by large groups of people?
Yeah, it's a great question. And the first question we had was, could proof of stake actually work or not? So the problem was that the engineers kind of led when the science should have led. And so there were all these POS protocols that came out in the early 2010s, like Purecoin was the first, and then NXT and others came out. And there they had suffered from things like the random number generation wasn't good. They had grinding attacks and nothing at stake and all these other things. And there's a lot of beautiful properties for proof of work from a theoretical sense. We even wrote a paper called GKL, named after the authors Juan Garay, Nico Leonardis, and Agalos Gassis, our chief scientist. It's got 1,100 citations now, and it was published in 2015. But basically all it did is just modeled a blockchain and created some security properties for it. And then it started talking about, well, what does proof of work actually do for you? And it turns out it does a lot. It's an asynchronous system. You can bootstrap from Genesis. So if Eve joins the network and Wally joins the network and Daisy join the network, then you give them some different chains, like 5 or 10 different chains, they can run a calculation and they will always pick the longest chain, the heaviest chain inside the system. That's a great property of proof of work. Until we published Ouroboros Genesis in 2018, you actually needed to solve that in proof of stake with a trusted checkpoint. So some actor had to be observing, watching the whole thing and creating checkpoints. And then when new people joined in, they would only be able to distinguish between a chain based upon a checkpoint telling them that. So you have to do a lot of really wonky, crazy math to show and create this notion of like density to be able to show that that's possible. But there's a lot of properties of proof of work that were super hard to replicate and emulate in the proof of stake world. Macaulay kind of revolutionized the whole VRFs thing. There was a group out of Cornell that talked about better network conditions. They wrote a paper called Sleepy. We did Genesis. We also did the very first proofly secure protocol, but that was 6 years of work and like 12 papers. And it's still not done. There's still a few polishing things that have to be cleaned up, because this is a physical resource and there's something there. But there's a flaw to proof of work that is a little problematic. It's a winner-take-all type of a system. So maximalism is kind of philosophically and computationally built into it. Let's say you have 2 proof of work systems and they have roughly the same market cap and hash rate, and they use the same algorithm. Then the problem is if the miner comes in, and let's say the miner has enough resources to have 51%, for any of these chains, they actually have a perverse incentive to come and destroy one chain and short sell the asset. It's called a Goldfinger attack, and then go mine the other asset because they're not bound to that asset. They're not loyal to it. And they can make just as much profit mining this as they can make mining the other system. And the markets allow them to profit from the destruction of a system. So that's something that proof of stake doesn't suffer from, because the only way you can participate in a proof of stake system is you have to actually own equity and you have to have ownership in that system. So if you go and destroy Daisy's chain, it would just be a net loss for the most part, unless you have really messed up markets or something like that. So there's always trade-offs and all these things. And this is why I like this concept of going one to N and having multiple resources, because why not have proof of work and proof of stake together if the proof of work is useful, not wasted computation? And why not add other things like create incentives for network relay? Right now, there's no incentives in the system for you to run peer-to-peer nodes and share data. Right now, it's not a problem, but if you're running like Amazon Web Services level of bandwidth, it could cost you like $5,000 a month in bandwidth just to run a full node or something like that. No one would do it. So then your system will centralize along the weakest link, whether it be the storage layer, the computation layer, or the network layer of the system. So if you can incentivize the resources differently, then you'll be in a beautiful position where you end up having a resilient system that pays its own bills.
So how does Cardano solve the consensus problem? Do you tend to eventually wanting to solve it in the hybrid approach of proof of stake and proof of work?
Yeah, this was a philosophical difference between Vitalik and myself. The problem with the people on the Ethereum side is they're really bright. And these really bright people, what they do is they try to do everything all at once because they're really, really smart. And they keep going until they run up against the wall. And they realize that the problem's a lot harder. If you're more experienced, and that's why we brought in proper academics like Agalos and others, because they'd been beaten up through life. Agalos worked with David Chaum and these others. It's really hard to work with those guys. And they'd already been humiliated and yelled at and had chalk thrown at them and all that stuff. And so they were humble enough to say, I'm not smart enough to solve the big problem. So don't even try. what you do is you decompose it and you say, okay, what's the first problem to solve in a chain of problems that you can compose your way up to a working system? And once you get far enough along, you have something that's pretty good. And then you have an obvious path forward of how do you iterate and improve that system. That's why we started with GKL 15, because it was just saying, we don't know what a fucking blockchain is. Mm-hmm. This is what is this thing, right? What's the security properties of this stuff? Like, what do we really mean? Then we did Ouroboros Classic, the original Ouroboros protocol in 2017. And that protocol was like a synchronous system, and it assumed the nodes were always on. And it worked, but it was useless because that's not real life. Then Proust came out, and then suddenly we relaxed things.
These are all, by the way, names for consensus algorithms.
Yeah, papers that we published, and they were all peer-reviewed. Like GKL was Eurocrypt. That's a very hard conference to get into, and Ouroboros Classic was crypto, and Proust was Eurocrypt, and Genesis was CCS. So basically, every step of the way was first an academic validation that there was some merit to the work that was done. Second, it solved a particular class of problems, either showing the feasibility of the entire problem. Because when I said, well, let's do the model first, because let's see if we can do an FLP thing. Let's see if we can get a possibility theorem. That's great because you're done. It's like, those short math papers were like, I found a counterexample. It's like, oh, okay, this whole thing is falling apart because you have a 2-line proof. Thank you. So that's what we were looking for in the beginning of the agenda was, let's either prove it's possible in a straw man case or show that there exists an impossibility result, in which case we can just abandon the entire inquiry. Proof of stake is impossible. And then once you've gotten past that threshold, it goes from theory to practicality. What actual network conditions are you looking at? Are you okay with living with an external clock, or do you want to build time from within? How are you generating random numbers, et cetera, et cetera? And every step of the way, each paper, you're solving one particular class of problems. With Prism, it said, probably shouldn't know ahead of time who Eve is. You probably shouldn't know who's making those blocks. That should be something you know after the fact. But if you know ahead of time, you can attack them. You can DDoS them. You cause all kinds of problems. Mm-hmm. Okay, so adaptive security. Also, we moved from an MPC, random number generation, which was great, but very heavy and very slow, and you can't scale to large amounts of people, to a VRF-based system, which is super fast, but a little dirtier. Because Algorand actually did some great work there. There was some good knowledge there.
What are the really hard problems that maybe if you just linger on a little bit, what are some of the really hard problems you have to solve along this chain of papers, ideas, the evolution of the consensus algorithm?
Yeah, not only are they really hard problems, they actually require different cryptographers, because you're moving from mathematician style cryptographers like the Neil Koblitzes and the Adi Shamirs, the people that like start as proper mathematicians. They really love theory, and that's their thing. And the proofs are dense and they're thick and they're beautiful, to practical applied work where you're saying, okay, now this is something an engineer can look at and say, I know how to build that. I know how to think about that. So that transition from GKL to Ouroboros Classic to Proust, I'd say the biggest leap was Classic to Proust, because that was going from a system that would only work in a consortium chain like Fabric to a system that would actually work and is working. That's what's implementing Cardano today, $50 billion cryptocurrency and all these people. That was a huge leap. But that paper alone wasn't enough. We also had to layer on the economic model, because we said, well, hang on a second here. Not everybody's going to be online all the time to be available to make a block. So you need some notion of delegation. The minute you have a notion of delegation, you have these stake pools. What the hell does that mean? And so this is a beautiful kind of interdisciplinary notion that layers computer science and biology together. And minute that complexity starts going up, you start seeing cell specialization. So you go from single cell organisms to organisms where you have eyeballs and brains and hearts, and each of these tissues do different things. Well, analogously, complex distributed systems start getting specialization. You move from the single celled thing, Bitcoin, where everything's a full node, they all have the same rights and responsibilities, a lot of homogeneity in that system, but you're only as good as your weakest link. You're only as capable as whatever the basic cell can do, to a specialized system where you start having these actors in the system that are actually a little different than the other actors. So you introduce this concept of the stake pool. And suddenly now you have this actor where you're probably going to be online 24/7. You're probably going to have extra relay infrastructure. There's a trust relationship where you don't own the ADA, but you have a right to use it for something. And a person's made that choice to endow you with that. The minute that you introduce specialization, though, the system gets more complicated, the game theory gets more complicated, and then you start having to think really deeply and carefully about, okay, well, can this now introduce a new attack vector that we didn't have before. So that leap from classic to Prouse and adding in stake pools and figuring out how to handle the game theory there was exceedingly hard. It took 2 years to do that.
So stake pools allow for multiple parties to delegate their staking capabilities to others. Can you describe a little bit how this works? It's kind of fascinating.
It's a super simple concept. So you register a pool, and then the pool is there, and they're basically they advertise, and they're actually registered on chain with a certificate. And then in the wallet software itself, you can see all of the pools that have registered. There's over 3,000 of them now inside the system. And you can click a little tile, and it shows you all the metadata that's in the certificate, and it says, hey, I have my own pool. It's called Rats. I'm king of the rats. So you can see all the stuff that's described there. And pools have an operating fee because they're like a business. And they say, well, if you delegate to me, I'll charge this much. So if you get like $100 in rewards, I'll give you 90, and I'll take 10 or something like that. And then you make your decision, and whichever one you select, you click, delegate, you push the button, and then you have now given your staking rights to them until revoked. Okay, so it lives there. And then the stake pool's weight in the system is proportional to the amount of stake that they have delegated to them. And then we have this other limiting factor, K, which says that you get diminishing returns with the more stake you have. So it's kind of like an S function. So you kind of go up and up, and then eventually caps, and then at some point you get no rewards beyond a certain threshold. So there's an incentive to split pools to different owners after some point.
Interesting.
Yeah, and so that's a complex thing, and you have to actually model the game theory out to understand where those parameters should be set. And we didn't know how to do that. So what we did is we bought talent. We went to Oxford, and we hired this guy named Elias Kasoupas, who's an algorithmic game theorist. We said, hey, would you like to do some game theory work in crypto? And he's like, that sounds fun. So he spent a year and a half. We built all these beautiful models, and we kind of figured out what those curves needed to look like.
So figure out like the S curve that would result in a nice distribution of responsibility. So not everybody delegates to the king of the rats.
Exactly.
How does it feel to be royalty, by the way? It's not a very impressive kingdom, but you're nevertheless a king.
I'll take it because I think it's the kindest thing people call me in this space.
Yeah, people love you. So, okay, so is that, would you say, a solved problem, the game theory of stake pools?
No, it's the starting. And then I was getting back to my original point of that you build things in iterations. Every step, if you've done it right, is an invitation for 10 more sexy, fascinating, fun problems. And this is why we have such a great time building labs. We started in Edinburgh. Now we're at Tokyo Tech and University of Wyoming and Athens, and we're setting up more labs this year. And all these academics want to work with us, A, because we write a lot of really fascinating papers, but B, because we're focused on all these really cool, sexy, interdisciplinary problems. We're actually running the problems where we don't even know where to publish the paper. Because you'll have this paper where there's like these PL guys working with crypto guys, working with systems guys, working with economists. And you put it all together and you have this Frankenstein paper monster. And we're like, where do we submit this? Where does this go?
Nature.
Yeah, there we go. Nature or Quanta or something. I don't know. They'll write a nice little...
So the sexy problems multiply exponentially.
Exactly. And, and we've now gotten to a point where we're starting to work on refinements to the system rather than fundamental things that are like, if you don't solve it, the system just simply doesn't work. For example, you can run all of this with NTP as your clock server, but you actually can create a notion of time within. We wrote a paper called Ouroboros Chronos for that. Okay. But that's not necessary for the system. It's just a nice to have thing. It's a nice property. Optimization of the random number generation is another example of that. You can run it with a heavier thing. You just have more blockchain bloat and slower time and transition. We have this concept of epic. So you elect leaders to run the system every 5 days with Cardano. But there's been derivative work. We didn't even do this. This work occurred at University of Illinois. And that derivative work said, well, you don't actually need to do that. You can do it on a block by block basis. It's like, oh, that's pretty cool. So that's the other point about doing things in a very rigorous way, is that way creates a lingua franca for what you're trying to solve with the totality of the academic community. So suddenly people that you've never met, you know nothing about, have read your papers, cited your papers, and start writing their own papers, either to try to attack and destroy things you've done or to build on top of the things that you've done.
So people are trying to figure out ways to attack this.
Exactly.
As rigorous as you are trying to.
And I don't have to pay them. That's the beautiful thing.
It's fun.
Yeah.
It's fun to try to destroy, and that's how we grow stronger.
And it's how you build your career too. There's plenty of people that they've gotten tenure just kicking the hell out of Intel SGX. You go to CCS every year, there's some guy there and he's having a hell of a time making Intel cry.
Can we pull back, historically speaking, and in terms of the big picture of cryptocurrency real quick, and ask the question, what is Cardano? we started talking about already the consensus algorithm Cardano takes, but maybe when you look at the history books, sort of Hitchhiker's Guide to the Galaxy and Cardano will have one sentence. What's that one sentence going to be? And in general, what's like the vision in the context of the history of cryptocurrency? You have like this whiteboard overview video that you talk about the 3 generations of cryptocurrency, where Cardano is the 3rd. So that's like 5 different questions, way of asking the exact same thing. You can answer however the hell you want.
I always term Cardano as like a FOSS, a financial operating system, and nobody likes it, and everybody picks on me for using that term. But basically, the idea is that the world runs on systems, especially the financial world. You have the BIS and SWIFT and all this other stuff, and these protocols allow you to move value around and represent things like identity and allow you to express yourself in some way. And those protocols, for the most part, work well for people in rich countries, and they don't work so well for people who aren't in rich countries. And so the point of what we do, or at least what I do and what my company does, is we think a lot about how do we build a universal protocol that does all the stuff the legacy system has, but just does it better, faster, and cheaper for everybody in the world. And everybody has equal access to it. So it's the people's protocol. You have a situation where the guy in Senegal has the same access that I do, or Bill Gates does, or someone else who's kind of higher on the spectrum of wealth and power. And so that is what we seek to achieve. But then the question is, well, is Cardano the solution? Is that thing? And the answer is no, because you need a lot more evolution. You need decades of evolution to kind of work your way there. And in many ways, the work is never quite done, but it's better than what came before. Why? Because you have a realization that first, the control of the system needs to be more balanced and nuanced, and it needs to be more democratic. So there's this sustainability component of like who's in charge and how do you pay for things. Well, the system can print its own money, so it always has the ability to have a budget. Okay, so there's a treasury idea. And then there's a voting thing. Well, the same things that allow you to move money around allow you to represent votes. So you can do e-voting with the type of system. Okay. And, if you played Nomic in the 1980s or Peter Superfan or any of these things, you can build a self-evolving system. You can actually create a game where the rules can be voted on and changed in the game itself. Mm-hmm. Great. Okay. So that exists there. And then you say, okay, well, but this thing still has to touch the legacy world. There has to be cash in and cash out and these types of things. So there's this interoperability thing. You need a Wi-Fi or a Bluetooth moment for the industry because nothing understands each other right now. There are all these chains are blind, deaf, and dumb to each other. And then there's this thing that it has to work at a huge scale, like billions of people. And we've done that, but we've done that with large multinational trillion-dollar companies with centralized infrastructure. We've never really done that with one master protocol that somehow does it for everyone. The closest approximation is probably BitTorrent. And it's a cool protocol, but it doesn't have all the oomph necessary to do something like this. So Cardano is just our first approximation. And like any good system, we wanted it to be self-evolving. So once you get the philosophy out of where's the target of what do you want to do, then you build a community. Now it's over 1 million people strong, and that community keeps growing, and they keep pushing the system in that particular direction. And what's nice about it is if you build the right philosophy within the system, it doesn't need founders. This is the great lesson of Satoshi. It doesn't need founders to be able to get there. So, if you look at the academic side, that's very decentralized. We have more than 30 different contributors for the 105 papers, and that set keeps growing. Within the next 5 years, it'll probably be 200, 300, 400 different scientists from all across the world, some from Russia and some from India, some from China and some from Japan and America and Africa and South America. And the faces change, the languages change, the cultures change, but the process stays the same. And that is a permanent organ within what we have constructed as a system. And it's the same situation entering marketplaces. Like we entered Ethiopia. What are we doing there? We have 5 million people in Ethiopia. We're getting them digital identity, and we're dragging that digital identity into the system because that's the most fundamental thing of a financial operating system. You need to know who people are in order to be able to do business with them, give them credit, be able to give them economic agency instead of thing. But once they're there, they're going to grow up with that system. They're going to deploy applications on that system. They're going to build on that system. They're going to use it every day for getting a loan or payments and so forth. And if they have pain points, what they're going to do is evolve that system to be able to mitigate and manage those particular pain points to a point where the system is competitive for it. So my job is we have this tagline in our company, cascading disruption. My job is to be the first domino. Just kind of knock it over and watch the cascade. And it kind of blows and blows and blows out until eventually, it gets to where we need to go. And what I was trying to think about with Cardano was, how do you build the minimum viable set of tools and social processes that once we push the domino, the system will just evolve to a point where eventually it can grow to fill that need, not out of charity, but out of self-interest. Right. People want things better, faster, cheaper. People want to have economic agency, especially when they lack it. Nobody wants to grow up in a world where they're unbanked and they have no access to marketplaces. They're going to seek it. Look at M-Pesa. It's the great example of that. Like cell phone minutes, they're using it as a currency. So that's where we're at. And I say a few more years, I think we'll have that right minimum viable set of dynamics inside the system. And then it's inevitable, in my view, that it'll kind of grow and consume and become this concept. And what's really cool is there's competition in the systems and concepts. So China is trying to do the same thing. They're saying, how do we de-dollarize the world and create a digital yuan? So they have a very top-down notion of how to apply this technology and bring it in. And they even have an identity system they're building in parallel called social credit. We have an identity system, Atala Prism, that we're putting in. Ours is bottom up and you own your own identity. Social credit, you have no idea. You just have a number and some computer's giving it to you. But they're both trying to do the exact same thing. And it's going to be this clash of cultures at some point between the open fosses and the top-down authoritarian fosses. And probably some Hegelian dialectic action will happen. And we'll create, some sort of somewhat closed, somewhat authoritarian, libertarian utopia.
Yeah, most likely it would be AIs battling in the space of fosses. So I really like this idea of financial operating system, but the letter F, so financial, is this just a basic mechanism with which you can have social interaction, therefore, or all kinds of interactions, therefore have an identity? Like, is F essential to this?
Yeah, because that's how people care. You need resources to survive. And, finances is kind of like this field of managing your resources in an intelligent way. And you could call it SoFi too, social finance. The nomenclature hasn't exactly been settled for our industry, and that's fun. But basically the concept is that you have something and you want to be able to store it, transform it, trade it, and use it to survive. And the question is, what rails do you do that on? Do you do those on centralized, controlled rails where there are these third parties that are, basically able to live off those things, become very fat and nepotistic? Or do you want to do it on rails where there's no middleman? You have a direct relationship with whoever you're doing business. And if you invite more people to the transaction, they're middlemen of value, not necessity. And that's really I would like to say the raison d'etre of our space, the reason we exist is to try to figure out a way to kill the middleman and try to figure out a way that we can better quantify value and transform it, move it, manipulate it. And in many ways, we've actually discovered some amazing things in the last 10 years as an industry. Like, we've kind of created the financial stem cell. This idea of a token can now is just as well be a national currency as a CBDC as it can represent a CryptoKitty. The same architecture can do stuff at the nation scale, can do stuff for a 12-year-old kid in Texas. It's pretty amazing to see that.
But sort of in that whiteboard presentation, you gave these 3 phases, and you're kind of implying that there'll be N phases to this whole evolution. And Cardano is just like the cutting edge. But if you look back to Bitcoin, how would you compare Cardano versus Bitcoin? Sort of where we are, how we started, and how it's going. Okay.
So what I did in that video, and I've done in a lot of media interviews, because I think it really helps people understand where we're at in the clock, is face things in terms of generations. And so I said, well, the first generation is Bitcoin. And really the problem Bitcoin was trying to solve is saying, every time we want to represent or move value, we need some sort of trusted third party to facilitate that. So can we build some sort of system where we can create some notion of value that can be teleported around the world and it doesn't require a trusted third party? That's it. And it's done in a beautiful way because it didn't try to be anything else. It just was, you only have Bitcoin. You can only do one type of thing. You can only push it. You can do some things on the encumbrances of multi-sig and other things, but that's a one-trick pony as a system. And it wasn't really clear if that was going to work or not for a long time. It took several years to build up enough network effect and for Bitcoins to actually become valuable. And I'd say the inflection point was 2013. And at that point, it became a $1 billion market cap. There were like Silicon Valley startups, real exchanges were forming. And it got to a point where there was legitimacy behind the concept, and people started getting, this is a really incredible idea because I can evade capital controls with it. I can like move $10 billion of something from one country to another country in 5 minutes. It's like, I could never do that before. And, some said, this is incredible. Okay. The problem is the minute that people validate the idea, they immediately want something they don't have. So like the minute Elon can land a rocket, there's the next big thing, right? You've landed the Falcon 9, now you're on the Starship. Similarly, you say, okay, I want programmability with this thing. It's kind of like when JavaScript came to the web browser. You went from these static, perhaps pretty, but ultimately static non-interactive pages to YouTube and Google and Facebook and these amazing, rich, incredible experiences, because now you can actually interact with the user. You can program things. Stuff runs on their side. Stuff runs on your side. It's a beautiful two-way relationship. So that's what Ethereum effectively did. They bolted a programming language onto a blockchain, and they went from a certain use case to whatever your imagination can have, like sunshine and rainbows and unicorns and these types of things.
So what you're saying is Bitcoin is HTML and Ethereum is JavaScript?
Basically, yeah. It was like when JavaScript came. And with like JavaScript, it has all kinds of problems and issues.
I wonder who's Flash in this analogy. This metaphor, but let's not go
Well,
there.
Actually, there were plenty of ActiveX's and Flashes. NXT was an example of a fail to start, and BitShares was another example. So there were a lot of people who tried to add some notion of programmability or a different view of how these things should be done, and they were not as competitive. Ethereum kind of came out as that JavaScript moment. Okay, the minute you have that, then suddenly you have ICOs and DeFi and STOs and NFTs and all these word salads of things. And then people start using it, they get frustrated. Why? Because it's too slow, it's too expensive, it doesn't talk to the things they want it to talk to. And also, it gets too big to manage itself. When you're small, you have founders and foundations, and you have trusted actors and core developers, and you can feed them with pizzas. You know them, you can meet them, you can shake their hands at conferences. When you're a multi-billion person system, you're too large to be able to do that. For example, we had the Shelley Summit last year. We invited Vint Cerf to come to the summit. Vint's a brilliant guy, and he had created the internet with Bob and the rest of the gang. And back in those days, it was such a simple, small system that one of their students they said, "Hey, you need to test it." He created a video game just to kind of test the thing. And you could call the guy on the other side and say, "Are you seeing this? Are you getting the signal?" They used to have an actual address book for email addresses. Yeah. So you'd open up the book, and you'd look it up. And now look at the internet. It's like, who's in charge of that? It's this gargantuan, network, and there's no group of people you can bring in. And thus, the internet evolves very slowly. You see? And so that's the problem, is that you have this situation where you want to do lots of utility. You want to do a lot of things. You want to be a financial operating system and, be everything to everyone. But then your rate of evolution slows down as your rate of adoption speeds up. So that's one of the other design goals of the third generation. It's not good enough just to do things better, faster, cheaper, and have consistent cost with your population growing, or talk to everything, your Wi-Fi moment. You also need a system that can govern itself at a scale of millions to billions of people who have divergent interests. Some cases, ice pick and eye divergent interests. They really hate each other, and they don't get along. And so that's what we termed a third generation cryptocurrency. And there's a lot of people attempting to compete in that space. There's Tezos and Algorand and ICP and Polkadot and so forth. And each and every one of them kind of brings a different blend of things that they value. So it's not completely equal between scalability, interoperability, and sustainability. Some people were very focused on high throughput, lots of transactions per second. Other people very focused on governance, like Tezos is like the governance chain, and they were one of the first to do a self-amending ledger. And other people are like Aeon or Polkadot. They're really thinking carefully about how do we build a nice interoperable ecosystem. With Cardano, we tried to actually tackle all three at the same time, which was one of the reasons why we were a little slower out of the gate. We had to write a lot more protocols, but we think we've kind of come up with a beautiful interlocking design for all of them. And again, the point is not to get it perfect, but rather get those just right set of evolutionary factors that when you click the domino, it just self-evolves into what you need it to get to.
Allow me to stretch the metaphor farther. If Bitcoin is HTML, there's HTML5. If Ethereum is JavaScript, JavaScript with V8 has become quite fast, it runs much of the internet. So the the argument could be that eventually everything will be JavaScript, or maybe you could say eventually everything will be HTML, and it's just be a bunch of different tools that generate that HTML. So is it possible that just like Rousseau, we eventually return to generation 1, Bitcoin, or we return to generation 2, Ethereum, as we, at the end of this journey?
The problem is your tail is wagging the dog there. And it's not, you have a situation where you're so focused on the technology that you're failing to understand that there's still Daisy here. You still have the user. And where's the app store? Where's the one-click install? Where's the use and utility? All these layer 2 protocols and these DeFi applications, in 5 years, they're completely protocol and blockchain agnostic. Because at the end of the day, they care about liquidity, operating cost, and user experience. It's so preposterous and absurd for somebody to say, oh, well, I'm going to go build my application, get on the Apple Store, and I am going to use Amazon as my web host. And no matter what happens, I will always use Amazon, even if the operating cost is crazy.
I see.
You see? And so we're just in a unique period of history where there's a network effect around some initial infrastructure, and people tend to be building around that. But every single one of the top DeFi providers are, if they're getting successful into a certain network effect, they're having the multi-chain conversation. So I don't really believe in a winner-takes-all maximalist view of, well, there's going to be some protocol that becomes the God protocol. First, because they evolve too quickly. Second, the incentives aren't aligned for that. TCP/IP didn't have a token connected to it. There was no financial incentive where if TCP/IP got adopted over something else, they'd make some big company crazy amounts of money. It was a useful piece of infrastructure. So I think that the third generation is going to be as defined by the social components and the usability components as it is by the technological capabilities of the system. Really, what these technological capabilities gave you was the ability to demonstrate a proof of concept and say these things are possible. Kind of like Xerox PARC. When Steve and Bill came in, they said, wow, you have networked computers, object-oriented programming, and a GUI. And this is like, what was it, 70s? It's like, wow, it's like incredible. But none of that was an actual product. That wasn't a Macintosh. But it was enough to get the idea. And then it was a race to how do we productize something like that. And in that case, it actually took several decades to roll out that vision that those guys had. And I think that's what Bitcoin and Ethereum did. But what's unique about this is normally you throw away the prior experiments. With these things, these are self-evolving systems. So it's entirely possible to, Joe Rogan quote, to evolve Bitcoin to a point where it could become a third generation system if desired, as some amalgamation of layer 1 and layer 2 protocols. And it's the same for Ethereum. In fact, Vitalik is throwing away Ethereum and replacing it with Ethereum 2 because he recognizes he needs to upgrade and evolve the system. And that's what makes it fun, because the techniques and methodologies that they've chosen to evolve and upgrade this system are distinctly different from the ones that we've chosen. And we have no idea which one's actually going to win, but we learn from each other and we co-evolve from each other. So you're running like all these experiments in real time in a giant marketplace, and maybe they'll consolidate, maybe they'll stay divergent. I mean, look at big tech. You have Google, Apple, Microsoft, Facebook. They all coexist and they're trillion-dollar companies. Some cases with TCP, it consolidates to one standard, and that's what we end up using.
So what's your intuition with Cardano having the proof of stake and then eventually smart contracts versus the Bitcoin with layer 2 technologies, this kind of evolving creature? Again, you said you can't really predict the future, but what's your intuition why one might be more successful than the other?
So the problem with Bitcoin is it is so slow. It's like the mainframe programming of the past. And it's the only reason it's still around is because there was so much invested in keeping it around that we just kind of have to leave it there. And one day COBOL will die. There's nothing about it from a collection of USPs that's particularly desirable. You have extremely long settlement time. You have extremely low programmability. It is not aware of any other system. There's no native way of issuing an asset in that system. You can't even do a pull transaction. I mean, you can't do anything that's interesting or unique there. And yeah, all due respect, it's, mafia, all due respect, Tony. You got some problems.
You
need
come
to lose
to me
some weight.
on the day of my daughter's wedding.
I know. So, all due respect to the Bitcoin people, it's like an amazing an incredible first generation thing. And we're all here because of Bitcoin. But the problem is you have to upgrade the damn thing. You know, just because you were a high school football star doesn't mean that 30 years later, you're still a high school football star in the same shape. You got the beer belly, you're old, you're not doing this thing again. And that's what Bitcoin has to do. There's fundamental improvements that I think Bitcoin can make at the protocol level that would actually make it an incredibly competitive system. Like if they wanted to keep Nakamoto consensus, proof of work, there's ways to enhance proof of work. I mean, Amin Gansir did this with Bitcoin NG. Pramod Viswanas did this with Prism. Make it 10,000 times faster, and you don't compromise the fundamental security assumptions that the system has. You can add programmability to it. Blockstream created a language called Simplicity. So there's actual ways to extend, and we did this with Cardano with the extended UTXO model. There's ways to extend what Bitcoin has, keep the philosophy, the accounting, the way of thinking about transactions, but then suddenly you can now do DeFi and other things. But what they've done is said, we will not evolve the base layer at all, and we're just going to build all this layer 2 stuff, which is usually highly fragile and centralized and requires enormous effort at the base level to do anything. It's not a coincidence Vitalik started as a color coins guy and a master coin guy, hanging out in those circles. He was trying to innovate and do things in Bitcoin, and it was so hard and difficult that he started diverging and going and doing things in a different system entirely. You know, I knew the Mastercoin guys, JR, and all these people. They were maximalists. They really wanted to build something cool and exciting for Bitcoin. And anything they did, the developers would attack them. It's, oh, you're misusing op return. You're doing this, that. It was a holy war anytime you wanted to evolve. So I think it's its own worst enemy. It has the network effect. It has the brand name. It has the regulatory approval. But there's no way to change the system, even correcting obvious downsides in that system. Now, what's really cool is Ethereum doesn't suffer from that problem. It's getting to a point where it has a similar network effect to Bitcoin, but the community there is completely different in culture. They love evolving. They love upgrading, sometimes a little too much. And so that means that if you look at the trajectory of things, if I had to bet just those two systems, Bitcoin or Ethereum, I would say 9 times out of 10, Ethereum is going to win the fight against Bitcoin if it was the only competitor. But obviously we're here and a lot of other people are here. So there's different things going on. So it's a much more complex game. But I think that's always the key, zooming out a little bit, set the technology aside and the word salad of cryptography aside, because it's too much. What you have to always do is say, what incentive does the system have to evolve? And when you look at things like Android and the App Store and these analogous platforms, you say, the evolution is user-driven and there's a financial incentive for the user to participate. So if I had to look at the trajectory of this thing, come back 10 years later, it's probably going to have millions of applications and lots of stuff going on because that's the way the system was constructed. Okay, it makes sense. When you look at Bitcoin, you say, what is the incentive to evolve the system? There's none. What is the incentive for the system to get more competitive? It's not. In fact, it's the opposite. They've turned it into a religion. I was in Miami at this Bitcoin conference there. I had a toilet paper roll thrown at me that had shitcoin written on it. You have Max Kaiser out on the stage, doing his best Rick James impression.
Was he the guy that did the F Elon?
Yes,
Elon?
yes. And so
wonderful.
you're watching this stuff and you say, okay, first, why would anybody want to join that? And then second, where is the conversation about how do we achieve something? I started with Cardano, the end in mind. I said, we really want to sit down and build this financial operating system. And the definition of success is the poorest person in the world has access to the same system as the richest person in the world, and they both get treated fairly. We've never had that happen before. Okay, that's something. You can agree with it, disagree with it, say it's boiling the ocean, it's impossible. At least I have something. I can't for the life of me understand what the hell is the point of Bitcoin. When I joined the Bitcoin space way back in the day, it was, hey, we hate the dollar and, hey, we like gold a lot. Let's create digital gold. Let's build a payment system. And then it just kind of went all these different directions and nobody can actually tell you what Bitcoin is for. It's a store of value, okay. There's some proof of work thing where maybe you're like incentivizing alternative energy to be produced. I don't know. It's like nobody really knows the philosophy. There's no direction. And they say, but don't worry, just buy and hold and everything will sort its way out.
I believe it's HODL.
Yeah, HODL.
What about the idea of digital gold? So trying to replace this particular physical material that is gold and transfer into the digital
that's
space.
Something. Okay, let's do that then. And just say that's all it does. Then why are we doing Lightning? Why are we doing any of these other things? Because you don't really need with, a commodity, a digital commodity, high throughput. You can have slow settlement. You can have high transaction fees, all these types of things. And that's fine. Okay. That's something. Pick it.
Well, the idea is to try to come up with technology like the Lightning Network that could have something like gold, but then still build an economy around it. Something with high throughput transactions.
And have we ever built a successful banking credit system off of gold? Never. It never works because there's too much volatility in the underlying asset. Would you take a gold-denominated loan for something? If somebody says, all right, I'll give you 5 bars of gold to go buy this car and pay me back 5.5 bars of gold. Nobody would know in 5 years where they come out in that kind of arrangement.
The idea is that the gold is used for the settlement of transactions, and then the actual economy is operating outside of gold. And then you kind of connect back to gold.
So we have to go back to the gold reserve. And we tried that for a long time. It didn't really work in a modern global economy. We had the Bretton Woods Agreement and all these other things. And so I understand what you're saying. And maybe there's some merit to that. But if that was really in earnest where they want to go, then the conversation should be about, well, how do we make it easy for layer 2 protocols to interact with Bitcoin? So why is simplicity not built into it? Why is it taking so long to do SNORSIGs? Why is it taking so long to do all of these obvious upgrades, which are cryptographically low danger? Also NIPoPoWs. Non-interactive proofs of proof of work. There's no cost to doing that. It's just a property of proof of work where certain puzzles are more special than other puzzles. And by noticing that, you can create these beautiful proofs that allow you to have sidechains and light clients. It's not compromising security of the system. It's just something you get for free with proof of work. Those came out in 2016. There's derivative work fly client floating around. Where the hell is it?
Yeah.
This is the frustration that I have is like, if you really are serious about this whole lightning and gold economy thing, I love choice. I'm a libertarian by nature. I love competition. And, I read all those books. I read Ludwig von Mises's work and Murray Rothbard's work. And I love what Hayek had to say about private currencies. Let's go try it. That's great. But then you have to have some focus and commitment as an ecosystem. And the excuse they use is, well, no, we don't because we're decentralized. And because we're decentralized, we don't need that. As if there's some sort of guiding swarm intelligence that will naturally push the system in that particular direction. But then you ask, well, how do people measure the success of Bitcoin? Is it the fact that they've actually achieved lots of transactions and lots of actual economic activity and lots of businesses accepting
Number
Bitcoin?
go up.
It's the price. That's what they do. And that's the only thing they pay attention. That's why this is the most attended Bitcoin conference in history. Not because somehow Bitcoin got so much more adoption. It's because this is the highest price point Bitcoin has ever been this year, over 30,000.
So first of all, let me state that Charles, for the most part, is purely objective. The bias that comes in, for the record, I want to say that I have heard, because you mentioned the mafia, that you prefer Goodfellas over the Godfather. So a man who prefers Goodfellas over Godfather, you take it for that opinion for what it is. I actually had to think about that one for quite a bit. I think.
Oh, come on. Joe Pesci was so good in that
He's
movie.
incredible. I also love Casino and those big glasses on De Niro. I love it with Sharon Stone. But we could talk about that for hours. But let me ask you about the Bitcoin conference, because it is kind of, I would say, an important moment in human history. It was quite exciting in terms of size and kind of turmoil and all those kinds of things. Right. And you were there in, hot and humid Miami, I believe is the way you introduced it. Mm-hmm. So what do you make of the community of Bitcoin or that particular event in human history?
What makes me sad is I remember the old Bitcoin community, and I've seen what it's become. And the old community was really fun, like the San Jose conference in 2013 or subsequent conferences. There was just a lot of people. They had no money. And they just really love this idea of decentralized money. They love this idea of decentralization in particular. And you could strike up a conversation with everyone. There's no ego at all. But what was really fun is just you could really get intimate friendships and relationships, great conversations with people there. It's kind of like the early days of AI. They all met in Dartmouth and all these other places. Very intimate. There was no egos. Everybody was just trying to do some really cool stuff. Now, just like those early days, there was an overestimate of how robust the solutions would be. So we believed, in 10 years, we're going to rule the whole world, right? Didn't exactly happen. On the other hand, Bitcoin grew from nothing in just 11 years to, I'm in Mongolia riding camels, and the camel herder has Bitcoin in the Gobi Desert. So that's telling you that's a pretty pervasive technology if you have that level of adoption that quickly. When I went to Miami, it was unrecognizable. Everything was so commercial. Half of the vendors at the conference were like watches that were cost $500,000 and they were covered in diamonds. So when you see that kind of materialism leak its way in, it at first is repulsive. The other thing was there was no, like, I remember one of the first conferences, Mo Levin's conference in January 2014, the North American Bitcoin conference, ironically in Miami, there was a Bitcoin Help Center booth. Dima ran it, and a few of the other Bitcoin OGs ran it. The core developers actually came over, like Jeff and others, who were there and sat at the booth. And anybody come up, ask a question. Anything you want to ask about Bitcoin. And it's like, that was the culture, just help people, welcome in. There was no help booth there. There was no notion of that. There were 6-hour lines and superstars and things like that. And again, it was always the same thing. Look how much money all these people have made. And the whole point of Bitcoin was to redefine the notion of money, redefine the notion of value, these types of things. So it just, I'm no longer part of that. And it made me sad because I really enjoyed being part of how I got started was the Bitcoin education project. I did a class on Udemy. I gave it away for free. I had 80,000 students and they would email me. I got 5,000 emails before I stopped answering them. And everyone come in and ask me some question about something, sometimes arcane, sometimes trivial. And I'd take the time to sit down and answer the question or forward the email to somebody I knew who could answer that particular type of question. And there were some amazing people in the early days, like Mike Hearn and Gavin and others. And they were just super committed. And Mike's case, he knew Satoshi. He actually emailed him back and forth because he was around 2009, 2010. He did the Bitcoin Java client. And Satoshi was all excited. He's like, oh, wow, Bitcoin can come to a cell phone. This is really cool and exciting. And then what happened? Mike left Bitcoin in 2013 over the whole big block debate that happened. They just treated him like dirt, like he was subhuman or something. So I don't know. The culture has changed a lot, and it's, if they like it, it's good for them. They can enjoy their religion, but it's not for me. And where I like being is, I had a guy who used to work for me, Alex Chepurnoy, and he created this beautiful project called Ergo. To me, that is the spiritual successor to Bitcoin. Ergo is really special because it has the same culture, it has the same mentality, and the technology is kind of like a natural evolution of what you would do if you knew about Bitcoin and you wanted to build the next big thing. So it's still a proof of work system, it's still a UTXO system, but he added UTXO with some smart contracts. It's this Sigma protocol idea. On the proof of work side, Satoshi had this one CPU, one vote idea. So Alex tried to create non-outsourceable puzzles to make it impossible to have mining pools. And there's all these other beautiful little things. And he's this brilliant Russian programmer, and he surrounded himself with all these other brilliant people. He has zero ego. He has negative ego. When you put him with a person with ego, your ego goes down.
Yeah.
Right? And everything about Alex is always like, how do I solve this? How do I do that? And he gets legitimately excited when he meets somebody that he can collaborate with or learn from. That's where Bitcoin was in the beginning. Everybody set their egos aside, whether it was Hal Finney or whatever, and they would just say, how can I help? What can I do? And it was all about coming up with some cool new thing or solving some cool new problem. I don't see any of that in Bitcoin today.
So quite a few people are excited about Ergo and excited about the fact that you kind of appreciate Alex and Ergo. Do you see Cardano potentially utilizing the proof of work mechanism from Ergo as part of this pool for the consensus mechanism?
I mean, anything's possible, and there's a lot of evolution Ergo has to go through. And Ergo was kind of like when the Xbox 360 first came out. While they were prototyping it, Microsoft needed a development environment. They ironically purchased a lot of Apple computers to do that, because Apple was moving away from the PowerPC to Intel, and Microsoft was moving towards the PowerPC. Just this weird intersection of history. So at that time, the largest order of Mac computers made was done by Microsoft, and they were using it for Xbox stuff. So Ergo we viewed the same way. So we said, well, we have this extended UTXO model. The only thing that's sufficiently close to it where we can beta test contracts is actually with Ergo. And Alex just was a little faster in getting certain things out because we were doing things in a slightly more rigorous way and slightly more expressive way. So we actually tested a stable coin and Oracle and other things on Ergo. And it has just incredible community. When we said, hey, we're coming here to work and build, oh yeah, we love work with you guys. This is so cool. The other thing is Alex used to work for us, and he had this lovely project called ScoreX, and it was all about like a pedagogical framework for building blockchains. And if you want to do prototyping or academic research, it was great. It was super modular, and it separated the consensus network and transaction layer from each other in just the right way so that you can make it modular and mix and match things. So you can put secure Kademlia in, or maybe a different network layer and a different consensus protocol like proof of work to another proof of work and so forth. So we loved having that kind of IP sitting around because it gave us the ability to kind of play around with ideas in a matter of weeks instead of months or years. And then he just took that concept and he gave it away. The Wave protocol was built on it. That was Sasha Ivanov. He did that. And I think there's 2 or 3 other cryptocurrencies that were launched from Scorex. And then Alex took that and built Ergo from it. So there was a nice intersection where there was overlapping technology with Ergo, with our technology. And the other thing was that the community was so open and friendly, it was just a no-brainer. Just go in and start building some things there. Now, in terms of evolving ideas, the whole Sigma protocol idea is very different and it's very interesting. And there's a guy at Boston University, his name will come to me in a second, who came up with this stuff. And I think there's some merit there, especially as we start moving closer to this idea of blockchains being used to validate proofs instead of running computation.
What's the Sigma protocol, by the way?
So it's just a way of expressing scripts. And basically, you get these concise representations of proofs. And then you can say, okay, the script is correct, but you don't have to run the whole program. So there's a lot. I'm not doing the topic justice. There's a lot more to it, but that's the basic concept. And in a redeemer validator model, you need stuff like that because as your model gets more complex and a lot more things happen, you don't want to have a situation where I have to replay a huge amount of the UTXO graph to be able to get to a point where I have the state of the system. You need some mathematical artifact that gives you the state of the system quickly. And then you're say, okay, I now know what computation thread I need to run to be able to get enough to be able to redeem this transaction. So he just found a more compressed representation of it. And, the math doesn't matter. What matters is there's a whole beautiful field that thinks about this type of stuff. And it was never once linked before into our industry. The brilliance of Alex was to actually realize you could do that and pull those things together, and it may actually have some merit. But by no means is he the only guy that does this stuff. There's actually other approaches in verified computing that have explored that. Like my favorite came out of Microsoft research is a project called Pinocchio, and there was a follow-up called Geppetto. And the basic idea was that it's fortuitous that you have these computer science problems like hashing, where you can do all this computation, and once you've done all of it and you found this magic number, that you can verify that the computation was done correctly. So the proof of work works this way. Hard to do the proof of work, easy to check the proof of work. Cryptography also works this way. You have some trap door where you can verify something's correct, but to get that thing done, if you're doing it brute force, it takes an enormous amount of computation. Well, not all problems are like this. Like protein folding, to verify the protein is folded correctly, you have to fold the protein. So you have to redo the work. But what if, for arbitrary computation, you could take a problem and then you could generate a proof that you've done that computation correctly, and the proof validates in logarithmic time or constant time? Wow, that's incredible, right? Well, Microsoft actually wrote a paper on how to do that. It's called Pinocchio. So that's another example of these types of things, these roll-ups of things, where instead of doing the computation on chain or trying to create some sort of replicated machine that does all this stuff, you instead just say, okay, only thing I'm going to use the blockchain for is to check your proof. But I'm going to turn it into a distributed computing problem, and any person in the world can do the problem on any server, untrusted server even, because you don't have to trust the output, you trust the proof, and the proof is deterministic. It tells you these things. So, whether you're using zero knowledge or Sigma protocols or, some other mechanism, it's moving you in that particular direction to turn it from a replicated to a distributed problem and go from I'm doing the work to I'm checking that the work was done correctly.
That's fascinating. And all of a sudden, we're back to the P equals NP thing, where for many very interesting problems, the checking is is much more efficient than the solving.
Right. And also, do you want complete determinism or is it probabilistic? Because if you relax that requirement a little bit, then suddenly actually you have a broader class of things you can construct this stuff for.
You mentioned UTXO. There's a paper titled The Extended UTXO Model. It writes in the introduction, Bitcoin and Ethereum, hosting the 2 currently most valuable and popular cryptocurrencies, use 2 rather different ledger models, known as the UTXO model and the account model, respectively. At the same time, these 2 public blockchains differ strongly in the expressiveness of the smart contracts that they support. This is no coincidence. Ethereum chose the account model explicitly to facilitate more expressive smart contracts. On the other hand, Bitcoin chose UTXO also for good reasons, including that its semantic model stays simple in a complex concurrent and distributed computing environment. This raises the question of whether it is possible to have expressive smart contracts while keeping the semantic simplicity of the UTXO model. Okay.
So what's the fuck that mean?
Exactly. What is UTXO? What is the account model? And what is the idea of the extended UTXO model?
So I guess the easiest way of visualizing it is UTXO is kind of like cash register accounting. So, and let's assume you don't have credit cards, you just have cash. And so when you go and buy some milk and potatoes or whatever, you go to the cashier, you pull out your $20 bill, you give it to them, and let's say that it comes up to $17.50, they have to make change. So you don't tear your $20 bill and cut a piece of it off and say, here's part of my 20. You give them the entire $20 bill, and then they give you something back. And the things that they give you back are also atomic units. They don't cut those things up. So that's kind of what UTXO is all about in a nutshell, is that there's inputs and outputs. Your inputs to that 20, and your outputs will be the $17.50 that goes to them, and then the remaining change that goes back to you. Okay? The problem with this particular model is that the way it was implemented with Bitcoin, there was no notion of how do we run complex predicates, complex contracts on this thing, where instead of just saying, okay, I'm just going to push value to you, I want to put lots of terms and conditions into the movement of that value. Like, you only get this if I mow your lawn on Tuesday, or you only get this if, some event happens, like the Broncos win the Super Bowl or something like that. Okay, so you need some notion of programmability with it. So a lot of people are trying to figure out in the early days of Bitcoin, how could we improve the expressiveness of the system? And one of ways of doing it is you can go to a different accounting model, bank-style accounting. So in a bank ledger, every time you do a withdrawal or deposit, it's a mutable system. With the cash register accounting, you don't tear up the bills, but the bank, you can deduct or add to the ledger all the time. So Ethereum kind of works in that bank accounting system where you send messages, you send transactions, and you're going up or down. And so you can trigger programs the same way. So what we did is we said, okay, if you take the UTXO model and you add some data to it, and instead of saying it's just a digital signature, but it's in a script, you can basically create something that's still the same as cash register, but now you have programmability, and the big difference is local versus global. So in the case of UTXO, your scripts are your concerns. So whatever's going on in that cash register has no bearing or impact on the other cash registers. But when you look at bank accounting, you have to know the state of the entire banking world to be able to make that work. Why? Because if that transaction is inbound, that wire transfer is inbound, you have to know those funds are actually there. That thing is actually happening. So when you have a global state for a program, it's like you can do a lot more with it, but it's a lot more dangerous. And so you have to build all these mechanisms to try to protect yourself from it. So what we did is we said, okay, add data, add a programmability, and you're kind of in this nice Goldilocks zone between what Ethereum did with an account style model and a global state system. And you're not as restrictive as Bitcoin, but you're still in a Turing complete world. You can still run all kinds of things. And then any standard mathematician, they'll say, okay, well, is it isomorphic? Is there a mapping between this? What type of function can I actually take something expressed in one structure and transmit it to the other structure and properties are preserved? So we wrote a paper, it's called Chimeric Ledgers, where we actually showed that UTXO, extending UTXO, and accounts are somewhat similar in that you can map things that happen in one system to the other system. The properties are preserved between the two. So in practice, what's nice about extended UTXO is that you can put infrastructure on top of it to make the development experience relatively similar to the development experience of what you would do with Ethereum, but you don't have to worry about this global state. So when you talk about sharding, it's a lot easier to do that. It's a lot more conceivable to that. And also you get determinism in the system. So when I have a Plutus smart contract, whatever I run locally is exactly what I expect to run in the system. When you have a concept of this mutable global state in the system, whatever you run locally is not necessarily what you're going to get when you actually push it into the system. So you may misprice things and the contract will fail. It doesn't ever happen in the Plutus world. So you get a lot of advantages with this particular model. The downside is that it's a little bit less expressive on the boundaries and a little bit harder to write certain types of software with it. But again, how you resolve that is you kind of build higher level languages and other such things that compensate for these types of things, and design patterns that compensate for these types of things. The other advantage that we have that's really fun and exciting is that Bitcoin lives in this model, and there are other UTXO-based systems, and so they're all talking about smart contracts as well, and they would like to continue working in the UTXO model. So if you're a Bitcoin contract developer or other things, there's actually already a group of people that understand this very well, and that's still a fairly large part of the mind share of the entire space. So there are no silver bullets, and anytime you pick a particular model, there's an upside and a downside, and there's different ways of doing things, from cash register accounting or bank accounting. You can even do different accounting models. But we felt this was kind of the best first step to go into, because we started with something very familiar that had a long history behind it. And it maps very beautifully to functional programming principles, this concept of immutability and these things, and much more strict management of state, and no notion of having this global concept that you have to kind of manage as you break up the system. Now, in practice, what does this mean to the developer when they actually start writing an application? Not too much. There's going to be a little bit of retooling and some new patterns you have to learn, but in practice, you can still do the same things. You can implement a Uniswap style thing. In fact, we even wrote that code with the Plutus Pioneers program, so you can go to YouTube and watch a lecture and see how that's done. You can do a stable coin. You can do an oracle. You can do interactive contracts. It's just, it has to be done a little differently than the way that you would do it in an account style model. Just like you can write an application in Java, you can write an application in Haskell. They both can do the same thing, but the code is going to look different, and the canonical way of looking at things is different.
So in terms of Oracle networks, what are your thoughts about Chainlink and external off-chain data sources, and everything we've been talking about now with the extended UTXO model?
Yeah, I mean, trying to do smart contracts without Oracle is like trying to have sex with your pants on. I mean, it's not really fun. It's not exactly the best of things.
That's the way I've been doing it all these years. I didn't know.
For any other person, Lex, I wouldn't believe you, but for you.
That's why I'm single. This makes so much sense now.
Okay, so anyway, you need the outside world to be injected into your system, right? I'm trying to keep a straight face. Yeah. I am. It's great. You need the outside world to make your system useful. It's like all the kinds of things that you care to do with a smart contract usually involve human beings and information streams aggregating and doing something. So the Oracle is a super important component in practice for any smart contract involving any notion of value. You need to know when things have happened, how they happened, who won, who lost, et cetera, et cetera. So first, where do you get the data from? So what's the aggregator? This is why we love our relationship with Wolfram, because one of the things you'll know about Wolfram as you get to know the guy is he's a data pack rat. Every email, every communication, every interaction, he's archived somewhere. Like last time I talked, he said, "Oh yeah, I have emails from you from 2012." It's like, you still have those? Like, yeah, every keystroke is written down and stored somewhere. So if you use Wolfram Alpha, it's a simulacrum of the way his mind thinks. And so you can query the system and be like, oh, how many shipwrecks have happened in Florida between 1950 and 2000 that have resulted in more than $1 billion of cargo loss and at least one fatality? And it'll return an answer.
Yeah.
I mean, he has this incredible source of data that's computable.
For people who don't know, Wolfram Alpha is more than just the thing that assists you with your math homework in high school. It's actually this giant network of data, of like weather data, of location data, just statistics, all kinds of. It's doing the aggregation in a way that you can query across data sets. And it's exactly this kind of idea. It basically represents the very kind of thing you would hope to be able to query off-chain as part of the smart contracts.
Right, but the only downside is it's centralized, right. And that's always the Achilles heel of Wolfram, is he tends to like proprietary things, and he tends to like centralizing things, and mostly because he likes running the things, and then everybody can have an opinion on that. The thing though is that after you've done aggregation, there's a question of injection. How do you get that data into the system? And you can do that in a very naive way, where you can say, I'm just going to attach a public key to it, and it'll sign for that data feed, that injection, and then somehow I'll just trust it as it is. Or you could try to make it more complicated. You could weight data feeds from different sources and have some notion of truthiness or a veracity metric or something like that. So Chainlink is just one of many different philosophies that was born out of the academy. I believe Ari Jewell was connected to it, and there's some good people on that side. And it has a philosophy about how do you aggregate, a philosophy about how do you inject, And how do you create incentives so that that process over time gets more federated or more decentralized instead of centralizing around one particular setup? Now, closely related corollary to this is computation off-chain. So as I mentioned, smart contracts are intimately connected to our Oracle. The question is, how much pre-processing and state management are you going to do outside of the system versus what do you do inside of the system? So it's a very interesting balance between these two. And they were thinking about this stuff for a long time. There's a great paper called Town Crier, came out way back in the day at Cornell, and that was all about using like SGX to scrape things, and and you can rely on trusted hardware to give you good data. But you could also use those SGX cores to do contract processing, because if it runs in trusted hardware, then it's very unlikely to be tampered with or manipulated. And because of that, you don't have to federate it or decentralize it. You can run it on a single device as if it was running on a cryptocurrency. So there seems to be a desire in that community to capture more and more of the smart contract stack and pull more and more of that stack into that layer 2 infrastructure from running on layer 1. Why? Because you have cost reduction, and potentially because your trust model collapses to whatever Chainlink is offering, you're not gaining anything by doing the computation on Ethereum. Or another platform, because it's you ever watch The Simpsons? There was this beautiful episode where Mr. Burns wants to turn the power off in Springfield, and it's the perfect analogy for information security. So he and Smithers, they go through this elaborate series of doors and secret passages and guard dogs and robots and shit to get to the center of the power plant to turn off the power. And when they arrive at the center of the plant, there's like this stray dog that's inside the room. And there's this wicker door screen door that leads to the outside. And you're like, well, why the hell did you go through this elaborate series of doors and things if there's like a back door into your system? Yeah. Well, that's basically a real life analogy of the relationship between the Oracle and the smart contract. You're only as good in your InfoSec model as your weakest link. And it doesn't matter if all of your computation is decentralized if you're at the mercy of your data feed. Because I can just manipulate that and break the entire security model of the system. You'll perfectly execute the wrong answer. So they say, well, if you're trusting us anyway, why don't you pull more of what you're doing on chain into our stack, which creates more transaction fees for them and more value for them. But there are many different ways you can do oracles. And when earlier I was talking about the biology of these things, cell differentiation. The minute that you admit heterogeneity in your system and you start having cells like stake pools or things that are on and 24/7, then you can start asking the what if question of, why don't you guys just also provide data feeds? Why don't you guys also provide state channels or payment channels or generate random numbers for me or whatever? And you're now a service provider. You're making the blockchain full-time, but part-time you're doing this. If you're making bagels, you could probably make donuts, that type of a concept. So I think that type of competition is going to be very difficult for a lot of these layer 2 protocols that aren't tightly coupled with the protocol. Because the ones that are tightly coupled with the protocol, they have a built-in trust advantage. They've already built a commercial reputation. There's already an increasingly more decentralized set. The other thing is you don't need a token. You can just use ADA. You don't need an Oracle coin for these types of things to work. And by the way, that's just for the injection component and the veracity attestation. So is it true or not? That's not about the aggregation. That's still a tremendously time-intensive, expensive proposition. There's only a few people in the world that have what Steve has with Wolfram. And those guys, by just cutting off those supply to replicate what they have, is something that would cost hundreds of millions or billions of dollars. And so it's an interesting question of how do you incentivize decentralized aggregation of information? And that's kind of what Town Crier and other protocols were trying to achieve.
So maybe you can say how Town Crier works, because it's like, what's your vision? You're now partnering with Wolfram Alpha, in sort of exploring this partnership of data and the blockchain. What's your vision for a possible distributed version of Wolfram Alpha?
Well, the first step is just say, can we use this as a feed, and they can be what Bloomberg is to the financial markets. So you have a terminal and you have something, and there's always a value of at least offering choice. And so it's not like we're anti-Chainlink or we're picking winners and losers. It's an open protocol. It's an open system. So if we're successful, Chainlink will migrate, or it will at least support us, because they like money. They like users. They like liquidity. It's a disservice to their community not to support a potential customer set. But, you're going to have a spectrum from the desire to do a completely decentralized aggregation, curation, injection, and veracity attestation to a completely centralized, vertically integrated set. You need to be able to have that whole spectrum and offer that to the smart contract developer to decide, what makes sense. By the way, a lot of cases, they're going to be their own oracle. So, for example, the World of Warcraft example that I gave, it's a completely centralized thing. It's a video game run by a single company. There's no sense in saying that we're somehow going to decentralize that. What they're just trying to do is extend their currency or NFTs or whatever into new marketplaces. So the minting of that is controlled by a single entity, and the world state of that, you just have to trust Blizzard to inject that into the system. You could try to imagine some sort of sentinel group of people within the game who keep Blizzard honest, but it's completely unnecessary because they can change the rules of the system arbitrarily. So in that case, you're optimizing around efficiency and cost reduction. So you'd want a single feed that gets injected into the system from that. If you look at a stable coin that's algorithmic, and it's basing its value on the aggregation of many different exchanges, that's the polar opposite example. Because there you're saying, okay, what's the price of my asset relative to some basket? But how do I know that the price feeds I'm looking at are accurate? You'd have to look at Binance and Bittrex and all these other things, or maybe there's conventional Forex exchanges or something like that. Okay, well, how do you weight that? And how do you clip outliers and these types of things? That's a completely different conversation. And there's a lot more mechanics you have to put in for that bundling and attestation of the veracity of the data feed. And what happens if you get it wrong? Your stablecoin gets mispriced and everything goes to hell. And the markets will eventually correct it for arbitrage-seeking behavior, but anything that was built on that will fail in the short term. So Oracle's really just a game of you have to build a standardized interfaces and make it as easy as possible for people to do that, and then let people choose how they want to inject data and what level of assurance do they need behind that. And the question is, how much do you leave to the user versus how much does the protocol take care of for you? And it's a difficult design question. For our part, we love working with Steve and Wolfram, and they're a great company, and they really have some bright people there. And we know on the data set they're second to none, because not only do they have it, it's computable. You can do all kinds of things and manipulate with a very rich query language. So that's a great thing. And we want to make sure that that's accessible to developers in Cardano. But remember, they're like Bloomberg. It's a centralized feed in that respect. So if you want to build a Chainlink-esque competitor, there's other protocols you could do for that. Now, you asked about Town Crier, and that was an attempt to kind of sweep the oceans with the net, get the data through a decentralized way. And that was just saying, hey, let's use trusted hardware to go read law, all kinds of websites and other things. And because it's trusted hardware, the scraping is non-biased. If you find something inconvenient to whatever the person who's scraping is, the trusted hardware will still do it, and it can't be changed. You'd have to manipulate SGX to do that. So that's great, but you still run into the problem of how do you wire that together? The underlying websites still don't have any notion of veracity or reputation behind them. And then you also have the issue of storage. Where the hell do you put all of it? Yeah. If you have exabytes of data, what's the incentive for that?
That's the dream of the semantic web that I still think is a fascinating idea. How to basically convert the internet into a core, a knowledge base that you can query, you can integrate in the same way you did with Wolfram Alpha, but much bigger.
Right.
But that means basically revolutionizing the way we put the internet together, which I think these ideas of off-chain data will motivate people, because there's a lot of money to be made in creating. Finally, there's money to be made with a semantic web. So that'll be an interesting kind of future. I do want to ask you about video games really quick as a small tangent, because you said this really interesting idea of Blizzard being centralized control. Is it possible to have items in the game that are not controlled by Blizzard?
Sure.
Being controlled in a decentralized fashion that you can, like, what is it, the grandfather sword in Diablo? What was it really? Somebody was criticizing me. I was saying all these kinds of nice things about Diablo 3, and they said Diablo 2 Resurrected is coming out. They need to check it out. There's a lot of camps and wars.
We both know that Diablo 2 is far better than Diablo 3.
That's what they're saying. This is the war that they're having. Okay, so we'll play it. It's coming out soon. I'll play it. Fine. But nevertheless, those items are owned by Blizzard. Is it possible to create video games where items are owned by the people, like outside of Blizzard? And do you think in like a half century from now, we will all live in those games and we'll forget the physical space even exists.
Well, yeah, that's definitely possible. I look at CryptoKitties. That's a great example of that.
Can you explain what CryptoKitties is?
Well, it's basically just a video game that kind of lives on a blockchain, and the creatures within the game can breed with each other and create new CryptoKitties, and you can own them. So it's like some sort of dystopian Tamagotchi with lots of money behind it. but anyway, the thing is, those assets actually have a blockchain-based representation. And so whether the infrastructure that hoists up that game off-chain goes on or off, because that ledger exists outside of the game, any person can come in, replicate it, restore it, and turn it back on. Sans intellectual property. So yeah, it's completely possible to break your architecture up where you have a notion of the player part, and then you have a notion of the experience part, and you can interchange experiences, almost like you do cascading style sheets or something for, have different presentations, and the ownership of the underlying layers, the players. So yeah, that's definitely doable. And frankly, that's what's going to happen in the gaming world, because there's so much value in that. I mean, everybody wants play, and right now the model is you make a game, you sell licenses, and you have a huge surge of people at the beginning of the game buying the video game. And then you have this long tail, but you've gotten almost 95% of your value in the first 6 months. And you have a huge churn rate. The odds are the vast majority of people won't be playing the game within 12 months. But if you can create an interactive game where there's an actual economy inside the game, then you have EVE Online or Second Life or any of these things where you have people playing for 10 years, and there's like people buying virtual real estate and all these other things. And you as the game developer actually don't have to create a lot of content. So your long tail gets a lot fatter and it generates a lot more revenue, and your cost of operating a system is fairly fixed or diminishing. So the economics align for doing exactly what you're talking about. And I think it'll get done.
Well, I just saw recently sort of this calculation that people played WoW and Fortnite for 140 billion hours.
Yeah.
So, and that's without the economic incentives there. So do you think it's possible that like most of our economy in the future will be people playing video games essentially? Like, okay, so one vision of the future, especially with AI and automation, that people like we get wealthier and wealthier. There's this kind of rising GDP for the entire world, and then people are losing their jobs, but they're still are well off enough to be able to have a high quality of life. So we're all looking for meaning, and the meaning we'll find is by playing video games. And now there's this extra levels, like you can be a Bill Gates within a video game world, in the digital world, as opposed to the physical world. Do you think that's the future?
You just want to have the Westworld. If you can't tell the difference, doesn't matter. Line uttered to you. Did you ever interview Yuval Harari? Was he?
Not yet. Eventually.
Well, yeah, I guess Homo Deus. That's kind of like the roadmap there, right? This hedonistic dystopia where everybody just lives wired into some simulation. And there's some movies about that, Ready Player One, and the other one was Surrogate, and so forth. So yeah, Hollywood has certainly visualized what this could be, but I'm not so pessimistic in that respect. I do believe that the video game world is evolving at an amazing pace. If you look at where Unreal is at, is just incredible, the latest Unreal Engine. And within 1 or 2 more ticks of that clock, the iterations, so 5 to 10 years, the photorealism will be so good that it'll be hard to distinguish between real life and video games. And, the hardware is almost there. So the question is then, when you have photorealistic experiences where you've successfully traversed the uncanny valley to a point where it's good enough, then will virtual reality be more desirable than actual reality? And for the vast majority of people, the answer is probably yes, because actual reality is tough. It's hard, But then your knowledge of that you live in a virtual world actually becomes a problem for you. So there's going to be this kind of sad, dark industry where people try to create amnesia, where they're not aware that they're inside the virtual world. And so that's an interesting...
Why is it sad? I mean, it's almost like
because it's not real. But if you could forget that it's not real, then you believe what you're experiencing is real.
Yeah, but so what? You forget all the ugly parts of life, which is the physical, the meat space, and then you get to enjoy video games.
But it's always lurking in the back of your mind that you're in the Matrix. Well, you have to not be in the Matrix. That's why the bald dude in the Matrix was like, I want to be rich and have a beautiful wife and eat a steak every day. He didn't want to know he was in the Matrix.
So you would take the red pill, not the blue pill?
Well, no, hang on. It depends on how good the virtual world is, Lex.
Well, that's what I'm trying to tell you isn't that what most of the beautiful experiences about human life are, is forgetting for a moment, for a time, like the mess of it?
Yeah.
I mean, that's what love is you forget, like all of a sudden everything is beautiful. But like the reality is you're going to lose that person and most likely love will fade. And no matter what, even if it doesn't, you're both going to be dead soon.
Jesus Christ.
So I'm taking the blue pill on that one.
You went full Ernest Becker on me, man.
Okay.
But no, I get what you're saying though, and actually, but then it begs the question: and goes back to the very first question you asked in this interview, which is like, how do we know we're not in a simulation, or is Bostrom's concepts or these ideas like real? Well, it's entirely possible that we are, and that we desire to be, because the real world is horrifically dystopian or bad, or maybe we actually don't exist. We're completely virtual, and does it matter? And I'd argue that it probably doesn't at some certain point. If you're at the end of your life in your 90s dying of cancer, the fact that you can live out being young, healthy, and 25 is probably a desirable thing. And no one would ever complain about that. Where it becomes problematic is if the vast majority of society enters this virtual simulacra of reality. And as a consequence, nothing works because there's no one to do anything. Society falls apart in that respect. There's no desire to do anything in the real world. Innovation stops. The desire to actually do real work stops because you're always inside this virtual economy. So I don't know. It's an interesting question, but drawing it back more to where we're at today, the evolution factors are there. VR is evolving at a very rapid rate. The game engines are just incredible today, and they're really doing amazing things. And there seems to be an overwhelming desire for people to escape the harshness of where they live, just by evidenced by how many billions of hours have been spent playing video games. People still play Skyrim. Yeah. It's a good game.
It's probably my favorite game of the whole Elder Scrolls series. But, it's fascinating because smart contracts is actually the mechanism by which we take a lot of the meat space stuff and move it to the digital world. So all the stuff we've been talking about is really probably the mechanisms which take us there, which I find that world not dystopian. I find that world quite utopian because there's so many opportunities to create beautiful experiences. But since we're talking about the future, let me ask you the timeline question, or even just like definitional. What is Alonzo? You mentioned some fun Hello World experiments going on.
Right.
And how and when will Cardano get smart contracts?
Yeah, so Alonzo Church is a famous mathematician, computer science guy, and he was a contemporary of Turing. And there was like these three different views of computing: recursive functions from Gödel and Turing machines from Turing. And Church had lambda calculus, and they're all equivalent, and they all give you the ability to build a computer. So we like functional programming. So we decided
that's your favorite Church.
Yeah. So we had to name something after Church, and it's just weird that we never did. So we said, okay, Alonzo is a good release name. Basically, it was bringing smart contracts to Cardano. It took us a long time to get here, and we'll be there in the next 90 days. It's we like everything we do. There's a process, and so there's all the colors of the rainbow. We start with Alonzo blue, and then white and purple. And each step you do some more things, you bring more users in, and then eventually you get to a threshold where you say, okay, everything works the way intended, and you push a button, and we initiate what's called a hard fork combinator event, and boom, the system has smart contracts. You just wake up and it's there. It's like it's in your house.
So it's going to be.
It's like when I got my blue check mark on Twitter. I woke up and I had it.
Yeah,
it's just like Christmas.
And you were never the same.
I was
never. You can't go back. It's like hard fork. It's a hard fork of Charles.
Yeah, exactly.
You got blue. Well, actually, I think you can take it away. But
can they take my check mark away?
I think. But that'd be like a hard fork backwards, I guess. Okay, so great. So that's. But currently, there's a testing procedure going on to see what does that look like and what will give you confidence that things are working well.
Yeah. So first you start with the Mary era, which is where we're right now multi-asset. So you can do metadata and issue tokens on Cardano, but you have limited programmability on chain. Alonzo adds the programmability in, but we already have most of the foundations of the extended UTXO model and the smart contract model. It's just those things aren't ready. So the first step is say fork it. So all those rules are now there. Okay, So that's what we did with Alonzo Blue. We forked a testnet-based layer, and it successfully survived going from Mary to Alonzo, which means that you can move transactions from one side to the other. Both systems work. And then the next step is say, okay, well, are the stake pool operators, people run the infrastructure, able to run this testnet just like they run Cardano? And that's what we're doing right now with Blue. We're bringing all these SPOs in. And then are we able to submit and run smart contracts on the system? And they actually return a round trip. You send something, you get something back. Yay, okay. So that's where we're at. And then what you do is each step, so the next is white, you go from like 50 people to several hundred, and then purple's an open testnet where we want every single person in the entire ecosystem to use it. And it's also a DevNet. So that means that people are writing with Plutus Playground and local interpreters, their smart contracts can actually start testing them now on the public infrastructure. So it's kind of like releasing dev kits to the Xbox or something like that. You send them out to game developers before you release the Xbox so they can test their video games in anticipation of the release of the system. So you run that for at least a month. And as long as it doesn't blow up in your face and, oh God, what have we done? Hindenburg, oh, the humanity. You release it and, you ship it. The problem is it's no longer in our control. There's over 100 exchanges that have listed Cardano. There's lots of wallet infrastructure. There are thousands of different constituencies. So it's less of a technological problem now, and it's more of a coordination problem. So you have to evolve in a very methodical way. And each step of the way, you bring new actors in, they get ready for it, they upgrade their infrastructure to it. And then like shells, eventually you get to the outer shell, which is the hard fork for the general public. And if we've done it right, like that blue check mark, they wake up and it's exactly the same. They just get a little update thing, update your client. And they start demanding Wagyu beef.
Is there stuff you're worried about in terms of like when something's this tricky, goes up several orders of magnitudes in terms of scale? Are there problems that you foresee? Is there like we said, there's game theoretic aspects, all those kinds of things. Like what worries you the most?
I mean, I sleep like a baby. I wake up every 2 hours crying.
Damn, that's a good line. You're full of good lines.
I mean, there's a lot that
you just made me realize that expression makes no sense. I slept like a baby, but go ahead.
Yeah, exactly right. Messing your whole world up right now, Lex. No, I mean, there's so much that keeps me up at night. It's like you're in a cold sweat every day when you have an ecosystem like this because the other thing is you're judged as much by the applications people build on the platform as you are by the platform you've constructed. So, one of the most unfair things that happened in our industry was blaming Vitalik for the DAO hack. He didn't write the code. He wasn't responsible for it. It was a completely independent, different team. And because it blew up, a lot of people just developed this idea, Ethereum is not secure. The EVM is fundamentally broken. And it's true there are some issues there, but come on, that's like saying, oh, well, Photoshop didn't work. Fuck Bill Gates.
Yeah.
And that's the issue is you get as a platform developer, coupled with the wins and losses of your application developer. So if they go do amazing things, it's like, oh yeah, Windows is great. We love it. And if they go do terrible things, they're like, oh man, I guess he's trying to kill all of us. So what we're kept up at night about is not just what we've constructed, but also how do we curate an ecosystem and foster the development of an ecosystem where you have assurance baked into the application and that's somehow expressible to the user. So when you download your smart contract or you click your one-click install to use your Uniswap clone or whatever the hell it is that's deployed on Cardano, you have a little green check mark or something that indicates to you that somebody audited the code or it followed a specification. The lack of that is problematic because then first, there's impersonations, the whole MyEther wallet thing, or like your videos or my videos are the same. Every comment, there's a bot that says, hey, give me some money or something like that. That kind of stuff happens. But then just protocol level flaws, like what happened with the DAO hack, that's what really keeps me up at night. How do you resolve that problem? Because I don't hire these people. I don't tell them what to do. I didn't tell them how to build things on the platform. They may have tons of experience and knowledge. They could be Simon Peyton-Jones, or they could have absolutely no knowledge whatsoever. And they read one tutorial and they've written 3 lines of code in their entire life. And they've deployed something horribly broken, copy paste, and suddenly it all goes to hell. I'm judged by both. That's what really keeps me up at night. And we're, as a company, trying to figure out, and as the ecosystem, trying to figure out standards. Like at University of Wyoming, we're setting up the Smart Contract Engineering Institute. We're negotiating with them right now. And the goal there is just to create some, standards for how to certify smart contracts. And so that you can get that green check mark and know that it actually has some assurance level behind it. But God, that's a huge coordination problem. And it's a huge information presentation problem and incentives problem and so forth. And unfortunately, people who value being first to market will kind of piss in the pool for everybody else.
In terms of, maybe you can comment on the topic of decentralized exchanges. What kind of decentralized exchanges, DEXs, what are they, first of all, and what kind would you like to see built around Cardano?
Yeah, so people want to create exchanges that don't have custodial risk. The point of an exchange is to build you a marketplace where bids and asks can find each other. People can meet and trade. You can find a price and you can get liquidity. So, you got gold, you want to turn your gold into dollars. Okay, well, somebody has to create a marketplace for that.
So like Coinbase is an example of a
Exactly.
marketplace, but it's centralized.
But the problem is you have custodial risk. So when you put your gold and your dollars, or your digital representations of these things into the exchange, what if Wally, Eve broke up with him and now he's really sad and he's gone to the dark side and he's become Wally the hacker. Okay, so he can go and sneak his way in and hack into Coinbase and steal all your gold and your tokens. So instead of you actually being able to swap these things, you've lost all your money. And there's other problems too, like let's say, Daisy has now come in and become a regulator and said, oh, I don't like these exchanges anymore. I'm just going to shut them all down. Yeah, and then you have no access to it. So you have sovereign risk, you have the risk of threat, you have regulatory risk, you have the issue of banks maybe cutting you out. So it's been in our industry for more than 10 years. Mt. Gox was the most famous example of that. They collapsed, I believe, in 2013, and hundreds of millions of dollars was lost over the course of a while. So the point of a DEX is saying, can we do what a marketplace does, but not have Coinbase, not have a central actor run this thing? And there's a lot of problems with that because exchanges are generally creatures of latency. High frequency trading, for example, they do things in the nanosecond. They co-locate their infrastructure with the exchange software just so they can front run orders over other people. I mean, it's crazy the amount of technology that they put in. So the traditional Wall Street version of an exchange is very centralized, very fast, very optimized, and kind of behaves by a very closed set of rules. When you look at a DEX, you have to accept that you're going to have slightly different rules because you're operating in a global systems latency, and you're operating in a system that has different behaviors. However, that said, there's a lot of great protocols that have been built for it. Uniswap has kind of evolved a lot over the years, and we've seen a huge competition and a lot of evolution to basically build out protocols that kind of eschew some of these security problems, enjoy high liquidity, and then also have this beautiful concept of openness. One of the gatekeepers to crypto when you're a cryptocurrency developer are the exchanges. I remember when we first created Cardano, the Bitfinex guys reached out to the Cardano Foundation. They said, oh, we'd be happy to list ADA. And I said, oh, okay. And they said, yeah, we want $5 million to do it. So there was kind of some Italian for go fuck yourself in those email conversations. I think "Vaffanculo" is what I said. But anyway, there was that kind of back and forth happens all the time. And because these guys are gatekeepers, they have this nepotistic control, information asymmetries and so forth. So having a DEX, you don't have that problem. You have open listing. And you basically just put the asset into it. And if anybody wants to trade it, they will. And if it seems like it's a good idea, a natural market will form, market making will occur, and you get liquidity with it. So there's no barrier to entry for that type of system. The biggest existential problem for DEXs right now is the concept of regulation. So basically, right now, when you use Binance or Coinbase or these other guys, you have to go through KYC and AML, know your customer and anti-money laundering. So basically, who are you, and is your money real or not, or are you a drug dealer or something? So normally you do that by saying, okay, I'm going to give them my copy of my passport, and maybe they're going to request some tax records or whatever the best practices are for the particular jurisdiction. And then that exchange is liable if that's fucked up. So if the government comes in and says, hey guys, we pull your compliance records and they find discrepancies, they'll actually put the exchange out of business or fine them very heavily. JP Morgan Chase got $19 billion in fines over the last 20 years for various compliance issues, amongst other things. So it's expensive, a very difficult thing. In a DEX, it's an open system. You just have value coming in, not identity. And so all these things are trading amongst pseudonymous accounts. And so there's no notion of compliance right now for that. So a lot of regulators are coming in and saying, oh, well, this is just a cesspool for terrorism and drug dealing and bad stuff. And they're word salad of bullshit. But, it is what it is. You have to deal with these guys. And so there's been a lot of discussions of, can we take DEXs and we keep the openness and keep the liquidity and no counterpart or custodial risk? And can we add some notion of compliance to that in a decentralized way that doesn't require a single actor to be a gatekeeper? So I think actually by combining DIDs, decentralized identifiers, that's the way to do it. But it's actually the next generation of the technology. It's the regulated DEX. And who regulates that? How does that work? And so forth. But I think ultimately those are going to be the only marketplaces that end up surviving in this current environment if your desire is to exit to a dollar. If you don't really care about the fiat side, like traditional legacy currency, you can always do things in a shadowy, unregulated way. But I mean, it's a personal preference and a business preference.
Can we kind of return to proof of work and proof of stake? There's just so many topics I want to talk to you about, so I'll jump around a little bit. But at the Bitcoin conference, Jack Dorsey spoke. I believe he said Bitcoin changes everything. I think you made a video for Jack trying to explain different ideas to him. I guess describing the difference between proof of work and proof of stake, as we've talked about.
Right.
What do you hope Jack Dorsey comes to understand about the difference between proof of work and proof of stake?
Well, I hope he understands it's just a resource. That's the entire point of the video I was trying to make. Is like, dude, you're like in this cult where you think the only way to be secure is proof of work, and somehow proof of stake is less secure than proof of work. I don't even know how you put those inequalities there, because you're talking about apples and oranges. You're making different trade-offs, and there's different assumptions about the nature of the people involved, but the mechanics are the same. And so it's really more of a question of, what type of system do you prefer? Do you want mercenaries guarding Rome, or do you want Roman citizens guarding Rome? Okay, and as the Romans learn, it's better to have citizens usually doing that. Okay, and that's the only point I was trying to make to Dorsey. And I don't think he watched it or particularly cared, but it was more of a video for everyone, and to start that dialogue of realizing that the real game is proof of stake better than proof of work. It's how do we go from 1 to n, and what should n be? Yeah. You just mentioned that semantical addressable web, going back to IPFS and these other concepts. Well, how do you pay for the enormous burden of storing that much data? You can create a consensus protocol for it. There actually is one. It's called Permacoin. Came out in 2014, 15. Andrew Miller wrote it, and a few other authors. I think John Katz may have been an author as well. But basically, it was just a throwaway proof of work style algorithm that only works if you have large amounts of data. Okay, so it's like your miners are like a hard drive, effectively.
Proof of storage, I think you call it.
Yeah, like this type of stuff. And there's been since then many iterations, evolutions of that type of protocol. Okay, so what if you throw that into your resource bag? Now you have a capacity in your system for storing huge amounts of information that's incentivized by the way the system works. And you can balance that with a proof of stake system. And you can balance that with let's say you have proof of useful computation. We may have a paper on that, who knows, coming soon. And what if you have a proof of useful computation where maybe you can do walkstat or something, who knows? With something like that, okay, well, now you have 3 resources inside your system, and those 3 things keep your system secure, they keep each other balanced, and they just so happen to create the world's largest supercomputer that's programmable, and it just so happens to create the world's largest database that's programmable, in addition to having a shareholder-style model for ownership inside of it to kind of balance these things out so people care about the appreciation of value inside the system. So that was my point to Jack, is you're a business guy, why are you betting all your eggs in one crazy model that's a cult? Step away and realize that does something. It's a tool, but saws aren't the only tool in the toolbox. There's hammers and screwdrivers and other things. Go to N resources, and let's have a real conversation about what would a world computer or a world infrastructure that's useful for your business domain, in his case Twitter, require, and what type of resources would you need for such a thing?
Well, in this case, Square, more importantly. Currently, if you look at Square and Cash App, they support Bitcoin. He is kind of all in on the proof of work idea. Not all in, but currently kind of that's the one supported
I guess there's
idea.
Just a tip in proof of work.
I love you so much, Charles. Thank you. Appreciate this. But I'm not going to run with that, even though I'm tempted to. But looking forward, do you hope Cardano becomes part of Cash App?
I mean, he's a business guy, or at least I'd hope he is. And it's not about what I want or what he wants. It's about what markets want. When you run a publicly traded company, you have a fiduciary obligation to your shareholders to maximize the utility, sustainability, and value of your company. And so if he's running a company that makes money off of these things, it makes absolutely no sense to be a maximalist. You want transaction volume. That's how you make your damn money. Coinbase was the same way. They were very maximalist in the beginning. Very quickly, they started realizing, hey, we're losing a lot of money. If we want to IPO, we kind of need to be a bit more diverse. Eric Voorhees was also a maximalist way back today. Now look at Eric. He's got Shapeshift and all these other pieces of infrastructure. He's a lot more friendly with us alties. So, Jack will make that decision. His people will make that decision, I think, based on market dynamics, transaction volume, and value to the user. And if the concern is actually legitimately security, then the only question I'd ask their team is, can you please provide me a definition of one? Doing POW is more secure than proof of stake as a tweet is not really a proof, okay? You need to actually come out and sit down and say, what is your security model? What do you care about? What do you value? What's the problems you're concerned about at proof of stake? And they never really get there. And that's why I call this maximum like a religion, because it's just like saying, well, the angels descended from the heavens. And it's like, well, how do you know? Well, because the Bible said so, or this doctrine said so. It's like, well, that's your evidence? Somebody wrote something down? Can you please give me a little bit more? They say, no, you're challenging the word of God. In this case, you're challenging the word of Satoshi. And all I ask for is just what is the burden of proof? We wrote the papers. We have security models. We went through the peer review process. God, that was not easy. We wrote formal specifications. In some cases, we formalized those specifications with Isabel, for God's sakes, which is not easy to do. And then we implemented it. And it's running in production with 1 million users at a $50 billion market cap. I mean, at what point do you start saying, well, maybe there's something there? And they say, no, there's nothing there and it's not secure. It can't be secure. And you say, okay, then why do you believe what you believe? And they never come back to me with an answer, ever.
Well, I believe God didn't go through a peer review process when he wrote the 10 Commandments. So sometimes it works out, sometimes not. Let me ask on that same thread, Tesla, SpaceX, Elon Musk currently invested in Bitcoin, but are openly looking to explore other cryptocurrency investments. What case would you make for Cardano?
Well, if they truly care about alternative energy and sustainability, carbon reduction or carbon neutrality, you can't be in a system where there is no built-in mechanism to constrain the energy consumption. With proof of stake, energy consumption is a negative. You want to minimize it. If you can get the same amount of stuff done on a Raspberry Pi as you can a big server, you're going to do it on the Pi, because ultimately that server cost and then energy cost is coming out of your budget. With proof of work, any innovation you come up with to optimize power, you just build more ASICs. Because you say, oh, it's 30% more power efficient. Great, buy 30% more. You keep adding to the work set because you want more hash power, more share of the pie. So you have no energy savings component. And I know these people are saying, well, there's a lot of wasted energy in the grid. And this is kind of incentivizing using that wasted energy. And it's a better way of storing it than batteries because you're now storing it as a Bitcoin instead of storing it as energy. Okay, maybe there's some truth to that. But anyway, it's just...
The energy is a critical point for you.
Yeah, and that's exactly right. The energy is a critical point for me with Tesla because they assert to be an alternative energy company. And unless they can make the case that somehow the proliferation of Bitcoin is legitimately going to proliferate batteries, solar, and wind, or other things, then it's probably good for them to just focus on the most efficient, energy-efficient cryptocurrency possible. Otherwise, you're exacerbating global warming. You're exacerbating the ecological consequences of it. The other thing is Bitcoin is the least programmable of all the cryptocurrencies. And if you want to do interesting, sexy, unique things, let's say Tesla, for example, they want to start doing V2I and V2V for autonomous vehicles and have the vehicles start talking to each other and connect it to 5G. Well, imagine if you want to build a telco coin or some sort of 5G coin and you want to build an IoT layer and network. There's just no real way to do that on Bitcoin with the way it's designed. So you'd need fundamentally different infrastructure to create such a token and regulate such a system and have these things autonomously negotiate and do business with each other. You need DEXs and stable coins and all kinds of mechanics to make something like that possible. Well, that's really beneficial to Tesla if they could figure that out. because they could create like an information sharing incentive scheme where if the cars talk to each other, including other branded cars like GM cars and Fords, they can now actually get data from those cars through a marketplace in exchange for the benefit of autonomous driving or for the benefit of understanding road conditions or safety enhancement and so forth. So it's just depending. Are you just here to speculate? Are you here to actually use it as another medium of exchange, or do you actually want to build infrastructure on this thing? The more closely you get to utility, the further down the road you get there, then the more programmability you need. And so it makes a lot more sense to be an Ethereum fan or a Cardano fan than to be a Bitcoin fan.
So to be both proof of stake and have the smart contracts capabilities.
Yes. And that's why we went over Ethereum, because they're proof of work.
You mentioned God. God spelled backwards is dog. How's that for a transition? And Elon Musk and Tesla are at least a little bit curious about a coin called Dogecoin.
Right.
You made a video directed to Elon on how to improve Dogecoin. What are your ideas for making Dogecoin even better than it already is?
Well, Dogecoin is just it's like that Nine Inch Nails song, a copy of a copy of a copy. Yeah, it's just a copy of a copy. Bitcoin gave Litecoin, Litecoin gave Dogecoin, and it was kind of a parody cryptocurrency. And I think Jackson was trying to do it to like prove a point about altcoins, and then true to form, it's like nobody got the doctrine and completely perverted the entire religion. It's almost like the Emperor of Man and Warhammer 40K. It was like this atheist, don't worship me, and now there's like this whole religion built around the Emperor. So Dogecoin has become a thing, and it's become such a large thing that it is a reasonable target for somebody to fix it up and repair it, make it an interesting cryptocurrency. The point of the video was to show what a modern third-generation cryptocurrency really would require. It's a major overhaul, and there are already people doing this. There's the Solanas and the Harmony Ones and the Cardanos, Neoses, and all these other guys, and they have billions of dollars and huge dev teams and all these innovative protocols. If you're really serious about this thing sticking around, being useful and doing stuff, then the point of the video was to show the types of things you'd have to think about and the types of papers that are all open source, patent free, and don't have any notion of intellectual property behind them that his engineers could grab and go and do. And he did mention on Twitter that he was looking for feedback on how to improve Doge. And so I said, all right, well, I'll just put all these things together. It was a little tongue-in-cheek because I figured he'd ignore it. But it was also showing how hard it is to innovate in this entire space. You don't just go and say, I'm going to go build a battery-powered car or rocket or enter a new industry. It's really hard to do that. You spend years and lots of effort. You have to do a series of small learning steps. You have to pick up destroyed rockets on the side of the beach and things like that before you get to the rocket landing itself. Well, analogously, it's really hard to build a cryptocurrency. Satoshi probably spent years thinking carefully, and that work was a derivative of 30 years of work in the digital asset space starting in the 1980s, working its way through. So, and then Bitcoin only did very limited things relative to what Ethereum can do or Cardano can do and so forth. So the minute that you extend that complexity, you're talking about years of R&D, years of engineering effort that needs to be done. So what's the point of Doge? Is it just a meme? Is it actually contending to be useful? Or is it competing as a store of value against Bitcoin? Now, if it's competing as a store of value against Bitcoin, why the hell does it have the monetary policy it does? Also, there's predatory distribution of the underlying asset. And over 90% is consolidated, less than 1% of the holders.
For Dogecoin.
For Dogecoin at a very, very low price point. So they can sell at almost any price point and make a profit. So, it hits 50 cents, they're billionaires. And it's not like 20,000 people. It's probably less than 100 wallets that have that distribution. So there's this existential ticking time bomb that's in Doge that once the guys who are vested start selling, they can just keep selling and ride it all the way down and make windfall profits regardless of what price they sell at. And who are they selling against? The retail investors. People who make $500 spare money a month or something like that. And it bothers me because I see it in my community. So I live in Longmont out in Colorado, and I was at a restaurant and I was talking to the waitress and she asked me what business I was in. I said, I'm in the cryptocurrency space. And she's like, what is that? And I started explaining all of it. And she says, oh, yeah, I own some Dogecoin. I said, you own anything else? No, I just bought some Doge. Why did you buy Doge? Oh, I saw Elon tweeting about it. And I thought it was a good deal. So when you see stuff like that, where people have no clue what they're doing, they don't really understand the supply dynamics, the ownership dynamics, and these types of things. And then when the clock stops, they're the ones who get hurt. And then the regulator comes in, the Elizabeth Warrens of the world, and they say, see, this is an evidence these guys can't regulate themselves, control themselves. We need to control everything. Either let's ban it, or let's just announce that the only 3 are legitimate, and every one of them has to be connected to identity, and rah, rah, rah. And I'm just very concerned that that's a bad thing to do. And that's why I've been so vocal about this topic. And my hope is that a compromise can be made where real developers come in and they start working on Doge and they find a way to create some sort of use and utility for it. So at least it has a value floor and, it won't collapse.
Is it possible for Cardano and Dogecoin to work together somehow?
Yeah, it'd be a lot of fun. I'm not adverse to the idea of cleaning up the code base, but legitimately whoever comes in, be 2 years or 3 years of work, because you have to do real stuff. And that code is like Litecoin circa 2012, 2013.
Well, the interesting thing about Elon, and I've got to interact with him quite a bit, that combination of humor and extreme ambition, like in the face of impossible odds, is something he does really well. And so I think that's the spirit of Dogecoin, is fun and almost like bold, ambitious innovation. And so I think you can't discount the power of that.
But where's the innovation? What's the agenda?
Well, this is step one.
What's going to Mars for Dogecoin?
Well, he came in the same way to rockets. He came in the same way to electric cars. Seemed impossible at first, but you step in and you solve the problems, first principles, one at a time.
But I'll challenge you a little bit on this, because I think he had some trends that he was very smart to recognize. In the case of battery-powered cars, he said, hang on, everybody has tablets and cell phones and these other things, and there's an incentive to make batteries better, faster, cheaper, and charge faster. And that's connected to mobile computing. So regardless if you want battery-powered cars or not, every year you have billions of dollars of R&D being pushed to force this capacity to evolve. And he's just getting on the train and piggybacking on that. So that was a brilliant business acumen to recognize that. In the case of SpaceX, it was just an obvious question. If every time you get on a plane, you have to throw the plane away, no one would fly. So reusability is like a fundamental thing that if you solve that, you've now opened space up to a complete new class of commercialization. I don't see the problem in Dogecoin, because if he was looking for it, then why not look at a real platform actually trying to solve a real problem? There's so many of them. He throw a rock, he can hit 15 of these guys, and they'd all die to work with Elon Musk.
Yeah, it's very interesting. I mean, so first, I could continue pushing back on your intuition about electric cars and batteries and so on. I don't think it's more obvious in retrospect than it is in at the time, I would say, because I would agree with you on the batteries front. I wouldn't necessarily agree with you with the electric car. Because first of all, nobody started a successful car company for decades.
Well, but it was the loyalty. The EV4 guys, or whatever it was with GM, they didn't want to give them back when they had the lease program.
So there's some basic intuition that there is some hunger here, but it's not obvious that you can do it successfully. And with relaunching rockets for cheap, that sounds good on paper, but to do it well, NASA is spending way more money for this. And the Russians were assholes, not selling any rockets. So you have to do it all yourself from scratch. How do you build a team? How do you launch rockets when if you fail a few times, you're going to go bankrupt?
Right.
I mean, it's just business-wise, I would rather build an app like Angry Birds.
Oh, yeah. He's got
than launch rockets.
You got to give him credit. He's got boulders for balls. That. It's a good picture.
Yeah, thank you for that. But maybe that's what, I mean, I think there's not enough first principle thinking on the cryptocurrency side. I think I agree with you on that. But there's some aspect to which the seriousness of the cryptocurrency world is paralyzing. So in some way, the innovation that you spoke to requires taking risks, requires not taking everything so seriously, like being afraid to take those bold risks in the space of ideas, not in the space of financials. So in that way, I think that's one pro for Bitcoin is there's room. It's hungry for innovation. But I think Cardano in that same way is hungry for innovation, just like as you said, with some more rigor and formalism behind it. And even Ethereum has a hunger for innovation. That's where Bitcoin is a little bit more, I would say, conservative in terms of how much innovating they're willing to do, in terms of the incentives they built into the systems for the evolution of the cryptocurrency. But yeah, I mean, it's difficult to psychoanalyze why Dogecoin is the thing that excites Elon so much. But at the same time, there's some power to the fun. It sounds ridiculous to say, but the fun, this idea that the most entertaining outcome is the most likely.
Right.
There could be something built into the physics of the universe that makes that true, because the viral nature of fun has power.
Well, it's a neuroscience thing. We like dopamine. We like these chemicals in our brain, and when we have fun, we want more of it. So you tend to gravitate towards work activities and play activities that are enjoyable to you. And it is nice sometimes to kind of come in and troll an entire industry.
Yeah.
And I can imagine he's probably having the time of his life. It's the same as like taking Tesla private at 420.
Yeah.
That kind of stuff.
Yeah.
And it's one thing when you do it with friends. It's another thing when you do it with the whole industry and it hurts people financially. And also I understand he hates short sellers, and there's some things there. And I can't speak for him because I only know the guy from a distance. It's just I live in this space and I have to deal with the consequences and clean up the messes.
You feel the pain.
Yeah. And if this results in a regulatory event, it's like I'm the guy who has to put on a suit and go to Washington and go and sit in a Senate inquiry and all this stuff. And he's the guy that, just like laugh with his friends about how he crashed the crypto market and how easy it was to do it. And that's my only umbrage about this. On the other hand, if it brings a lot of cool, new, interesting things and people into the space, that's a net positive. And so, it's not universally bad or universally good. And I'd like to give people the benefit of the doubt. And so I'm really hopeful to see what comes about this recent surge of interest. And if Elon actually puts his money where his mouth is and takes some of his enormous engineering talent and capital and starts contributing and building something in the cryptocurrency space. It'd be really cool to see that happen.
There's a bunch of different technical aspects I want to ask you about on the Cardano side. So first, maybe on the scaling side, what is Hydra? How does Hydra compare to other different ideas for scalability, like roll-ups?
Yeah.
Main trade-offs with respect to security, UX, and anything else you want to talk about?
You have to have a little bit more energy, Lex. Come on.
You know what I need? I need that Coke machine that you mentioned, the thing that converts water to cocaine.
Cocaine from Director Bullock. we'll leave this in, right?
Yeah.
Isomorphic state channels. That's a great topic, right? There's a word salad of cryptographic terms. Whether Lightning, Hydra, rollups, any of these things, really what you're trying to do is say, okay, if I do it on layer 1, it's slow and expensive. What I'm going to do is batch something somehow, some way, and then do it in a different system where it's fast and cheap. And what I'm doing with that is I'm losing some of the security guarantees of the base layer and admitting a slight higher degree of centralization. But then I get super fast settlement. I get super low cost transactions. And potentially, I may even be able to get distributed computing, meaning that instead of having the smart contracts run in a replicated system, they can run on a single node, like a stake pool, and their stuff is different from the other guy's stuff. So you go from a system of capacity of whatever it is to a system of N for the totality of all the stake pools. So basically, Hydra is just the next generation of that when you have the ability to tinker with the accounting model. And the layer 2 solution is co-designed with the layer 1 solution. So it's like what Lightning would have been had Lightning been co-developed when Bitcoin came out. There would have been special provisions made in Bitcoin specifically to accommodate Lightning, and it would have made it very easy for you then to move inside the system, outside of the system, and have security properties preserved, like availability, for example, or fraud resistance. Say, oh, you can't steal the money, or these types of things. Where things get really complex, and this is why Hydra is novel over Lightning, is when you want to move beyond payments to state management. Okay, so payments are just, I want to move between Alice to Bob as quickly as possible, as low cost as possible. So for example, I have a micro tipping application like Change Tip on Twitter, or, like a video, I'm watching a YouTube video, like maybe this video in the future, and people really like it and they click tip and you get 5 cents or something like that. Okay, so that's an example of a perfect payment application. And that's great. But what happens when you actually have a rich smart contract like a DEX, or, you want to do a video game or something like that. You want to run that off chain. But then there's some reconciliation on chain. that happens. So a state channel basically lets you do that, but it's a lot more complicated and there's a lot more to think about. So Hydra basically just has in its design a collection of ideas of how to do that. And the current paper is for a single head. The next thing you do is composition. So you go multiple heads and there's a routing protocol between them. And then eventually create these tail protocols for when things get asynchronous. So instead of always being a line and always being available, what happens if they die for a bit and then they come back? And you can create all kinds of guarantees that your funds won't be lost or locked forever or things like that. There's a failure recovery mode for this type of stuff. And basically the idea is leverage what Lightning has already achieved with Bitcoin, but then take advantage of the fact that you have a more expressive accounting model and a more expressive programming model, so you can just physically do more and you can put more crypto into that thing. Now, contrast it with rollups. Really, that is just saying you're going to take something, batch a bunch of transactions together, and you're going to generate a proof. And then what you can do is whenever you see some part of that history, you can check it against that proof that's rolled up. And there's closely related concept of recursive snarks that you'll see a lot. There's things like the Mina protocol or other things. And basically the idea is that whenever you see something, you can always generate two proofs, an existential proof that the coins exist and a non-existence of a double spend. So you can always check those two properties. And the proof is verifiable in logarithmic time, ideally. So you can have giant amounts of data, but it's very small. The actual proof is concise, okay? So they're just different boats for different floats. The advantage of a layer 2 network where there's actual channels and there's interaction and there's service providers is the channels can eventually scale in the collection of things that they can do, and eventually they can become interoperability networks between cryptocurrencies. So at some point, we could modify the Bolt spec and make it somewhat interoperable with Hydra. And then what you could happen is you could use it as a bridge to actually do cross-chain traffic and send transactions between the systems. You don't really think about that too much when you're talking about rollups. That's more of optimizing what you have within the system.
Within the chain. So what can you elaborate how it's possible to do cross-chain traffic?
Well, you already have the intermediary, you have the channel operator, and you already have Lightning
switch
protocol, right? And you just build a DEX that runs within that system, and they can swap assets, or you can do wrapped assets. So you lock
like low cost. I guess you could just switch low.
Yeah, the same thing lets you batch things on one will let you batch on the other. So if Lightning works on Bitcoin and Hydra works on Cardano, you can eventually bridge these two together and create a way of moving back and forth. And the same things that make transactions in and out of that network cheap will make creating wrapped assets cheap. At least on the Bitcoin to Cardano side. You can't create assets on Bitcoin. Another flaw of Bitcoin that they've never fixed.
What's your thought about layer 2 technologies in general? Is there stuff you're excited about? We talked quite a bit about Lightning Network, Hydra, these ideas. Do you think there'll be somebody that wins out, or is this going to be this kind of dynamic thing that we just keep building different ideas and they all interact with each other?
It goes back to biology, that cell differentiation concept. Is you have to build specialized tissue to do things. The point of layer 2 is to extend the network. It's adding a foot, it's adding an arm, it's adding a brain, it's adding a heart, it's adding eyes, giving you additional senses. You have ears now. So when you add these layer 2 protocols, like Atala Prism is a perfect example of that. We don't have identity at the base layer of Cardano. It's a real bad deal to do that, because then China will come in or US will come in and tell you how to do that. Mm-hmm. What you do is you build a layer 2 protocol that's blockchain agnostic, and then the user can decide when and where they need an identity and then bring that identity into the system. And if you designed it right, when they bring it in, it's very easy, very fluid, and suddenly the experience enhances. Everything just gets better. Oh, wow, okay, now I can use all these regulated things. They go from gray to green in the App Store. That's so cool. Or, oh, wow, now I can send to human readable addresses, because if I have an identity and you have an identity, we can alias them with some namespace. And now I sent to Lex instead of some horrible Beck32 address structure. Okay, so that's really what you need to do with layer 2 is say, okay, each layer 2 protocol is meant to do something. Either it gives me payments or lower cost smart contracts or interoperability or identity. And then it's a marketplace. So you should have blockchain agnosticism with your layer 2 solutions. And so you can mix and match and choose whichever collection of services you need. And that's actually how IT works these days with microservices and these other things and cloud software. Every firm is an aggregation of dozens of providers, and basically that composition of them is your software stack.
Jumping around back to proof of work. what are non-interactive proofs of proof of work? NIPoPoWs.
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 NIPoPoWs. It's fun to say, right?
NIPoPoWs.
It's just one of those things that you notice that certain proofs of work, when you solve them, come up less frequently than other ones. And just by that nature, you can sample them and then construct proofs from them. So you can, with that just set, have a more concise representation of an amount of work for a range of the chain. So that word,
can you say that again?
Yeah, I was going to say that word salad, basically the idea is, okay, so let's say that this block, and I'm just simplifying the concept a lot. This block, you get a regular green type of proof of work. And then this block, you get a green, and you keep going, and then suddenly you get a red one, okay? So it's still a valid proof of work, but it's more rare than the other ones.
Yeah.
Okay? So if you notice that particular pattern, what you can do is you can just start not caring so much about the green ones, and you can just bookend your chain with red. Okay? And then you can just repeat that and repeat that, and you can create this really compressed representation of these things. So what does it mean? It means that suddenly when you have that, now you have a way of representing a long range of history with a very small proof. So you can use it for light wallets, and you also can use it for sidechains if both sidechains use proof of work. So when you see a transaction come in, you don't have a copy of the sidechain, but you have a copy of the proof of work, and it has the same algorithmic weight as the normal longest chain. Because you don't have all the greens, but the reds only occur with a certain sampling frequency. So this is the brainchild of Dionysius Zindros and Agalos, and it's just an amazing paper. And what's so cool about it is it doesn't require any structural changes to proof of work. It's just something you notice as an off-gas of proof of work. It's like you're watching an engine operate, and you notice like every 500 times a piston will do a certain weird thing. And so you take advantage of that. You say, well, if I count 10 of them, now I have 5,000 pistons strikes. Because I observe that pattern. And so it's the same concept there. And it's just a property of the engine. So you don't really need to hard fork it in. It's just there. And because you can build proofs that way, now you can use those proofs to do light clients, and you can use those proofs to do other things, because you just use that as something that comes with the history. You don't have to have the whole blockchain.
Now, is this a weird property of multiple proof of work chains? Or
it has to be keyed to the particular consensus algorithm, but usually there's some portability in this type of thing. Like we're right now exploring, can you do NIPoPoWs with Prism or any of these sharded proof of work protocols? But it looks like you can. The closely related is log-space mining. So you can use this concept, and instead of having the entire blockchain to be able to mine, you can use a compressed representation of it. We wrote a paper called Log-Space Mining that basically explains how to do that. So your miner only has this very small micro ledger as opposed to the entire ledger.
How does it connect back to the entire ledger? How does the
because you have those red blocks, you have those special things, and so you know that the state you're working on is actually legitimate, right?
So the map goes both ways?
Yeah. Pretty cool.
Wow, that's really interesting.
Yeah, and Dionysius is a genius. He's a really, really smart kid, and he got his PhD under us. He went to University of Athens, and he was Agalos' graduate student, and now he's doing a postdoc at Stanford under David Shee, and this is literally the only thing he does. He does interoperability, sidechain stuff, NIPoPoWs, and so forth, and he's written a lot of great papers on it. And that was a testimony to hard work for getting the paper published, because the paper came out in 2016, but I think it took 3 or 4 years for it to go through peer review. Oh, wow. He kept trying to push it one conference after rejection, after another rejection, but he got it through. Real proud of that kid. And then he's just doing all this beautiful derivative work now, like log-space mining and so forth.
So, Reddit, any sentence that starts with Reddit, you know it's going to be fun. The top question on the Cardano subreddit, which is quite a wonderful place, by the way,
Thank you.
Was, can you get Charles to play devil's advocate against Cardano? If it's going to fail, what would failure look like, and what are the most likely reasons it would fail?
Okay, well, there's the failure. For example, I said one of the project goals was to achieve self-evolution. So if it doesn't achieve that, where it can evolve itself iteration by iteration, then obviously the product didn't do what was intended. Right? If it continuously required the supervision of custodians in order for it to succeed, the system just won't work. The good news is we have a lot of data showing the opposite. We used to run a federated model, and now we're completely decentralized for block production. But that didn't just happen overnight. I mean, there was a whole process with the incentivized testnet and the Stakepool Pioneers program and the launch of shelling and the decrementing of the decentralization parameter. And every step of the way, people showed up and had to do things. And we went from several to thousands of people who were regularly maintaining the infrastructure. But there's no guarantee that that would be sustainable. And there's no guarantee that the next step, the smart contract step, will achieve what we want. And the next step, the governance step, will achieve what we want. I mean, it's an experiment in all these types of things. All cryptocurrencies, all companies are, in a sense, experiments when they are evolving the business model. And as our case, our business is systems and society. We're offering to the world a vision of how to run humanity in a different way. And the only way the system can do that is by millions of people joining the system, self-evolving the system, and growing it in that particular direction. Another failure scenario would be the system evolves in the wrong direction. So it's self-evolving, but it goes into a more centralized dystopian way, and that's problematic as well.
What would that look like? What would dystopia, the self-evolution toward dystopia, look like?
A small group of actors have total control over who gets to use the system and how they get to use the system, and your use of the system is monitored and shared with that small group of actors. So social credit in China is a great example of that. A small group of people have access to that, and then your experience in Chinese society is determined by it. So that's an example of a failure mode. And then another could be just network effect. We start experiencing a churn rate, and the inputs don't match the outputs, and that you lose more than you gain, and then over time the system dies off. However, that's really hard in practice. Once you reach a certain network effect, even if you become stagnant and stale, you tend not to lose your users. And our evangelism is unbelievable in the Cardano community. I think we're number one for tattoos, And that's, if you think about that, it's a strange metric to have, but there are brands that associate that way, like Apple and Harley Davidson and so forth. People tend to actually tattoo the logo. Those people don't leave. They don't actually walk away from the ecosystem. They're fanboys to the core. So there's a lot of people that are here for life. They don't care if it's dollar ADA, 2-cent ADA. They believe in the mission, vision, and value of what we wish to achieve, and they've become evangelists in that respect. So the question is, does that community sustain itself? And also, does that community not make the same sins and mistake of Bitcoin, where they become toxic and maximalistic, and they start becoming highly religious about whatever beliefs they have? My hope is our community will be open and Socratic and love the scientific method and be willing to entertain ideas without adopting them and discard ideas that are proven to be wrong. If we become dogmatic and embrace an orthodoxy that is counterproductive to innovation, then it'll stall out the ecosystem. And you'll notice I never said price in any of this. I never said, hey, failure is if the price goes way down and success is if the price goes way up. That's unfortunately the metric that most people use, but I couldn't care less about it. Because, if the reality is, if you construct a system that encompasses the entire globe and has billions of users, it's probably going to be a pretty valuable system. That's a secondary thing. It's an after effect of having success in adoption, use, and utility. Unfortunately, most people on Reddit and Twitter and other channels, they tend to just judge your entire success based on that. I had very few people when Shelley launched, even though it took us 4 years to get there, a lot of work, say congratulations on Shelley. But I had a lot of people when ADA reached $1 say, we're so proud of you, amazing work, congratulations, and so forth. And that's probably the most disheartening thing about the whole being around and doing this stuff, where all the things you do only matter as long as it's making someone else rich. And in a way, I feel almost like a failure, because that mindset means that we haven't yet inculcated the community in a proper way, saying, hey, guys, this is about more than money. It's about more than the value of ADA. What we're attempting to do here is re-engineer the way society works. I'd like your voting to be different. I'd like your property to be different. I'd like you on your cell phone to have a universal wallet. And when you go to Starbucks or wherever, you can buy your coffee with silver or gold or airline miles or something like that, and they get paid whatever the hell they want to get paid. And I want those rails to be done with a system that puts you in charge, not someone else. And they say, yeah, that's all fine and great. As long as ADA is $5, we're all happy. You see, so that's a problem. There are, of course, other things that could fail. Like, we could lose project cohesion. Lots of people could quit and die. But again, there's so much momentum. There's so many things here. The ideas are already out there. And there's no intellectual property. When you publish 100 papers, you write 1 million lines of code. That's something, and it's permanent. And it's in the commons now. So it's just as much yours as it is mine. So there's no notion that somehow, if the core development company disappeared, then that a concept is lost forever, like the Library of Alexandria burning to the ground. It's there, and someone else will take it, fork it, and get it done.
So, I mean, first of all, that's fascinating. The self-evolution, you don't know which trajectories that's going to take. But also there could be singular events, like bugs in the system create an opportunity to hack the system. Is that something that you see as a potential failure case?
Yeah, it's always a possibility. Bugs can exist. There can be flaws in the protocol design. Zcash was a great example of that, where there was a subtle flaw and it damaged the fidelity of the cryptocurrency in ways no other cryptocurrencies ever experienced. Normally, when you have a bug, the bug, you can see it, like the Bitcoin overflow, the value overflow incident. Yes, Bitcoin can be created, but we can verify they weren't. So the monetary policy is preserved. When you have a bug with a private system like Zcash and it exists on the shielded side, there's no guarantee, unless you can audit the total supply inside that shielded side. My understanding is you can't, that somebody didn't exploit the bug and create trillions of these coins out of thin air, just hiding them on that system and dripping them out. And so the monetary policy is forever damaged as a consequence of a bug like that. It's probably the worst type of bug you can have for these types of products. So, no matter how good of a job you do, they have great scientists, there are great people there, great engineers there. You can always have something like that seep its way in, leak its way in, and that lurks in the distance. But, if that's a problem shared with every one of your neighbors,
That's true.
It's like everybody working on a nuclear power plant. Well, yeah, you can all die of radiation poisoning. Well, we all kind of knew that, didn't we? So
Yeah.
so it's like I don't really think too much about it. I think the context of the question was more, what is Cardano specific over Ethereum or Bitcoin or any of these other things? And yeah, okay, an existential lurking bug could happen. It's lower probability for us than the other systems because we use formal methods and we use peer review inside the protocol design. So there's been more eyeballs and tools and techniques used to check things. And we actually have discovered a lot of weird, wonky bugs before production and resolved those bugs. So it shows you the system works. It's a lot of fun.
What about close kind of competitors? I don't know if you would put it that way, but if you look in the space of ideas, competitor cryptocurrencies like Polkadot, what are some interesting differences between Cardano and Polkadot? Technically, philosophically, historically, is that something you think about when you think about the future of Cardano?
Yeah. I mean, we do. We actually have a whole group of people that do business intelligence and comparative analysis, and we're getting to a point where we want to start eventually forking their code and running private versions of it, and just playing around with things.
Well, that's
getting
fascinating.
Better understanding. Consensus actually does this. They actually did it with EOS, and they wrote this lovely report like trashing EOS, saying, hey, by the way, all those claims these guys made are just not true. But it's nice to do that. It's nice to use your competitor's technology or, competing protocol technology because you learn a lot along the process. It's not all bad. There's always something there because they have different trade-offs and customers that potentially are more interesting. Like right now we're grokking, how do we want to do the sidechain model of Cardano? Polkadot's actually a tremendously useful piece of infrastructure for that conversation because they copied part of our infrastructure. Gavin's a trained computer scientist. He got his PhD from York, and he read our papers, obviously, and he realized that Ouroboros was a really good starting place for building a proof-of-stake system. So Polkadot's consensus is very similar to ours. And so if you're saying, hey, how do you do a good sidechain model with an Ouroboros-style proof-of-stake? Well, we already have this parachain thing, right? And so now by just looking at that, I can kind of get an idea of one way of doing it. And so that's just beautiful that we live in a space where that's there, it's open source. And if it's really good, you just say, okay, well, we'll just take that and adopt that. There's no shame, The other side of it is that Polkadot really has focused a lot on commercial adoption, Silicon Valley adoption, getting real use and utility. I say in a much more sustainable way than Ethereum is focused on. Ethereum was kind of a spray and pray thing. Polkadot was more of like, hey, let's go ahead and actually curate our ecosystem more carefully. And we're going to build it in a way where there's predictable or as predictable a cost as possible with the rollout of the infrastructure. And, that's so important for a business. It's not necessarily important for an experiment or a startup where, they're just trying to get population as quickly as possible. We'll figure out later. But if you're actually sitting here saying, I need to know what my expenses are 3 years, 5 years, 10 years into the future, you need predictability there. Mm-hmm. I think they have a better shot of it than anything in F2 or with currently Ethereum. Now, the big contrast between the two systems, though, is We actually have native multi-asset. We have a different accounting model. I think our base ledger is far more expressive. Our rate of evolution with proof of stake is much faster than theirs because they're based on derivative work, and we already have Ouroboros Omega and other things there. And I think we have a better, ultimately, a better sidechain model will come because we have something called Mithril for that. But we learned a lot from their work. The other thing is that we thought about governance a lot more carefully, in my view. And we have Catalyst and Voltaire, and really the key there is saying, how do we make sure that every single person who holds data can participate in the network? That wasn't a high design priority of Polkadot. It was more fast commercial adoption, the acquisition of customers. We'll come to governance later, and those were just different business philosophies. But it's nice to have a competitor like that. And oftentimes I've said that Polkadot's like Ethereum 1.5. It's what Eth2 probably should have been. There was what Vitalik wanted to do, which was incredibly aggressive and brilliant, but it's a lot. And there's so much execution risk in that plan. And I think they've had like 6 years of playing around with it. Had they gone down the Polkadot road, they probably would have been in market with it in 2018. And because they already had the network effect, they would have had years of building on that, iterating that. And they already had a path to it too. All they had to do was just give Elaine Shih and her cohorts at Cornell, a $5-10 million grant. And Snow White would have been the dominant protocol, not Ouroboros in the proof of stake space. So it's really fascinating historically when you look at these things and the rivalries and what they did and what they didn't do. And, Gavin had a chance to have C++ Ethereum be used as as IBM's enterprise blockchain. The only reason they didn't do it is, it was licensed GPL, and I think they wanted to relicense Apache. If you ever talk to Bob Summerwall, he was there at the time, and he had this amazing story about like these terrible fights where, it's like, guys, just relicense the goddamn code. Let's figure out a way to make this happen so that we can, get this huge network effect of being basically IBM's play. Mm-hmm. They didn't do it. They created Fabric. These types of things. So there's a lot of lore and stories in that respect. But the space is better because of Polkadot, and there's a lot of good people there. Web3 is a good concept, and we run into their people in Germany and Zurich a lot, and they've always been cordial and friendly and really affable.
Before I talk to you about governance, which is one of the most fascinating things about Cardano, because there's a lot of stuff to untangle there. Since you mentioned some humans in this wonderful story, you did make a video before we talked, directed to me. Thank you so much for that.
It came from a place of love.
But it was basically saying, as we have been, you would love to talk about the technology, about the future that you're creating with Cardano, and just the future of the cryptocurrency space. I think you were kind of worried that you'll be talking to a journalist that's looking for clickbait content, that kind of thing. But I'm fascinated by human beings. I think you're all, from an outsider perspective, incredible human beings. I don't know about personal intentions, all those kinds of stuff, but I think you're changing the world together in different ways. And I just wanted to sort of give you an opportunity. If there's, in the name of love and friendship, is there something from your history over the past decade or so, outside of technology, on the human side of things, that you draw inspiration from, you draw insight from,
right?
You're just proud that happened?
I mean, it's like asking Paul McCartney about John Lennon. He's like, tell us about John Lennon. It's like,
and how much do you hate Yoko?
For almost 8 years now, it's just been this reoccurring pattern. Every interview, tell us about your time at Ethereum. Those 6 months you spent there that were so pleasant and enjoyable. Tell us all about it. And tell us about your relationship with Vitalik. It's like, I barely talk to the guy. I see him every now and then. Like every 2 years we say, hey, he says, hey. It's like, okay. Maybe 10, 20 years in the future, Walt Mossberg or Robo Walt will bring us together like he did Steve Jobs and Bill Gates. And we can kind of talk about,
that was a tense conversation, by the way.
The 2007 interview?
Yeah, the 2007.
Oh, it was great though, wasn't it?
Yeah, that was the body language. That was art.
Yeah.
That was fascinating. That was a fascinating study of human nature.
Yeah, so maybe that'll be us in like 10 or 20 years. Who the hell knows?
The robot versions of all three of you.
Yeah, my only point though was that, it's a closed chapter, and it's funny. I was there for 6 months. I've been building Cardano for years. We've done all this stuff. I've been to 52 countries. I love talking about those experiences, and there's so many of them. I've met heads of state. I was Mongolia, like eagle hunting, and being bucked off horses and riding the sand dunes. We've invented all this new cool technology that's the space itself is using, and we've had a chance to sit on government panels, pass laws, 24 laws in Wyoming. I mean, there's like all this amazing stuff that's there, and it's such a fun conversation. There's so many superheroes in that conversation, like Kaylin Long and Taylor Limholm, and there's Alex Chepurnoy, who we already mentioned, that I met along the travels. I met Ralph Merkel. Cool. I met all these amazing people along the way. I have fond memories of, by the way, you should interview him, by the way. Amazing guy. He does nanotech now. I met, I was hanging out with Sylvia McCauley, and I remember before he launched Algorand, I said, you should really just do a Bitcoin Cash style play and airdrop Bitcoin. What the hell are you doing distributing this? And he's like, trust me, I know what I'm doing. So it's like so many great conversations and so many great people. And what I've really noticed in this industry, when you separate the tribalism, the maximalism aside, there really is a love of creativity and building. And there's like no other industry like it. I've been in many different places in life, and here people just love art. They love beauty. They love the unknown. They love pushing things. They love, really, in some cases, not necessarily the most socially beneficial way, but they really love the challenge, right? And that has been fun. I wouldn't trade it for anything in the world. The dark side of the industry is that people love labels. They love saying this person's good, this person's evil, this person's a sociopath, this person's not. And by the way, they've never met that person. They've never interacted with that person. And they just say, well, I heard from this person, or I read this book, or I did that. I was like, oh, so some books written by a journalist makes $50,000 a year who's looking for a movie deal, say that somebody said this or did this in an unconfirmed way. So what can you do? Sue them for slander? I mean, so you just let it ride and you let it roll. And if it was just ending there, that'd be great. But the problem is it cascades, and people just repost it and they relive it again and again and again. And then what do you do about it? You eventually just say, I'm not going to talk about it anymore. I'm done with it. And you move on and you say, you know what? If it's your problem, it's your problem. It's your reality that you want to live in. I'll be defined by the things that I achieve and do, and the people that we help, and the things that we build. And, since I started in this industry, I've gotten to a point where not only do we have this amazing company with these incredible people who work at this company, but we also have the ability to pursue amazing different interests. Like I met Ben Gortzel, and Ben and I are going to do an AGI project together, and of all places, Rwanda. And he gave me this 85 fucking page paper. He was wearing that damn hat that he always wears. I think he showers with the hat on. He never takes that thing off.
I think he refused. I interviewed him, and he refused to tell me the story of the hat.
He wouldn't tell me either. I interviewed him as well in Wyoming, and every time I call him, he'll have his shirt off. He'll have the fucking hat on.
And now all I can think about is the hat.
Right.
I wonder what the story there is.
I know it's like it's got to be.
That might be the AGI.
Yeah, exactly. But anyway, he gives me this 80-page paper. And he says, Charles, it's like the culmination of everything. This is how we're going to do AGI. And I said, that's crazy, Ben. And I said, I'll throw some money at it. So we're going to hire some developers. And I have no idea where it's going to go. But I mean, I get to hang out with Ben Gortzel. And that's fun. Yeah. That's the kind of stuff. And that's the really cool side of the space. And it's what I enjoy. In the Vitalik rival thing, the Ethereum thing, I try my best not to mention it. I hate the fact that still when Bloomberg or anybody else writes a story about me, they'll say Ethereum co-founder. Like, can you say something else?
Well, I think if I've learned anything from the internet, you can't resist that kind of stuff. You just have to. It's the Elon. Yeah. No, it's the joke it away. I've noticed this. This is already starting to happen with me. It's like people just make up stuff. They haven't made up anything interesting yet, but they could. And I've seen that with Bill Gates, for example, just stuff being made up. I mean, probably half of it is true. I'm sorry, internet. I'm sorry. But I guess what I realized, this is the dark side of memes, is you can just make something up and it'll spread.
Yeah.
And then that's it. And that's what happens. But then...
And the problem is half the world will believe it.
Yeah. It could be good stuff. It could be bad stuff. So I guess the hope is it balances out in the end. I tend to believe you almost want to play with that and not take it seriously, just kind of laugh it off and enjoy life and keep creating, keep doing awesome stuff.
Right.
Operating both in the physical space with other humans and in the digital space with humans and AI systems, and just have fun. Yeah. Because most of us in the long arc of history will be completely forgotten. None of it will matter. It'll all be some kind of, just like Hitchhiker's Guide to the Galaxy will just be one sentence that summarizes all of our existence. And the sad thing is most of us will not be part of that sentence, or all of us.
Well, thanks for all the fish, Lex.
Thanks for all the fish. The dolphins are running this thing, and they're talking to the UFOs recently, which is very interesting, because the UFOs keep going to the water. So we humans assume that the UFOs are here to visit, the aliens are here to visit us, but it's probably the fish.
No, I just think it's next generation aircraft that we're using.
Oh, that we're just not aware of. But why are they talking to the fish?
Well, that's the place you test hypersonic aircraft is over oceans.
So that's the Russians with their hypersonic nuclear weapons. That's what Lockheed.
Rods from God, man. Rods from God.
So let me try to transition from UFOs to Abraham Lincoln. Lincoln said that nearly all men can stand adversity, but if you want to test a man's character, give him power. Do you think power and money can corrupt most people? And if so, do you worry of this corrupting force on your own mind? You're one of the leading minds in the cryptocurrency space. You're the leader of the Cardano project. You're the king
of the rats.
Of the rats. Does this corrupt your mind, both the power and the money of it?
Yeah, I mean, you see this most pervasively with people who inherit a large amount of money or title, like, dynasties like the Mellons or the Rockefellers or other people. It's the worst thing you can do to somebody is just hand them an enormous amount of power that they're not prepared for. And the challenge with this space is like everybody's young and we're all billionaires now and we have these cult followings and do all these things, right? And nobody really says no to you. Like, for example, I have this ranch up in Wyoming and it has 400 bison on it. So now I'm a bison rancher. Like if somebody was like, monitoring, auditing that, be like, Charles, do you have any experience taking care of bison? I'd be like, no. So you think it's really a good idea to have this ranch with 400 bison running around? What the hell are you going to do with bison? I just have to figure out what I'm going to do with these bison. So, and we'll make a video game. We'll do crypto bison. And you're going to get one.
I'm not pulling. Thank you. I would love to. I'm not pulling at that string just yet. So I'm wondering how you're going to connect this back to power.
Right. And so, but my point is that when you are unrestrained, like literally no one can say no, or you have the ability to distort reality around yourself and you're not constrained by social customs, it creates a situation where you start losing perspective. You're not grounded anymore. I think so. It's less of a question of will you become evil or not. It's more of a question of will you lose so much touch with humanity that you just can't relate or understand people, and then you inadvertently, by your actions, start harming people, either through the policies that you pursue or the things that you start building and so forth. So I think the best inoculation against that is to surround yourself with activities that are utterly divorced from your reputation and status. The best thing are animals and gardening. Because, a donkey doesn't care if you're a billionaire or broke. He'll shit on you exactly the same way.
Yeah.
And so there's a humility behind these types of activities and these things. And there's a honest work component. Like when you grow hay or whatever, you have to plant. You have to actually water, you have to irrigate, you have to actually be there. And if you can't use some excuse, well, I was meeting the president of El Salvador, I was doing this. So like, the hay doesn't give a shit. It's hay, right? So it grounds and connects you. The other thing is you have to get used to giving away. All the best things in my life have come as a consequence of first giving. Like I got started in the cryptocurrency space by giving away a free class, Bitcoin or How I Learned to Stop Worrying or Love Crypto. You did a free podcast, right? In life, if you give, and you develop that mindset of, I'm not attached to the things I have, and if push comes to shove, it goes away. Usually you get more back. Like I gave away all my Ether. I never received any of 293,000 Ether at the all-time high, over $1.2 billion. I gave it to my secretary. I had no idea if it was going to be worth anything or not, but he kind of got shafted. And I was like, well, they don't like me, so they don't like you by the transitive property of relationships, so you're screwed. And he's like, well, I'm going to go back and my wife is probably going to divorce me and all this stuff. And what do I do? And I said, well, I'll give you my Ether. I don't know if it's going to be worth anything. So, he's doing pretty good. But then again, regardless of doing that, I now have Cardano. I have this great career. I've done all these amazing things. So I think that's the single best way of handling power is you have to do things to keep yourself grounded. In case of Washington, he was deeply connected to Mount Vernon. During the Revolutionary War, he was like sending letters talking about the irrigation ditches and the barn and things like that. He was always connected to that. And then also develop a mindset that you're only here temporarily. Everything you have is finite. It's going to go away at some point. No matter how much you want to keep it, you will die, and somebody else will have it. So you live for the next generation. You don't live for yourself. You look to the future and you say, what am I going to leave behind? What am I going to transmit? And then you, in that kind of mindset, always forces you to be more gracious, cooperative, and collaborative with people. All these dictators, they are egomaniacs, and they get connected to these fantasies, and they live for themselves. Look at Xi in China. He's unraveling a power structure that was what made China China today. You know, after Mao, they said we probably shouldn't have another one of those guys, and so they said let's build something where there's checks and balances, and no one person is going to run the whole show, or else it'll descend and regress, and we'll have problems. And then what he's done, he's thinking only about himself, not the best interest of China. So he's systematically unraveling a system they've been embracing for over 40 years. And to what end? After he dies, the next guy who comes in, even as he's super competent, the next guy is going to horrifically abuse that power structure. And the same thing happened with the Romans. After Augustus, the great emperor, then suddenly down the line you have Caligula and Nero and all these other terrible emperors that just destroyed everything that the Republic and the Empire sought to achieve. So you have to think for the future. You have to think in institutions and systems. You have to have things that ground yourself, and you have to be fully prepared to lose everything and give up everything. After I left Ethereum, I had nothing. Okay, reputation was damaged. Not a lot of money. Nobody really wanted to work with me. No one picked up a phone for 2 whole years. It was horrible. And so I was at bedrock in that experience. And now look at where I'm at. I built all the way up to that. And so that wasn't by accident. I had to surround myself with amazing people. Why would amazing people want to surround themselves with me? If I was this narcissistic asshole who just was like, it's me, everything would be a transactional relationship. It would be, okay, we'll get as much as we can and then run away as quickly as possible. Instead, it was, I'm going to invest in you. And maybe I'll win, maybe I won't win, but I'll be the last guy to leave the boat. If we're freezing to death, you get my coat and I'll just deal with the cold. That kind of mindset. You have to have that. I got that from my dad. He got it from his father. My grandfather and great-grandfather, my dad's side grew up in Montana, and they were like products of the Homestead Act. Very rough, Montana. A lot of people died and froze to death up there, or eaten by animals or something, or shot by their neighbors. And nobody investigates anything because it's Montana. So the only way you survive is by taking care of each other and being a good member of that community. And if somebody gets big, you have this implicit desire to go and give back and take care of the community that you came from and invest in that community. Like I came from the mathematical community. I never completed a PhD, but one of the things that I'm doing is I'm going to put $20 million and set up a center to do automated theorem proving. And we're going to heavily invest in lean because I'm super excited about mechanizing math and making a machine understandable. Now, I know all these guys who do this work. There's like all these mathematicians and computer scientists, and no one pays attention to them. And they're kind of like the redheaded stepchildren of mathematics, and they live on the boundaries and periphery. Meanwhile, they're super passionate and they absolutely love what they do. And if only they had the right resources, within 50 or 100 years, what they're doing can probably become the dominant model of how to do mathematics. So I'm now in a position where I have the financial means to take care of these guys. So all I have to do is just call them up and say, hey, would you like to work with? Oh, absolutely. And cut a check and it's done.
So the interesting tension here, so we talked about ways to prevent power from corrupting a human being that's in a leadership position. There's a interesting case in the cryptocurrency space of Bitcoin and Satoshi Nakamoto that's basically doesn't have a leader. So the benefit of a leader is somebody that perhaps even when they don't carry power, maintains a little bit of a flame of vision. I suppose Bitcoin has that with the original work by Satoshi Nakamoto and the sort of that even though it's anonymous, the idea still lives on through the community, but nevertheless, the leader is anonymous. Do you think this is an interesting case study about leadership, is for the leader to maintain anonymity?
It was a saying from Sun Tzu, paraphrasing it, the best leaders are felt but never seen. Yeah. So I think that's exactly right. The less the leader can be in the room, and the more the principles of the leader are in the room, the better for the firm, because what you're doing is creating more leaders that way. You're inspiring the next generation, the next wave, the next circle out to act with those principles, but contribute in their own way and their own flair. And so you gain collective intelligence inside the organization instead of just constraining yourself to however the great the leader can be. The other side of it is if the leader's principles are too strong, so this is the dark side of it, you end up with what's happened to Disney, with Walt Disney after he died. For like 20 years, people said, well, we don't do that because Walt Disney wouldn't do it that way. Or to a lesser extent, Apple. They say, oh, we don't do that because Steve Jobs wouldn't do it that way. Well, he's dead. He's gone. Move on.
So somebody, I think, asked you whether you're a clone or a deep fake, and you said that you admitted you slipped up on video saying that you're a deep fake. On that
I'm actually a poker-playing robot that escaped a lab.
The truth finally comes out. But on that topic, who do you think is Satoshi Nakamoto? Is it possible that you are, in fact, Satoshi Nakamoto?
No. If you have a preponderance of the evidence, I think the most likely candidate would be Adam Back. It's the Occam's razor candidate, and mostly because he's the right place, right time, right age, right skill set. If you look at the design of Bitcoin, the types of decisions like the use of Forth, the scripting language, that was pretty common in English and European pedagogy in the 1980s and 1990s as like an example language for a stack-based assembly, and like little stuff like that, little quirks like that. Also, he created Hashcash, which was the predecessor of proof of work. He just kind of got a chip on his shoulder that Microsoft never did anything with it. So he's probably looking for something. He grew up with all the cypherpunks. He knew of Hal Finney. He knew of all these people. He knew Phil Zimmermann.
Hal Finney.
Well, no, because the code was not good enough. Hal was a Unix, Linux guy. He was a talented programmer. He was a talented developer. The initial code for Bitcoin was developed, it looked like on a Windows machine. Adam worked at Microsoft, go figure. And also it was very academic and it had to be cleaned up and a lot of things had to be patched up and fixed. If a guy like Hal developed it, they probably had less of the, let's use SecP256K1 and these types of things and more of like, hey, let's build this cool engineering thing and we'll figure out the protocol design later on. It just stinks of an older academic, the initial design of Bitcoin and the initial rollout of Bitcoin. And then brilliant people like Greg Maxwell and others, they came and cleaned it all up. And lo and behold, where's Adam? He's like the CEO of the largest Bitcoin development company in the space who's trying to keep working on and building out Bitcoin. And where the hell was Adam when Satoshi was around? I don't think there was any overlap where they were both together at the same period of time. But I mean, if you really care, you can even do this. There's a lovely paper written by the U.S. Army. If you just Google like code stellometry, U.S. Army, it's a technique where you can use ML and a few other things to actually kind of develop a fingerprint for the way that people write code. So all you got to do is take the original Bitcoin source code and then take all the open source repos from around that time period and before and see if there's a match between those two. Now, if he's really good at creating an alias, probably not so good at obfuscating the code that was written. So the odds are that you'd probably find a match to a repo that's connected to a real life human identity, or at least a weaker OPSEC because, you're younger, you have weaker OPSEC.
Do you know if people have tried that?
I don't think anybody's actually done it, but there's actually a beautiful paper. It's like 94% accurate, the code stellometry.
Code stellometry. So I've for various reasons, have worked with people that work on stellometry of natural language.
Okay.
And
I think it matches closest to Nick Szabo if you actually do the written stellometry analysis of Satoshi's writings to Szabo's
So I meant stellometry as a field. I didn't actually look for application for this particular problem. But so you're saying Nick Szabo is the closest match?
Yeah, somebody did it years. I didn't look at if the model was sound or not, but I just remember reading on a Bitcoin talk. And Szabo is another one of the common candidates. Hal Finney, Szabo, and Adam are probably the top three things that people would list.
What do you think about this idea of anonymity, of publishing something anonymously? Would you ever consider publishing a paper? Like you've been part of, the Cardano ecosystem has published a lot of incredible papers. Is there ever a value to publish anonymously?
Well, every paper that goes through the referee process, the authors are ripped off. So you don't actually see the authorship when you submit to the conference. So that's just best practice. But the question is, do you preserve the anonymity post-conference and actually not reveal the author of the paper? It's a detriment for the deals we make because the whole premise of working with our company as an academic is that you're going to have amazing co-authors, and your work is going to appear in great conferences, great journals, and as a consequence, you get tenure. If you publish anonymously, it's like being doing clearance work in high energy physics or something like that. It's like after 30 years of this amazing career working on nuclear weapons and classified reactors, you finish, and then you go to apply for a job, and they're like, so what have you done for the last 30 years? Stuff. Where is it on your CV? Well, I can't really talk about it.
Yeah.
Okay, welcome to community college.
Yeah.
So you get really screwed if you do that. So there's a misalignment of incentives in the academic world towards anonymity. And generally it's only done when you're doing something very controversial or there's a whistleblowing type of a component. It's not typically done for foundational work. And Satoshi was really one of the first things, because if there was Satoshi doxed himself, and I don't think it's possible anymore, but if he or she did that, that's like a Nobel Prize in economics, likely. You're on the short list for that, and there's enormous accolades that would come beyond the monetary incentives of being able to dox yourself. But
that'd be cool if they give a Nobel Prize in economics to an anonymous, to Satoshi Nakamoto.
It's been proposed, and it was turned down.
Fascinating.
Yeah. So, there are a few people in our company that have done pseudonymous publications. If you look at the Chimerical Ledgers paper, it's not a real name. It's a crazy name. It's a pseudonymous publication. But that's usually for throwaway work. There is one project we inherited from an anonymous person, which is fascinating. It's called QAditas. And it's basically an extension of the QAD manifesto from the 90s. And the pseudonym is Bill White. And I think it's some anonymous mathematician, but I can't figure out which one it is. But basically, it's a marketplace for deduction. So it's like this magic machine where you can create incentives for people to write mathematical proofs in Ethereum prover and make some money from it. So there's some cool work that's there, and it's sad that Bill stayed anonymous, because I think that could have been easily published, and there was a lot of really cool things that could have been done with QAditas.
So you did say the success of Cardano, sort of the vision you have is for you to have less and less power over time. So this idea of governance, what's your vision for a decentralized, secure governance system?
So the first thing you have to do is you got to look at meaningful metrics, not vanity metrics. What does it mean to have legitimacy in a governance system? You can build any governance system you want. You have a dictator, right? Like Bob is in charge. It's like whether you like Bob or not, he's in charge. It's not very legitimate. And you can have pure democracy where every single person votes and then nothing ever gets done. County dog catcher is like a 6-year election or something like that. So there's a spectrum there between absolute power to one and perfectly egalitarian power to every single potential participant inside the system. And then the question is, okay, well, how do you handle choice architecture in that? So are you asking your people about every question? Or are you asking your people about a subset of questions related to a particular set of topics, but then they're not allowed to talk about other topics? Like, for example, are they allowed to change the tax rate, but they can't change freedom of speech, that kind of a thing? So the first thing you have to do when you build these types of systems and they get to a certain scale is you have to build some mechanism for people who are interested in governance to self-select and participate. Just create a collection bucket. In Bitcoin, we had Bitcoin Talk and Bitcoin Reddit and these things, and eventually the GitHub repos and these things. There was a place to go if you were interested. And you need some sort of change management system where people who want to evolve the system can write it down in a very careful way. So in Bitcoin's case, it was a Bitcoin improvement proposal. And Ethereum, it's the Ethereum improvement proposal. And for us, it's the SIP, the Cardano improvement proposal. But it's just a structured way of discussing how you wish to change. Then there's a question of, do you want to do this implicitly or explicitly? In the case of Bitcoin and Ethereum, it's an implicit system. So there's no on-chain voting. There's no 5 people said this and 4 people said this, so we do this. In the case of Cardano, we're actually explicitly inviting this. This is one of the biggest differentiators between Cardano, Polkadot, EOS, and these other things, is that we're really serious about governance to the extent that we're actually doing foundational research in e-voting. We're building new voting systems. We're exploring preference voting and quadratic voting. And the long and the short is that we want more and more people to participate in voting for things. And you have to start somewhere. So our hypothesis is we can bootstrap the system with the treasury system. So in Cardano, some of the inflation goes to the block producers, just like any other cryptocurrency, but some goes into a decentralized treasury. She now has over $1 billion of ADA in it. So it's a lot of money. And that treasury is not under my control or the foundation's control. It's actually controlled by the community as a whole. through a program called Catalyst. And so all these people can come together, they can submit spending ballots, and other people who hold data can vote to approve that. What's nice about it is you have a growth engine to improve two axes. One is absolute participation. So increase the amount of people who hold data participating, so the absolute number of people participating. And the other is meaningful participation. So the depth of participation. Did you just show up and vote? Or did you spend hours debating things on IdeaScale, the innovation management platform, interacting with the funding proposal, going back and forth? And there's dozens of little things like that. Now, my hypothesis is if you run this with enough iterations, eventually you get to a certain critical mass, like over 50% absolute participation and a high level of meaningful participation, where you can move beyond funding and you can start actually having meaningful questions about protocol design and improvement proposals and so forth. And then what you can do is you can roll out new voting systems and new social structures, and you can let them start voting on training wheels like system parameters, like, for example, the minimum transaction fee or that K parameter for the amount of stake pools or these types of things. Okay. Then they build enough competency there and they move up a next level and they actually start talking about hard forks using the update system, the hard fork combinator system. See, so that's how you
voting on a hard fork.
Voting on a hard fork. You can't do it unless your social dynamics are right and your voting system is right. And by the way, you also need to write a constitution around the same time, because not all hard forks are created equally. The kinds of things that would add support for a new cryptographic primitive are distinctly different from the kinds of things that would change your monetary policy of the system.
So the constitution would be written, and maybe you can comment on what is the innovation management
it's a company.
system.
So we partnered with a company called IdeaScale, and they run a kind of a side platform. So people who are interested, that's kind of our version of a forum. They sign up, and there's special tools in that platform for discussions that are productive. So they don't descend into kind of like trolley Reddit style conversations, but they're much more focused around how is your product building out. And by the way, we're going to add more infrastructure over time. In fact, our chief of staff, Tamara Hassan, she's working on setting up an incubator and accelerator. And we have lots of cool partners we've talked with in that space. And it's the same concept. Your idea comes in. What enters the system should not be what gets approved on the other side. It should go through some sort of gauntlet, some sort of crucible where you iterate your way through, and there's all kinds of optimizations and upgrades and evolutions and combinations and destructions that occur. And then by the time you get to the other side, either the idea just dies on the vine because it was a bad idea, or it's a significantly stronger, far more fundable thing, and potentially even gets attached with accountability. So you don't just fund the idea, you actually fund the auditor at the same time who actually holds the person accountable, because the blockchain is not a real company. It's an ethereal thing. You need a counterparty to hold someone accountable who's real for that type of stuff and that type of funding. So that's what we're doing this year. It's like we have a whole team of people, partners like Governance Live and IdeaScale, and papers we've written, and about 30, 40,000 people regularly participating in this. So it's a huge social experiment. And we're learning an enormous amount. And then our goal is by the end of the year to have a meaningful percentage of the entire Cardano population inside of it, like 40, 50%. And then once you're at that threshold, now you have democratic majority of the entire system. And you can have a real conversation about, okay, how do we write a constitution for this type of a system?
And sorry to interrupt, but so the Constitution, people still argue about it because natural language, much like poetry, lends itself to multiple interpretations. Is it possible to formalize some of these ideas that reduce the ambiguity?
Everything is old is new again. We were talking about Lojban back in the day, right? So there's definitely formal languages you can use to express these things. That's why I'm so interested in things like Idris and Kak and Agda and theorem proving, because that's exactly what you're attempting to do, is to express some concept or desire or construction in a language that's machine understandable and manipulatable. In particular, how does a system know its own design? So what is the reference of a cryptocurrency? Usually it's a canonical code base, like, here's Bitcoin Core, and the C++ code is the canonical code base. But actually that's not right. You should have specifications, blueprints that are implementation agnostic as your canonical code base. And can your system know those specifications, understand those specifications, and can your change management system be for that? And then can you provide a proof that your client is bisimilar to that specification? So that's 10 years in the future, but that's where you would go with that kind of a concept.
But you're tending towards the formalism.
Eventually, but that's not necessary for the system in the short term. It's good enough just to have anoint a winner and say the Haskell client is that. And then what you basically do is you vote on a SIP, and then once it's approved, then you go and implement that, and there's some mechanism to trigger the update system to update the reference client.
Do you have an example of a SIP, a Cardano improvement proposal?
Like the Curve Benefit Pledge, SIP 007. So the
007.
Yeah, everybody loves that.
Yeah,
I got to change my luggage code now, Lex.
What is that?
So so basically, it just has to do with the pledge. So pledge is a certain amount of ADA that a stake pool operator will set aside and connect to his pool in order to be listed in the registry. And actually, it's connected to how much income you make as a pool operator. So if you set it too high, you have a consolidation and you have lots of pools. If you set it too low, what will happen is larger pools will tend to fragment and actually run multiple instances of themselves. And so there's this delicate parameter that you have to tweak. And so we have a formula for it in our formal specification that's quite involved. And so one of the community members came and said, well, I think we can massively simplify this design and actually get a better result for smaller stake pool operators. Mm-hmm. And so it's SIP 007. And there's actually a lot of conversation and people are thinking about it. And it's just stunning for me because to understand how to write a SIP like this, you actually have to read like 100 pages of mathematical prose in the formal specification. So the guys who wrote it, I was like, fuck yeah, this is great. But that's an example of a SIP, but that's one thing, but it can be as big as, hey, I want to add like quantum resistance to the system, and here's how you do that, like quantum VRF, and I want to put XMSS and all this other stuff. So there's a lot you can do, and you can do it you can do it indirectly or implicitly, where there's some social process outside of the system where you eventually approve a SIP, or you can do it explicitly where you directly vote, or some representative democracy, some group of representatives directly votes, and then once you've decided, it's there. The Constitution is necessary because you need to know the decision threshold. Mm-hmm. Is it supermajority or majority? And also the voting process. Like a lot of policy experts believe that if Brexit was a multi-stage vote, it would have never passed. Because what people would have done the initial stage and all the horrors of Brexit would have been broadcast to society, and then there would have been some reluctance and buyer's remorse on it. And then the second round would have failed or something like that. But because it was just a singular event, it's like they passed it. Now British are all passive aggressive about it. Like, oh, sign. Very well, we shall remove from Europe. And so your voting system has a lot to do with, the outcome you get. The other thing is, what type of voting? Is it just an absolute or is it preference voting? Like, so, you pick your favorite SIP, follow your second favorite SIP or something like that. So Condorcet or Borda are two examples of systems.
Are you a fan of those, like the ranked choice voting?
I love them so much, especially for political diversity, because this whole concept of throwing your vote away. If it's Alice or Bob, you're always going to get South Park did it best, right? The giant the
turd.
Yeah, you know the one.
Turd versus I forget what else. Douche versus turd.
Douche versus turd. South Park. So if it's ranked order, or preference voting, you never have that situation because you always pick your favorite, and you get a lot more diversity on the ballot. But then you have Arrow's paradox and all these other things that come up. So there's no perfect system, and really you have to be comfortable with governance in a game of inches. And you start by some guiding principles, and the guiding principles is more is better, and productive interactions are better than destructive interactions. And you have to be able to quantify those things. As long as you have an engine that allows you to grow in those directions, then you have a lot more people along for the ride when you actually start talking about these bigger and bigger things. The other challenge was that we had to decentralize development of the protocol and the brain of the protocol. Mm-hmm. We have fully decentralized the brain of the protocol. The peer review academic process means that there's now an academic incentive for graduate students, postdocs, and professors to spend enormous amounts of time writing papers in our ecosystem because they want tenure. They want to, and we showed that you can get it. There's been a lot of people who have gotten great academic careers from working with us. So keep adding to that pile of 105 papers. This is great. And that doesn't need Charles Hoskinson. It doesn't need IOHK funding or anything like that. We're already seeing unfunded derivative work from people who are completely disconnected from us writing papers about stuff in our ecosystem. So just continue to develop that, but that's looking good. Decentralized development, we're working on that as well. Our goal is sometime in the next few years to make sure there's at least 3 independent clients, so 3 completely independent dev teams and code bases, and also to get a separation of the commercial clients from the reference code and turn the reference code into like a formal specification, a formal blueprint, and then have that change management be completely decentralized. The core developers are actually voted on, and the SIP process is used to change that, and then some way of proving that your client follows the specification as use of the protocol.
Is there, beyond the Cardano ecosystem, these ideas of distributed governance, do you see ways it could revolutionize politics? Our governments?
Oh, yeah. Like the Ethiopia deal, for example, we have 5 million people that we brought in with the DID system there. That's going to follow them throughout their whole life. Right now, they're high school students, but when they're in their 20s, 30s, they're going to want to use that for e-voting and for payments and so forth.
Can you describe the Ethiopia project? Because that's fascinating.
Yeah. So we spent 4 years in Ethiopia. I went there in 2017 and shook a lot of hands, kissed a lot of babies, and they said, "Oh yeah, we'll have it all done in 6 months." Everything is a lot of fun there, but it takes a little bit longer than you'd think to get anything done, and that's okay. I really love Ethiopia. It's a beautiful country. So we spent 4 years. We trained a whole cohort of developers, and then we started a relationship with the Ministry of Education, and they care a lot about proper credentials. One of the biggest problems they have is when someone graduates, it's really hard for them to prove the quality of the credentials that they have, and it's really hard for them to prove the knowledge that they have. So if you want to be an ICT outsourcer, or how does somebody know that this is a real programmer, or how does somebody really know that this is a real doctor, or whatever the hell you're outsourcing? So they said, can you come and build a digital identity system for credentials? So every student in the country at some point will get a DID, a decentralized identifier, and then you can prove all sorts of things about them, like GPA or what particular diploma they hold or blah, blah, blah. And then the beautiful thing is the way we designed it is it's extensible to include payments, extensible to include proofs about themselves, like are you over the age of 21, that kind of stuff. And then eventually it can be used to link into a cryptocurrency system. In this case, we built it for Cardano. So Atala Prism is the framework we're using for it. Every student will get one. And then those students will be able to use those credentials in the Cardano ecosystem, eventually for DeFi, like lending and so forth. So it's the largest blockchain deal of its kind, and it probably will grow to 20 million people over the next 24 months. The other beautiful thing about Ethiopia that people don't know is the prime minister is a cryptographer. He's in his 40s, 50s, he's a young guy, and he can actually read the papers we write.
Wow.
And so he's a really bright guy, and he's written this beautiful agenda called Digital Ethiopia 2025. And one of his things in the agenda is digital identity. He wants every person in the country to have a digital identity by 2025, and he wants to implement an e-voting system at some point for that. So when you ask about governance, all these governance tools that we're constructing for Cardano are completely reusable for a nation state. A company, and by the way, if you create a Cardano application, will eventually be reusable for you. Because if you have a DeFi protocol, you need a voting system. Why the fuck do you have to re-implement that? Native multi-asset, anything that works on ADA works with a native multi-asset. You can use our voting system for your asset. Mm-hmm. So you get a government in a box that you can parameterize any way you want. And similarly, when a government does something with Cardano, not only do they get all this amazing infrastructure, but wait, there's more. They actually get this amazing voting system that they can use for small or large-scale decisions that they want to do. On the U.S. side, we're thinking about trying to roll something like this out in the state of Wyoming. There's been tons of laws that are passed. It's a very friendly crypto place. At the very least, it'd be fun to see if we can do the Republican-Democrat primaries with preference voting and voter registration this way.
Nice.
And do it completely online with an e-voting system. So, that's something we'll be pursuing in 2022.
You think there's some openness to that?
Yeah. That's the one good thing about the craziness of Trump. He's made like half of America think the election system is completely irreparably broken. So, you walk in, it's like, we're going to go kill Dominion. And they're like, yay, that's great. Let's go do that. Whether you believe that or not, it created a market opportunity, created a lack of faith and credibility in the system.
To improve the system.
Exactly.
What do you think about El Salvador becoming the first country to approve a cryptocurrency, Bitcoin in this case, as legal currency? And where's this trend going? First of all, this event, if we mentioned the Bitcoin conference, the Bitcoin folks believe that this is a monumental event. Do you think this is a start of something new?
Well, they're both right, the critics and the pro people. So the critics are saying this is a nothing burger and it's just a publicity event for El Salvador. And then the people say this is the most monumental event. They may actually be right because there's reciprocal agreements. When a country issues a currency, other countries honor that usually. And it trades on Forex exchanges. So if like Bitcoin becomes a recognized currency of a country, then it may be the case that the United States and the European Union and others can't actually stop them from trading on Forex exchanges and being treated as a currency from a regulatory perspective. So it was like a really clever backdoor into the League of Nations. And actually, we had this crazy harebrained idea years ago. We were down in Mexico at the Satoshi Roundtable, and we're like, hey, let's go buy a country. Let's go to Tuvalu and get them to do something with the cryptocurrency, because they sell everything in Tuvalu, like the .tv extension and their fishing rights, and Taiwan pays them money to recognize them and so forth. So I'm like, man, maybe we can convince Tuvalu to do something with crypto. And that didn't work out so well. But now El Salvador is actually playing the game, and that's a real country. It's got like 5 million people and so forth. So we know the president's brother, and we've had some conversations there. So maybe we'll go, in the next few months and see what's going on there and do a state visit and talk to the president. But it's an interesting development. And it's one of those things that it can't quite be ignored because a nation state's doing it. On the other hand, you have to manage expectations. Is the central bank taking a position in Bitcoin? Are they actually switching over to a cryptocurrency as their unit of account? Are they now getting off of BIS and they're all using the settlement rails of central banks? Are they actually blockchaining the entire country and they have some broad, ambitious agenda to go and do all that? That remains to be seen. And so it really is a commitment there. The other thing is that if you're autocratic, these systems are not so good for you. Because the minute you adopt these types of systems, you're pushing a lot of power to the edges. So there's a world of difference between optics and actual commitment. And actual commitment is I'm prepared to accept the consequences that the state is going to lose a lot of power along the way. And the problem is it's not clear to me if some of these politicians who are pro-blockchain, and I'm not making a statement of El Salvador in particular, I'm just saying in general, are fully aware of that reality. A lot of them seem to think that somehow they can contain the blockchain genie in the bottle and blockchain their whole country, but stay president for life. That doesn't work. Once they have that power, they're gone.
So do you think once they realize that this is one of the failure cases, one of the things that people are concerned about is governments banning cryptocurrency?
Well, that's the China case, right? They started realizing this was a legitimate threat to capital controls and to the autocratic system that they've constructed there. And then suddenly China is starting to build its own People's Bank of China blockchain, and Bitcoin is now the redheaded stepchild. They didn't really care too much because it was great for corruption. You could evade capital controls, and so all the well-connected people, Bitcoin's bad, but then they'd have Bitcoin of their own and they could use it to send money around. But now the government's gotten very serious about it. They're saying okay, we want to control and dominate this whole thing, and it's a threat to our plan for the digital yuan to become the world standard to displace the dollar.
But so the moment you have El Salvador and just more and more countries, say there'll be a country in Europe, for example,
right,
that accepts Bitcoin or other cryptocurrencies, Cardano, the idea is it would put a lot of pressure on the other. So there'll be like this kind of ripple effect,
right,
that and then the individual governments won't be able to help, and eventually there'll be a superpower like, I don't know, Russia or the United States or, I don't know, Canada. So do you see that sort of an inevitable trend where cryptocurrency takes over the world as a store of value and as a method of payments?
Yeah, probably. I mean, you can do just so much more with programmable finance. Transactions in general have 5 properties. You have the asset that runs on the rail. That's what we always think about. And you can transact that, and then you have the identity, and you transact that either like one-to-one, one-to-many, many-to-one, or many-to-many. And then you have metadata. So that's the story of the transactions, like where did it take place, these types of things. And then you have the contractual relationship. So that's the smart contract component. And then you embed that within regulation. So transactions always live within jurisdictions. This is relevant to the conversation, will digital currencies take over? Because those things are right now done separately in a very fragmented and fractured way, and they're not completely globalized. And so it's super expensive to hoist up this entire system and automate things like compliance. It's usually a huge part of every bank's balance sheet. So when you look at the concept of a digital currency, you're saying all 5 of those things are programmable. And so they could be like library driven. You say, I want to be in compliance with Eritrea. Okay, pull up the Eritrean library. Now you are. Built into the transaction. Previously, it's like, go hire some lawyers and go figure out the entire code and translate some things and rah. And it's crazy. Just the orders of magnitude efficiency gains that you get and the increased liquidity you get and the fact that you can now represent all assets with a universal way, that financial stem cell, there's an inevitability to the victory of our industry. The challenge is, how do we deal with this with the squabbling of superpowers?
Right.
China wants to be the new world standard. America wants to preserve that. And the rest of the world is trying to figure out how do we create something that's a bit more fair and balanced. And so crypto comes in, and it potentially is both an ally and a competitor to those desires. Because if you do too much crypto, you don't need the nation state anymore. If you do too little crypto, well, it's China or America. So what's that sweet spot?
Do you hope that in the process of cryptocurrency pushing power to the edges, to the people, that we would be able to alleviate some of the suffering in the world caused by centralized power and the abuses of power and corruption, all those kinds of things?
100%. I made a very angry video months ago. I make angry videos. I shouldn't drink, Lex. I really should.
Maybe you should drink more.
Yeah, I know, right? It depends on who you ask. I made a video a little while. I said, our industry is an industry of frustration. It exists because we weren't the industry that charged 85% interest to the poorest people in the world for loans. We weren't the industry that charged 15% to move money for a maid sending money home to mom in Manila. We weren't the industry that laundered hundreds of billions of dollars of drug money and funded arms dealers in Africa and all these things, or permitted oil for food to exist and so forth. And the people who did these things aren't in jail. They're rich. They're billionaires. They fly private jets. So our industry is the antidote to these types of things. We say, guys, we want a system that's fair. That's it. Mm-hmm. And we want everybody to be treated equally. That doesn't mean everybody's going to win. It doesn't mean that when you lose, somebody's going to come on a white horse and bail you out. You're going to have winners and losers, but it's fair. That's all we want. That's all we've ever wanted. There's no coincidence that Bitcoin was created right around the same time as the 2008 financial crisis. It's not like these were just unrelated events. They're highly correlated to each other, okay? I'd say perhaps even causal. Mm-hmm. Go figure. And everything we've done as an industry from that moment to today and beyond has been about that endless, relentless desire to make things a little bit less corrupt, a little bit less nepotistic, and a bit more open. And it's gotten so insane that you have these things in Wyoming called speedy banks, where you're full reserve banks. They have 100% of their balance sheet is accounted for. They don't lend. And then you have the people in the banking community saying, well, those are a risk to banking. We're scared that these speedy banks are going to default. Mm-hmm. It's like, what world are you living in? You have fractional reserves, sometimes like 2% assets on the balance sheet. And then you're worried that the guys who actually have $1 for every dollar they say they have are the ones that are going to collapse. Mm-hmm. It's like the 1984 level doublespeak when you see in the system, and negative interest rates and all these other things. And so I absolutely believe the direction and course of this industry is to make things more honest and fair. And also, by its very existence, it exposes double standards, hypocrisy, and corruption. Just the fact that it's there. Because it's one thing to say that, well, it just can't be because of the nature of global finance. There's no way to do it otherwise. It's another thing to see it there as an example and say, well, that thing is doing it. Why can't you guys be this way? That's why I'm so passionate about Africa, because they don't like the systems they have, and everybody's really young. And they are going to throw all the systems out in the next 20 years, and they're going to replace them with something else. If we get this stuff into Africa, 1.2 billion people will be living in a considerably better system than the rest of the world. And then everybody else will look at that and say, why the hell are those guys so rich? Why are those guys making the money? Why are those guys doing so well? And it's not satisfying to hear, well, that's, Africa is just better. No one's going to say that. They're going to say, okay, yeah, it's nepotism and corruption and, lack of transparency and these types of things. So I think absolutely it has the potential to improve the human condition, but humans have to get out of the way. Humans have ingrained in themselves selfishness and a desire to maximize for themselves and their family and not think in systems. And so we have to evolve capitalism at the same time. And what I mean by that is right now, you're trying to maximize the amount of resources you get today. What we need to do is start thinking about how do we create future versions of ourselves in 2100 and create a resource for that time period. And then the name of the game is to maximize that or balance that with what you get in the short term. And then suddenly you're saying to yourself, well, if I'm doing things that are good for me today, but compromising then, I make less money. Mm-hmm. So capitalism as an engine is okay. The problem is it's misparameterized.
Right, almost like inject long-term incentives into the capitalist system.
Exactly, and cryptocurrency space is the only economic system where that's actually possible. Mm-hmm. You can create a tokenomics scheme where doing things that are beneficial for people you'll never meet because you're long dead, actually makes you money today. You can't do that in a legacy financial system and so forth. So I think that that's the real impact capital conversation that has to be had as you explore these things is you have to talk to people and say, look, it's not about communism or socialism versus capitalism. It's not about, hey, let's donate and save the world or try to be charity and make things better. It's all about how do you use the fact that we have a better toolkit to create a different system, a different incentive model where the default configuration of the system is long-term thinking. And the default consideration of the system is to get rid of all these negative externalities that marketplaces have and judge the success of society not by how the greatest of society are doing, but by how the least of society are doing. HDI, not GDP, this kind of thinking. And I think crypto can actually be the vanguard that kind of pushes us there. And the first countries to adopt that are going to be just significantly better places to live. And the people who envy them will force the other countries to change.
That'd be a ripple effect. So when you wake up in the morning or as you sleep like a baby, wake up multiple times in the middle of the night, do you feel the burden of this kind of future that's in your hands and not to mess it up? Like, what is it, Big Lebowski? Her life is in your hands, dude.
Don't worry about them. They're nihilists, Donnie.
Do you feel the burden of because we're talking about all these 100+ papers and the academic beauty of the algorithms we're talking about, but then there's millions of human lives at stake here.
I mean, you always feel the burden, especially my own company. I mean, I have all these people work for me and, they eat because I pay them, right? So if I can't pay them, then that's my fault. Yeah, so you have to, as a leader, you always have to be cognizant that there's all these people who have signed up for your crazy vision, and you have to be larger than life. You always have to be good. You're not allowed to have a bad day. You're not allowed to feel like shit. You always have to show up. You always have to be pushing forward. And so that's a huge burden in many respects because there's Charles the person, and then Charles the CEO, and these are very different things. In terms of expectations, at the very least, and so it's heavy in that respect. That said, what gives you solace is that you're not in it alone. It's lonely, but you're not alone. You have so many amazing people around you that are willing to help and actually take some of that burden. And my life has gotten considerably better when I learned how to delegate and trust. And even if people screw up and fail, it's worth the risk because ultimately you're amplifying yourself. The other thing is that it's okay not to get all the way. You want to push there, but make sure whatever the hell you do, you leave something for somebody else to pick up and carry on. That's why we care so much about the publication process and open source code. We'll never file a patent in our entire history because whatever we do, it's yours as much as it is mine. And maybe I can only get you 70% of the way and I'll plop over dead from a heart attack or get killed by an eagle or something like that. Maybe somebody brings the maybe somebody brings the Hast eagle back and it kills me, so it could happen. They're bringing the woolly mammoth back. Talk to George Church about that.
It's a good way to go.
Yeah,
Either
I know.
The eagle or the mammoth.
I'd rather be crushed by a mammoth because eagles actually fly you up and drop you.
So you won't die. It'll be a slow death, and they probably peck at you.
Exactly. You'd just be grievously wounded on the ground, and the eagle's slowly devouring you. Yeah, don't go down that way. I've lost my train of thought.
The point is that you feel deeply grateful. There's a bunch of people around you,
there we
and
go.
then you give.
You delegate, and somebody fights the eagle, and other people takes care of that, and this, that, and the other. You just do the best you can. You're in the arena. You fight as hard as you can. You leave nothing. It's for home. You could put it all on the field. And then when you go home, you have pride in what you've done. And you know that you've at least made a slight difference. And, one person can make a huge difference. Look at Norman Borlaug. I mean, he just went around the whole world teaching people how to grow crops. He saved 1 billion lives over the course of his life. 1 billion people didn't starve to death because of one guy. It's amazing the asymmetry and the returns on that type of a thing, just for the knowledge transfer of all things, and yet not a household name. Mm-hmm. So that's the other side of it, of the burdens. People always want something for something. So they say, if I endured all these burdens, I should be given something. I entered into this space fully expecting that probably the most likely outcome was jail. That's what my dad told me and other people told me. And it was because it's look at where we came from. The Liberty Dollar, E-Gold, all these things. Anybody tries to innovate the monetary system, either end up like Gaddafi or they end up in prison or they end up, like nepotistic corrupt banker or something like that. And so, the financial regulations are not built for rapid innovation. They're not built for Bitcoin. There's a reason Satoshi was anonymous. It wasn't because, he enjoyed anonymity, because there was legitimate criminal risk for this type of activity. So the fact that I've gotten this far and I'm doing pretty good, that's a win. You take that. Life is good.
What does a productive day in the life of Charles Hoskinson look like? Now, we're getting to the details here. Diet, like fasting or not, maybe. Coffee, non-coffee, exercise, sleep, scheduling, like periods of deep work, programming, then the social media stuff that you do.
Right.
You clearly enjoy being on social media, and also live streaming, educating, inspiring the world, or getting drunk and ranting at the computer.
Well, first off, you do a wet year and a dry year. That's what prevents you from becoming an alcoholic. So unfortunately, the way that schedule worked, 2020 was my dry year. Like I didn't drink the entire year. Not a single sip of alcohol. It was the
on
worst.
Purpose.
Yeah. You do a dry year and then you do a wet year.
Oh, so this is one of your ideas about life, is you alternate.
Yeah, you have to alternate. Never do too much of any one thing.
Well, Churchill never alternated. He just kept drinking throughout his life. He did pretty good. just to push back against.
Yeah, him and Alfred North Whitehead. Although didn't Churchill get kicked out as prime minister at some point?
So maybe he should have he took
yeah,
one
he
dry
was a
year.
sober, happy, in shape Churchill. He'd have led it Britain for 30 fucking years. But, see, Lex.
Yeah.
That's why we can't have nice things.
Hunter S. Thompson. Maybe you're onto something.
Oh, it's really crazy if you go to Aspen and see the bar he used to go to. I actually met a waitress who knew him really well, and he'd go in there like 2-3 times a day. And she's like, yeah, he'd do cocaine right here on the table. And he'd come in with lots of pills and just put them all out on the table and be taking them at different hours. And they were all clearly illegal substances, but we just give him coffee or whatever he wanted. He's a great guy. But anyway, yes, the day in the life of Charles. I fast. I try to do intermittent fasting, 16/8. The longest fast I ever did for a long-term fast was 2 weeks, which was just crazy.
Wow.
Oh my God.
Can you take me through the journey of like philosophically what was going on in your mind?
Well, so normally when I do an extended fast, it's about 3-4 days, because that's the sweet spot before you start losing muscle mass and other things start happening. And there's people know so much more about this than I do, but I just feel pretty good. And you kind of get addicted to the fast high. You don't have to eat. You have no downtime. Yep. You're just going. Your energy never dips. And so I used to do like 3-5 days, maybe 3-4 was the sweet spot. But then after about a week, I was like, how long can I make this go? And so I started talking to some people. They said, well, Angus Barbary did 384 days. Of course, I'm not as fat as Angus. So I said, I can do 2 weeks. Yeah. So I just kept going and kept going and kept going and kept going. And right around the 2-week mark, I fainted for a little bit in a chair, and I was like, okay, maybe I should start eating again. But then I was legitimately worried about like refeeding syndrome and this stuff. Like, okay, how do I take care of that? So my brother's a doctor, and I called him and I said, hey, Willie, I haven't eaten in 2 weeks. How do I start eating again? And he's like, well, what? Slowly. Yeah. So in the usual routine, intermittent fasting, although I haven't been as good about it as I should be, and I used to work out, I don't do as much as that. The stress and the work-life balance has been horrible the last 24 months, and I've gained a lot of weight and all that stuff, but I'll fix that. But I do try a lot of things. Like I use the Calm app and I do meditation. Recently, I started doing photobiomodulation. You ever heard of that?
No.
This crazy headset called a V-Light. You saw that picture of me with like the weird thing with the red lights on? It actually shoots lights into your brain. It's really cool stuff, but it improves blood flow. And actually there's some peer-reviewed studies that show that it does neurogenesis. So you actually generate new neurons and things like that. It's really cool stuff. So I do that, and it actually helps a lot. And it's every day's a little different.
Do you get a few hours of like alone time to work, to think?
Yeah, deep work is so important. There's even a book on that, like Deep Work.
Yeah, by Cal Newport.
Yeah, I think you interviewed him, didn't you?
Yeah. Everyone should listen to his podcast, Deep Questions. He's awesome. He's a mathematician, a theoretical computer scientist. So those guys really need their time alone to really think.
That's the one thing I deeply miss. When you're a CEO, you're the master of the 5-minute deal. You come in, you talk to people for a minute, you make a decision, you move on to the next thing, you move on to the next thing. And I used to be used to like really deep focus. You'd sit down and think about something for 10 hours, 15 hours, 20 hours. And that's that. And I enjoyed it. It was just so beautiful to get lost into something and just go and go and go. And then you become a CEO, and it's like you never can go and go. You're lucky if you read a 4-page thing, because there's something else that comes up, you have to travel, you have to do that. So I've been trying lately to have, and actually our chief of staff recommended like Fridays is do not disturb day. So it's for deep work, you don't have meetings, any of these things. And so far I have not committed to that, but everybody else in the organization has started to move there. But my hope is next month that I can actually get serious about that. The other time I'm lost in thought is I do a lot of float tanks. Have you ever done isolation tanks?
No, but I really want to.
It's one of the most amazing things you can do. You come out on the other side and all your stress worries, they're just gone. And you have so much productivity and clarity. If you combine that with daily naps, that's the way to go.
Yeah, I'm a huge fan of naps. So what about the social media stuff and like you doing the live streams? Do you ever dread those? Are you energized by those? So because you're exceptionally good at communicating all the different kinds of ideas and being very transparent with the community, all those kinds of things.
I really enjoy the live streams. It's fun. It's never been a chore because it's for them. It's a chance for people in the community who've been loyal and they really love it to actually just be there, ask some questions. And I try to make it as entertaining as possible. And, you have your trolls and you have your love, and it's actually nice to have a mixture of the two because sometimes you can beat down trolls just for fun, that kind of stuff. And it's grown to a cult following. I think there's like 40, 50,000 people, and it's almost like Fight Club in a certain respect. So I was in Vancouver years ago, and I was at Air Canada checking in, just about to fly back to Colorado, and I was getting this weird vibe from the guy that was checking me in. And then right after he takes my bag, he kind of leans over to me. He's like, "I love Ada," and I was like, "Really?" He's like, "Yeah, I watch your live streams." And then I was flying into London. I was at London Heathrow Airport, and the passport control guy was there, and I was just about to take my passport out, and he says, "Welcome to London, Mr. Hoskinson." I was like, "Oh God, am I going to jail in London? Why does the border patrol guy know who I am? This is a bad deal for me." And it turned out he watched my live streams, and so there's a lot of that and that's so much fun. In fact, here in Austin, I was at a Mexican restaurant just down close to this place. And while eating there, two different people recognized me, and I took a picture with one of them. And again, they watched the live streams. So that's...
Well, if it's anything like Fight Club, you have to wonder if some of those people or all of them are just figments of your imagination.
Right. I would... I don't have an answer for that, Lex.
I could be a figment of your imagination, which just proves that you're
but honestly, if I was capable of that level of delusion, why the hell don't I look like Brad Pitt?
Good point. Okay, so... on this topic, let me ask you about mushrooms. You're interested in mushrooms, growing mushrooms. Mm-hmm. I believe you are also interested in the mind-expanding capabilities of psychedelics. At least you mentioned kind of the interesting place where your interest in non-psychedelic mushrooms might go. Can you explain the nature of your interest in mushrooms? Is it personal? Is it business? Is it both?
Well, it's a little bit of everything. It's just an underexplored area of science and botany that ought to be explored because there's so much cool, interesting stuff there. Mushrooms do so much. Like they have these things called cordyceps, and they are like a zombie fungus that infects insects, takes them over, and then it will have them kind of get to other insects and then burst out of their head like an alien and spray spores on them and repeat the process. I mean, they even made a damn game about this, The Last of Us or something like that. And this is a real thing. Like you can Google it and see like these dead ants with these fungal stabs coming out of them. And it's like, holy God, this is crazy. And in the same topic, you go all the way to lion's mane, and it could actually help treat Alzheimer's and treat depression and Parkinson's and regrow nerves and so forth. Other things, they've shown some effectiveness against COVID. It's just so crazy, the diversity in the mushroom kingdom of the medicinal applications, the pesticide applications. You can use it a lot to kind of save hay and trees. There's a lot of things you can do to combat all kinds of invasive species. And it's true, there's a lot of cool stuff with psychedelic mushrooms. And there's a great book from Michael Pollan, How to Change Your Mind, where he was really the first journalist in a long time to go and roll and Griffiths work his way through the Johns Hopkins studies. But the long and short for me, when I read that book, like, okay, mind expansion is great, but look at the effectiveness of psychedelics, psilocybin mushrooms with SSRIs, selective serotonin reuptake inhibitors, for the treatment of depression. They showed in the Johns Hopkins studies that they're equal or better in effectiveness in many cases.
Yeah, it's fascinating.
For the treatment of depression than a drug that you have to take forever and this is just 1 or 2 treatments, and then you desist from it. That's a miracle, because there's so many people suffer from severe depression, and it's a lifetime ailment. And the fact that we have something in the toolbox that we've underexplored is a very powerful thing. The other thing was end-of-life issues. A lot of people get cancer. I've lost people in the family from cancer. And it's so hard those last 2-3 months, because they kind of like have this, they're in a horrific pain. They're trying to find meaning and why is this happening to me? And if you can just give them a substance that on the other side of it, there's a good chance they can come to peace with everything and die with a lot more dignity and happiness, that alone justifies an enormous amount of study. And the fact that these things are super cheap and they grow pretty much anywhere, it's pretty cool. Mm-hmm. Now, on the commercial side, you can make a lot of money from mushrooms. And I'm working with a company called Farmbox Foods, and it's one of the, they do both vertical hydroponic farming. They also do mushroom, and they put these amazing labs and shipping containers that are kind of like controlled environments. And you grow 400 pounds of gourmet mushrooms a single week off of that, and your margins can be up to 30% per year. If you're just selling them for food consumption, if you're doing supplements, they can be even higher than that. So it just kind of made sense from a diversification of assets to say, hey, let's do some stuff in hydroponics and aquaponics and in mushrooms. But the more I do, the more I learn that community, just the cooler that community is. Like, I went to this beautiful mushroom festival in Cave Springs down in Georgia, and I met this guy named Bill Ewell. And he just looks like a druid, just like he lives in a tree, and he opens up the tree and goes out and everything. And I was like, Bill, what do you do? So I go and I try to study beetles and boletes, and a very particular type of beetle, and they mate in the most crazy way. It's like this beetle will fuse on top of another beetle, and they'll vibrate. And if they make the right harmony, she'll mate with him. Otherwise, they'll kick her off. And you can only make the harmony while you're on a specific type of bolete mushroom. If it's anywhere else, the harmony doesn't. It's like, who the fuck does this? It's like 20 years, 30 years just thinking about goddamn beetles and bolete mushrooms. But that's that community. And they're the happiest people you'll ever meet. And they're just so much fun to talk to. And there's just so much lore there that's not discovered. The other thing is there's a ton of undiscovered mushrooms. So, you go to my ranch up in Wyoming, go out that national forest next to it, you'll probably discover 6 or 7 new species just doing some gene sequencing and things like that. So there's like a gold rush for new things to discover to treat all kinds of things. So love mushrooms, love that community. I think there's a lot of wonderful medicinal properties, and everybody there is just a lot of fun to hang out with. The other passion is aquaponics and hydroponics, and I got a lot more serious after COVID. I go to the supermarket, all the store shelves are barren. And I say, guys, can you imagine if we had a real big thing, what this would be like? We need to have domestic food production. We need to have resilience at the community level. So let's go build a $40-50 million aquaponics facility next to every major city. So at least you have some local production of food and people won't starve to death. Otherwise, it's very bad. And again, the margins are phenomenal there, 20%, 30%, if you actually do it right and alternate your crops properly and so forth. And you can create a lot of high-paying jobs with it as well.
And so you kind of draw a lot of value from staying close to nature in all of these kinds of ways to keeping you humble. Like you said, what is it? The goat is still going to crap on you.
Oh, yeah, the donkeys will shit on you, whether you're broke or a billionaire.
That's a good line. That's the that'll be the line you'll be remembered for, right? If the universe has a sense of humor.
It's a neo Yogi Berra.
So I think mushrooms is a good place to ask about my friend Joe Rogan. So I'll keep folks from the Cardano community keep saying things like Lex podcast first, then Joe Rogan experience. I guess I'm the moon and Joe is Mars in this metaphor. Since I'm a CS person, I can talk a little bit more fluently about cryptocurrency, because fundamentally, cryptocurrency is a computational idea. But then there's somebody like Joe, who's more like an everyman. He does not necessarily know the technical intricacies of cryptocurrencies. And I don't think he's had a cryptocurrency person on.
Didn't he interview Andreas Antonopoulos?
Oh, he did. That's right. Long time ago. But that was almost like, the cryptocurrency space goes through phases. And I think we're in a new era of some kind.
Right.
And how do you talk to Joe about Cardano? How do you talk to Joe about what the heck. I remember somebody tried to explain to him what Dogecoin is. How do you explain this whole space of what Bitcoin is, of where Ethereum is, of where Cardano and smart contracts and some of this proof of work with this proof of stake ideas that we've been talking about?
You don't. What you do is you start with applications that they're interested in. So he's an elk hunter, and so he's probably interested in elk tags, right? So you start there, and you say that whole system can be put on a blockchain, and here's how it's going to be better for you. You say that's what you do. You always connect it to something they know and love, and then once they get that, they say, "Oh, that's really cool." And then they ask, "What else can you do with it? What else can you sell me on it?" And you kind of work your way outwards there. The problem technologists make is they're so damn in love with the technology. They have that tail wagging the dog where they just want to talk about the technology and how incredibly cool it is. And that's fun. It's like talking about math. Oh, God, let's talk about cobordisms. That's fun. All right, yeah. Everybody's eyes glaze over. No, you always have to connect it to the interest of the particular person and what they care about, what they love, what they need. Royalty payments. He's a big guy. He's got the Spotify thing. He's got all these things going on. Intellectual property is probably pretty important to Joe at some juncture. So NFTs. We can talk about this concept of perpetual royalties. So for example, let's say that you create a piece of art. You can build into the token itself a perpetual royalty to something you care about. Maybe every time it sells, it pays it back to you. Or maybe every time it sells, it donates to some clean water charity or something like that. The point is that the actual acquisition of the NFT requires adherence to that smart contract. So people can't deviate from your desire even after you die. So, stuff from Andy Warhol or from Picasso, that can still be generating some donation every time a Picasso sells to something else. You can do that with NFTs. And so he starts thinking, God, what else can I do? I do shows. Maybe I can do my tickets with these types of things. Maybe I can do loyalty points for my fans. So now you got him engaged and he's thinking of all the opportunities for him. And it gives him an incentive to anchor and connect to those concepts. And then over time, he starts asking questions. Well, how do we know it's secure? Mm-hmm. Then we can talk about proof of work or proof of stake or these types of things. Well, so this is how it stays secure if you're really interested. And there's an incentive to have the attention span necessary to do the homework, eat the broccoli, and get over that hill.
But it's also an opportunity, at least it was for me, especially with Bitcoin a while ago, is to take another look at the monetary system. Mm-hmm. Even look at I've been looking quite a bit at the history of the 20th century and sort of look at that history through the perspective of the monetary system, of the gold standard and all those kinds of things. And just add that little layer of consideration of how money can be used to by people in power to control the populace.
Right.
And it's fascinating to look at the history from that perspective, and then that allows you to look at the future of how we can change that in order to empower people. And then of course the governance thing that you're working on is fascinating because, I mean, I don't know, but it seems like a deeply broken aspect of our government is just the voting system. And discussing how that could be revolutionized is fascinating because a lot of conversations end up being on the internet about like number go up, which is like financial side. And to me personally, at least, and I think that's the same for Joe, that's just boring. Like it's the investing, the financial side of it. I know it has a lot of impact, but it's kind of boring.
Right.
Because long-term it's not going to have any impact. If the ideas are strong, long-term it's going to win.
Right.
If the ideas are weak, long-term is going to lose. The ups and downs of the short-term don't matter. That's just like casino games that you play. Speaking of games, video games, got to ask you about those.
Okay.
You mentioned Diablo. Maybe you're a fan of Diablo.
Well, yeah, and Diablo 2 was great.
Do you like
Diablo
Skyrim?
1 was great. Skyrim was great too. Like the Elder Scrolls. I actually bought the game that the Elder Scrolls was based on. Do you know that? So way back in the day, the Elder Scrolls series was inspired by a game called Legends of Valor that I played when I was a little kid. And it doesn't actually have an ending. They ran out of money before they finished it. So they just kind of like put this little thing on and said, okay, but you never finish it. So I actually bought all the intellectual property for the game.
I saw that. I didn't know there was a connection between Legends of Valor.
Yeah. Well, I forget the name. The guy, was it Todd something at Bethesda? Mm-hmm. He played it. He was inspired by it. And then he created Arena right after playing it.
That was such a good game. Arena, Daggerfall. Yeah.
I had a copy of Daggerfall when I was a kid, but it had a bug, and so when you left the dungeon, it would crash. And this was before, like, you can get an easy patch for it. So I never actually played Daggerfall. I entered in through Morrowind.
Yeah, no, the Daggerfall was the fascinating thing. We're jumping all over, but we'll return to Legends of Alex. I want to ask you about that. But Daggerfall was fascinating because I think of all the Elder Scroll games, it was like the largest because it was like randomly generated.
Right.
It would like randomly generate the worlds, the dungeons, and so on, which is fascinating to think about. Like, how big can you make the world, both in actuality and feel? Like, it's incredible to have a video game. I don't know how many video games do this well, where the feeling is you can be lost here forever. You can live here, because most video games have like a bottom. It feels like you can run out of stuff. With Daggerfall was like, I could just keep doing this.
Right.
At least that's what I felt at the time. But yeah, why? What the heck? Legends of Valor. What's the idea there?
Well, I mean, there's really nothing about it that's super compelling today. I mean, there's a nostalgia of youth that's there, but I mean, it doesn't even have a class system, a level system. The combat system is terrible. There's no journal. The magic system is terrible, and so forth. And so I just wanted to start somewhere, and I felt like that would be an incredibly fun overhaul project. I kind of got the idea from Beamdog Studios when they did another one of my favorite games. Remember Baldur's Gate?
Mm-hmm.
Yeah, and they did
I love that Baldur's Gate 2.
Oh yeah, the enhanced edition was great. They should have never just done Throne of Ball. They should have done an actual proper sequel and gone down that whole road. But anyway, I got the idea there. I said, well, take some old piece of IP and then you can kind of retrofit it and clean it up. And what's nice about Legends of Valor is it's a blank slate. You can do your own Elder Scrolls. You can create your own class system and level system and so forth. You could write some beautiful, exciting, fun narratives for that. And also it gives me a chance to explore a lot of things I think should be dragged into game development, like algorithmically generated music is one example. Nice. The problem with sound games, as you mentioned, you play lots and lots of hours, but your sound content is much smaller. So you have tons of repetition in the soundtrack. So what if you could connect the music to the state of the game world and it automatically through some process will generate music? And there's actually people who study this, and so that's one dimension. The other thing is you have things like GPT-3 and so forth. There was a great game, Event Zero, and it came out like 2016 where you could actually have a dialogue with an AI and you're like a marooned astronaut on a space station that's abandoned. And you have to somehow work with this AI through communicating with it to convince you to take you home. But the AI is a bit duplicitous, and I don't want to spoil the plot of the game because it's such a cool game, but it's actually like a paint by numbers. It's almost like Zork, where you don't have pre-selected dialogue. You actually type in the terminal and the AI will reply to you back and forth. And this was 2016. And it's like things have gotten an order of magnitude better. So the evolution of that tech, I think within the next 5 years brought into video games, could give you incredibly cool dialogue inside the game. So algorithmically generated music, better dialogue, better gameplay mechanics. Also, I'd love to explore alternative physics systems, alternative geometries like, hyperbolic geometry or these types of things. And there's actually Hyperbolica is a game that does that.
Wow.
And you can do down the Euclidean geometry as well and bring those elements into a game design. And that's what we'll do with Legends of Valor. So it'll be kind of like Skyrim, but with a lot of really cool new shit. It's kind of like, I saw Aerosmith years ago and he was out there. He's like, do you like the old shit? Do you like new shit? Kind of middle shit, So
you're going for the middle.
Yeah, I'm gonna try to do some of the old and some of the new, and bring it in. So that'll be a lot of fun. And what's nice about it is that there's a lot of new play in the market because of the Microsoft acquisition of Bethesda. Mm-hmm. They've been losing employees like crazy, and there's a lot of belief that Elder Scrolls 6 will not live up to expectations because Microsoft will kill it.
I will tweet it. Okay, listen to me. I will go into, I'm all about love on the internet, but I will go hard at you, Microsoft, if you screw up Elder Scrolls.
Well, we might have to do a spiritual successor, right? And it might have to happen with Legends of Valor. You never know.
Right.
But it's a passion project, so I have no time for it at all. It's like so low on my list of things to do. So I'll probably do it in 2022, 2023, and we'll build a nice crew, and we'll do it in Wyoming, probably in Wheatland or some really small town, and we'll import everybody, and then we'll have to build the whole city up like Elon is doing here in Texas. It'll be a fun project.
Well, I like programmatically generated music. You mentioned Baldur's Gate.
There's, by the way, Haskell frameworks for that. Euterpe is one.
For generating music?
Yeah, for doing it. I
wonder how successful that could be, because I remember Baldur's Gate was the first game where I realized music is so important to the game. It was the thing I remembered about the game. It was the reason that it was the thing I thought about when I was away from the game. is like that, the feeling it created, that music. I don't even remember the music anymore, but I remember the music was...
Jeremy Soule, I think, was the composer.
Yeah.
It was great. And actually getting like Raman Djawadi or Bear McCready in to do that, it would be so cool.
Okay, this is awesome. Ridiculous question. What's the, maybe let's say, top 3 greatest video games of all time?
Baldur's Gate's definitely in the top 3. Arcanum is my favorite game. And Arcanum was, Troika Games was just this amazing studio where they took the time to build probably the most compelling game worlds. In the case of Arcanum, it takes place in kind of like a 19th century Victorian England play, so steampunk. But then there's also magic inside this game world. And there's this crazy juxtaposition between magic and technology. And the more technology you have, magic stops working. The more magic you have, it disrupts technology. So all the people on the magic side hate the technology people and vice versa. And so you're just this character in this game world, and you're just trying to figure out, like, where do you fit? And it has this incredible plot where you're kind of just a stowaway on a Zeppelin that gets shot down, and you get dragged into this conspiracy, and you have to kind of figure out the conspiracy as you go through the whole game world. And you meet all these different races, like the elves and the dwarves and so forth, and they've all been impacted by the proliferation of technology in different ways. Like the humans use steam engines to clear cut all the forest, and it caused a lot of problems. The dwarves leaked that technology to the humans, and so they kind of got exiled for it and so forth. And you have to decide, like, where do you fit in all this? And you have a lot of choices as a player. You can be on the magic side, the technology side, kind of be neutral. And there's like 40 different endings for the game. It's just incredible. And this is all like 2000. And then you talk about a procedurally generated world. You have a quick travel, but if you want, you can just walk and the world randomly generates. But it's not like Daggerfall where there was interesting things along the way. So it was really ahead of its time. And it was kind of the last of a generation of games. It was based on the same framework that Interplay used for Fallout, the original Fallout and Fallout 2. So that was really a cool setup.
So how were the graphics? They were not essential to
it's isometric, top down. So
cool.
Yeah, kind of like the Fallout look. And so it doesn't hold up super well today, but that was never the point. It was more of a story-driven game. But it was one of the very few games where at the very end of the game, you could actually talk the villain into killing himself instead of fighting you. If you had to really work at it, you had to become a master of persuasion and get your charisma score maxed out and learn all this stuff along the way. And you have this philosophical debate over the nature of life and death with him.
That's amazing.
Yeah, and then you're just like, by the way, you're wrong, and here's why. And he's like, oh yeah, you got a point. I'm just going to kill myself. And I was like, wow, this is great. Planescape Torment is the other one I think is probably the greatest.
What's it called? Planescape?
Yeah, it's another one on the Infinity Engine, which was what was used for Baldur's Gate. So it looks like Baldur's Gate. And God, that was such an incredibly well-written game. You play this character called the Nameless One, this little blue guy, and you wake up in a morgue, and it turns out that you're immortal, and every time you die, you lose all your memories. And so you've just been apparently living this life for a very long time, and you meet all these people in this crazy city called Sigil who know you, but you don't know yourself, and you're trying to figure out your name, your identity, and why do you have this curse where you live forever, but you keep forgetting every time you get killed. And it turns out you weren't such a nice person throughout this entire game world. But then again, it's this question of, well, if you can start over and you lose all your memories, do you have a chance for redemption or not? So it's an incredible game, Planescape Torment. And it's actually another one of those games where you can never actually have a fight. You can just kind of talk your way out of everything. And there's probably like 1,000 pages of dialogue inside the game. Those guys had a lot of fun and a lot of drugs making that game.
Do you think these 3 games are the kinds that would still be okay to play today, or are they forever lost in time because we sort of got desensitized to the richness of computer graphics and all those kinds of things in modern games?
I think you can enhance these games because your storytelling medium is so much more engaging. You know, I was at the movie theater before COVID, and the person to the left of me was looking at their cell phone during the movie, and the person to the right of me was looking at their cell phone. They're just not engaged anymore. Everybody is attention starved. And the video game is one of the last mediums where you have undivided attention of people. They're really into it, man. They're all into that thing. And so I think the fact that you have VR and AR and enhanced graphics and all these new gameplay mechanics, it's a value add instead of a value negative. Because ultimately, what are you doing? You're telling stories. And you're trying to connect people to something. Maybe it's the nature of life and death, or are we truly real? Or are we in a simulation or not? Or something like, it'd be great to do 13th Floor as a game or something like that. And the question is, well, how good of a story can you tell? Well, you're constrained by your storytelling tools and technology. The fact that games are so much more advanced now means that you now have many more dimensions of storytelling available to you. And actually with AI now coming in, and really good AI coming in the next 5 or 10 years, your storytelling is not static anymore. The person can actually majorly participate and change the outcome in ways that were previously unpredictable. The other thing is they're still educational. You can teach people concepts that they never knew before. And it's like if you want to teach people about bizarre geometries, or like Minecraft is a great example. A lot of people learned how computers worked from redstone. Think about that. It's true.
Yeah.
Yeah.
Yeah, as we said, we're more and more going to be living in video game worlds. Might as well sort of, as opposed to just make it fun, also expand our knowledge, expand our ability to think, explore different ideas, and do education broadly defined within those video game worlds. So we can do the entirety of life in the video game worlds. Hopefully it doesn't look like Minecraft, but we'll see. Do you have advice for young people today, aside from playing lots of video games? High schoolers, college students, thinking about their career, thinking about life.
Well, we no longer live in a world where you get one skill set, you do it for 40 years and retire. I mean, that ship has sailed a long time ago. So learn how to learn, and learn an appreciation and love for learning. So that's the first thing. Josh Waitzkins wrote this beautiful book, The Art of Learning, if you ever read it.
Yeah.
Stuff like that. So good study skills, slip box notes, these things. What was it? Zettelkasten or whatever it is. Yeah, there's a lot of little techniques that you can pick up along the way. And basically, they teach you how to process lots of information very quickly, retain it, and then decide what's useful to you for that moment. The second thing is, do not undervalue EQ, emotional intelligence. We've lived for a long time in a society where IQ was dominant. It's like how smart you are excuses everything else. You could be a horrible human being, but he's a really bright guy, right? The asshole mathematician or physicist. We now live in a world where the balance is far more important. You have to be smart, but you also have to be a nice guy. And don't undervalue that. So learn things like closed circuit communication and active listening. These skill sets will always pay enormous dividends along the way. Third, remember that you're judged for the things that you have and what you do with those things. If you have very little, you still have to do something. If you have a lot, you have to do even more. So learn how to give, and do that early on. Learn how to give back. Volunteerism, charity, mentoring, these types of things. Those are so incredibly valuable to a person's development. The people that you mentored in the academic world, you learn this. You have graduate students. They one day will be professors, and it might just so happen they might eclipse you. Remember, Gauss had a doctoral advisor. Never forget that. And so did Feynman. Make sure that you mentor people, you give back, and you learn how to learn, and you learn how to teach. Super important for your development as a person. Now, you'll notice all those things are agnostic to whatever domain you happen to have chosen. You could be in medicine or law or technology, whatever. That's your fancy, whatever your passion happens to be. And don't conflate your earning and your career. If people try to keep putting these things together, they're increasingly becoming decoupled. There's a lot of cases where people do their passions and they do it for free or, for sustenance, but then they have something else they do on the side to also augment or supplement their income. It's probably best that way. When you conflate the two, you tend to get burnt out terribly. You see this a lot with musicians or other people. They want to make music, but they have to tour or whatever because they got to pay bills. Stuff like that happens. Other than that, I'm not a guru. I'm not in any particular position to.
You showed up in a robe, which I thought was kind of weird, and you had a crown, and you kept calling yourself king.
King of the rats. And that wasn't a robe. That was a yukata.
Okay, thank you for clarifying.
Wait, audience, he's joking. Reddit.
I heard somebody's going to write blog posts. Charles Hoskinson walks around with a crown. Let me ask you a ridiculously big and the most important question. What's the meaning of this whole thing of life?
Well, I got a story for that.
Does this have something to do with a farm?
Well, no. It's from Japan. I used to live in Japan. I live in Osaka, next to Namba. Beautiful area. It's like, if you're going to live anywhere in Japan, live in Osaka. You live anywhere in Osaka, live next to the restaurant district. At 4:00 in the morning, you can get good ramen. these are the things in life that make you who you are. So there was a shogun, and he was kind of a badass. He was really good at killing people, really good at running his empire. And then he got a bit disgruntled in his late 40s. And he said, I'm just going to give it all to my son, and I'm going to wander around Japan until I find the perfect cherry blossom. That's what I'm going to do. Everybody thought he went crazy. He said, no, that's what I'm going to do. And he took his whole entourage with him. And his son is now the shogun. And then he's just wandering throughout Japan and having all these incredible, crazy adventures as he's wandering throughout Japan. Fighting bandits and loving beautiful women and so forth. And then 30 years later, he's passing these two geisha gals, and one of them turns around and they notice him slumped over next to a cherry tree. And so she goes over to try to rouse him, and he's dead. And in his hands is a wilted cherry blossom. So that's a very Japanese story, right? The point is that it's not the actual blossom finding the perfection that matters. It's the things you do on a day-to-day basis, the places you go, the people you meet, the experiences you have, and the joy you take in the things that you do here in the moment now. You have to get there. If you look at Jiro Dreams of Sushi, there's this guy, 70 years of his life, making the same damn piece of sushi again and again and again. He's the happiest guy around. Albert Camus in his story of Sisyphus. Sisyphus should be miserable. It's the Greek curse. No, he's happy. He has total clarity of purpose. And every day he gets to basically roll that stone just a little bit better than the day before, a different way than the day before. And it's not the destination. It isn't getting the stone up at the top of the hill that matters. It's the fact that the act, you find that joy in that act, that ikigai, that way of life, that purpose of life. That, I think, is the closest thing a human can get to a meaning. You're a blip. You didn't exist. You're dead. And if you compare it to the size of the universe in that time, it's just a little blip. So all you can do with what you have is just find meaning in the things that you do on a daily basis. And you can't predict the macro. We have all this wealth and power in America. What if a world war breaks out? We could be destitute like Wehrmacht Germany. And so, you could be a big guy. You could be now living on the street side. Would you be miserable? The point of life is getting to a point that no matter what comes your way, what misfortune comes your way, you're in a position where you can find a modicum of happiness and love and empathy for others in that moment. Mm. And then the highest pursuit of life is the ability to share that mindset with other people and give it to them somehow. And that's really hard, because everybody comes to you, they're always Eeyore, doom and gloom and cynical, but this and that, and reputation this, and that. You have to somehow transcend all of it and say, that doesn't matter. Look at the cherry blossoms. Aren't they beautiful today? And let's find a better one tomorrow.
See, you're also a fan of fishing, I read somewhere.
Yeah.
And one of my favorite books is Old Man in the Sea, where there's an old man sort of battling a big fish and basically closing out the last chapter of his life in this battle. So I think another aspect of life with this boulder, it feels like the boulder gets bigger and bigger as we get closer to death. And, you find yourself married to a particular struggle in life that eventually just kind of overtakes the entirety of meaning of your existence. Do you think, I know what it is for me, do you have something like that? The broader vision that unites your work with Cardano and everything you've done in life, the big fish that you're going to end up in the dark of night struggling with at the end, the last chapter of your life, like the big problem you're taking on?
Well, in mathematics, it was the Goldbach conjecture. I'd like to prove that. That's probably not.
That's a really big fish. So do you still have a love for mathematics?
Oh God, yeah, of course I do. You never lose that. You never lose it. You lose the ability to do deep work, and you don't have the creativity and the raw inspiration. This is why I've gotten into automated theorem proving, because what I lack because I'm getting older, I can now have computers understand it and use AI to just solve this stuff. It's like the cheat codes for math, so fuck those guys. We'll still do that. But, mathematics still has those last passions, and, there's all kinds of cool things that I'd like to see done. Like quota complexes allow you to unify topology and number theory in really novel ways. And there are all kinds of cool things, but who cares? It's everybody has those white whales. Another thing I love to do is bring back the woolly mammoth. That's George Church's, hidden pleasure. In 5 to 10 years, it's actually going to happen. And I have this beautiful ranch in Wyoming, and I got to find a way to convince George to let me raise his clone mammothants on my ranch.
Among the bison.
Among the bison. They'd probably get along really well. And then I have to learn all these cool things about woolly mammoths. Like, do you shave them in the summertime and let them get shaggy during the winter? Or do you just let that coat go and then it falls? Who knows? It's an undiscovered country.
I just had the image of Charles Hoskinson alone on a bison farm trying to raise a woolly mammoth, and
just start wearing a white suit and say, "Welcome to Hoskinson Ranch." I'll have a cane with amber on it.
Yeah, with a chalkboard that you keep scrambling on, like the Beautiful Mind, the movie, and you'll have voices.
Oh, the schizophrenia has already come. You guys are all figments of my imagination, anyway. Now, one of my goals, though, I love catfish, and they live a long time. They get really damn big if you see those guys. Yeah. I'd love to catch one now and be in my 60s and catch the same fish twice and recognize it. Maybe I'll lift a scar or something. That'd be really cool. Going back to the fish thing,
Yeah.
Because both the fish has gone through a lot, I've gone through a lot, and we can just be like old
reminisce.
Friends. Exactly. Yeah. Exactly.
And then
I'll die of a heart attack, and my mammoths will eat me.
That's something to look forward to. Charles, this was one of the most amazing conversations I've ever had. It's truly an honor that you would spend your valuable time with me. And I'm glad you exist in the cryptocurrency and the technology space. And I can see your love for mathematics and your love for life just radiate through everything you do. So thank you for being you. And thank you for talking to me today.
This was a lot of fun. Thank you so much, Lex.
Thanks for listening to this conversation with Charles Hoskinson. And thank you to Gala Games, Allform, Indeed, ExpressVPN, and 8 Sleep. Check them out in the description to support this podcast. And now, let me leave you with some words from William Faulkner. You cannot swim for new horizons until you have the courage to lose sight of the shore. Thank you for listening, and I hope to see you next time.